Let's start simple. Think about the last time you booked a cab on Uber, paid through UPI, or asked Alexa to play your favorite music. Or maybe you sent a message on WhatsApp and saw it instantly appear on other device. Behind these everyday movements, one technology is working silently in the background. That is cloud computing. In fact, many digital services we now take for granted like navigation, payment, virtual assistant wouldn't exist without cloud. So, what is this cloud computing? Putting it simple, it's a delivery of computing services like storage, servers, databases, networking, and software over the internet. Instead of owning bulky hardware or investing in expensive tech stack, businesses rent these resources on demand. It's flexible, scalable, and cost effective, making it the backbone of digital world. According to Gartner, global spending on public cloud services is expected to exceed $679 billion in 2024. More than 90% of the enterprises use cloud technology in some form, whether for hosting applications, storing data, or running analytics. It's not just big companies or startups, even small businesses also adopt the cloud to compete with heavy upfront cost. Looking at this growing demand, we have created this course. In this course, we will explore what the cloud is, how it works, and the type of services it offers, and why it matters for everyone. So let's get started without any further ado.
How to become a cloud engineer in 2025? Cloud computing has become one of the rapidly growing tech industries worldwide. From Netflix to Spotify and our own personal Google Drive, Gmail, and photos. Cloud computing has created a new normal in how we store, process, and manage data. Now, due to such a high growth rate, having at least the bare minimum knowledge of cloud is going to become a necessity in the near future. This video is designed for absolute beginners who want to get an overview of what their cloud journey can look like. And that is because everybody has a different learning curve. The roadmap provided in this particular video stretches over 4 months, which is the minimum. If you have any prior knowledge of working with cloud, certain steps may seem too basic, so feel free to skip them. Month 1, Foundation and Basics. Start with networking fundamentals. Understand important networking concepts such as IP addressing, DNS, HTTP, HTTPS, subnets, etc. Next, install and use free tools like Cisco Packet Tracer and Wireshark for a solid hands-on practice. You can refer to free courses like Networking Concepts for Beginners, Introduction to Networking for Complete Beginners, and Basics of Computer Networking. For week 2, focus on Linux basics. Learn the important Linux concepts such as file handling, SSH, and process management. Refer to free courses like Linux Basics for Beginners, Linux for Beginners Crash Course, and Introduction to Linux Full Course for Beginners. If you want to use the Linux operating system on your PC, you can use free tools like VMware and VirtualBox. However, avoid using these if your system has lower specs, as they can significantly slow down your systems. For week 3 and 4, learn a basic programming language, preferably Python. You can refer to the Python full course for beginners. If Python is not your cup of tea, then you can even go with JavaScript or Java. So to sum up, by the end of month 1, you'll have a basic understanding of networking, Linux basics, and a programming language. Month 2, AWS core services. Now that you have a good grasp of the basics, we can proceed to creating an AWS account. Don't worry, you'll get to use the AWS free tier for a year. Explore virtual machines on cloud, cloud storage, databases, security services, and networking subnets and security groups. Don't dive too deep into any of these services, just understand the basics, like what they're used for or how they function, etc. You can refer to our AWS full course for 2024. Now that you have a good grip on cloud, it would be a good time to get an official validation. Start by preparing for the AWS Certified Cloud Practitioner certification. You can refer to the Cloud Practitioner Essentials free course and take up study guides and mock exams to better prepare. Remember that you only need to start preparing for the certifications. You can take the exam whenever you feel ready. Month 3, Hands-on project. For the initial 3 weeks, focus on building projects. Start with basic projects like hosting a static website or building a serverless API. Later, move on to develop more advanced projects, like a full-fledged scalable web application by combining the various AWS services that you would have worked with. If you need help building any of these projects, you can use the step-by-step tutorials available on YouTube. In the last week, learn the basics of Terraform, where you will get to apply the programming language you learned in the beginning. You will learn to apply it in the form of infrastructure as a code. You can choose to learn AWS Terraform, Azure Terraform, or take up the Terraform full course available for free on this channel. By the end of month 3, you will have at least 2-3 projects that can demonstrate your real-world cloud knowledge. Month 4, portfolio, and job preparation. Actively participate in workshops and make connections, along with earning certifications. And don't forget to update your progress continuously on LinkedIn to build even more connections. Towards the end of the last month, start applying for various fresher job positions, such as junior cloud engineer, cloud support engineer, cloud operations analyst, and infrastructure associate. And yeah, don't forget to practice system design interview questions. So by the end of month 4, you'll have a polished GitHub account, a tailored resume, and you'll be actively applying for jobs. Now, doing this on your own can be challenging. Being highly disciplined is not that easy. However, if you had a personal mentor who could guide you through every step, actively resolve all your queries, and at the end, not only arrange your job interviews, but also help you crack them, well, that's where Intellipaat's advanced certification in cloud computing and DevOps course steps in. Here, you'll be taught and mentored by the top IIT professors and industry experts who are actively working in both the cloud computing and DevOps field.
Alright, so let's begin with a question. When was the last time you actually bought a DVD to watch a movie or carried a USB drive just to store your files? Come on, think about it. Alright, let me answer this for you. Probably a while ago, right? And why is that? Well, nowadays we simply stream movies on platforms like Netflix or Amazon Prime, where there is no need to download files or worry about running out of space. Just one click and boom, instant entertainment whenever you want, wherever you want. And it's the same with storing files as well. We just save the files over the Google Drive or Dropbox, where there is no need to panic over losing that USB or carrying extra devices around. Everything is just there whenever you need it. Now here's the fun part. This is what cloud computing looks in the action. And you have already been using the cloud in your day-to-day life without even realizing it. Like through the movies you stream, the files you save online, all of it is powered by cloud technology working silently into the background. Okay, let's make it even simpler with another example. So, think about how you listen to your favorite music nowadays. Do you still keep a giant collection of CDs or download every song onto your phone? Nope. Right. Chances are you just open your favorite music streaming app such as Spotify, Apple Music or YouTube, tap on the song you want and voila. Just instant music anywhere, anytime without worrying about storage or device space. Now, why am I talking about music and movies? Because that's exactly what cloud computing does for businesses and individuals as well. But instead of streaming songs or movies, you are getting instant access to the computing power, storage, software and much more all on your demand. Now imagine if a business had to buy and maintain massive servers and hardware for every little task. It is expensive, right? Not to mention the time and effort to manage it all. But with cloud computing, they don't have to do such a hassle. They can just rent what they need, like how you stream a song without buying the whole album. There is no maintenance worries or bulky equipments, right? No bulky equipments, right? Just instant access to the powerful resources whenever you need them. Now that is pretty cool. Cloud computing is like having a magical toolbox that's always stocked up with exactly what you need, without you ever having to carry it around. Now that we have seen how familiar these cloud-powered services already are into the day-to-day lives, let's dive into what cloud computing really is and why it is becoming such a game changer for businesses, startups, and individuals alike. So let's move forward with understanding what exactly is cloud computing. By the formal definition of the cloud computing, it is the delivery of on-demand computing services and resources like storage, computing power, networking, security, and more via the internet. And it operates on a pay-as-you-go basis. But what does that mean in simpler terms? For that, think of it this way. Normally, when you store your photos, documents, or apps, you save them on your computer or a local device, right? Or maybe you use external hard drives or USB sticks to keep them safe. Well, cloud computing flips that. Instead of storing all your stuff on a physical device that you own, you can save it on the internet. It acts like a virtual storage space that's available anywhere and anytime on demand. Now here's the cool part. Just like you don't need to own the movies or music you stream on Netflix or Spotify, you don't need to own all the equipment or servers to store or process data with cloud computing. Here you can just rent these resources whenever you need them and actually only pay for what you use. Think of it like a subscription to power up your business or personal projects without the need for huge upfront costs. Now let's take a look at the diagram of cloud architecture. This will show you how cloud computing services are structured. You will see how different elements work together to provide computing resources in a seamless and a scalable way. In the cloud, there are several key components. First is clients. As you can see, this end line over here, it is even written, and users. These are the users or devices accessing the cloud services, like from your laptop, mobile phones, or from the desktops as well. Then comes this internet highway. This is the highway that connects everything, allowing you to access the cloud anytime and anywhere with unstable internet connection. Then comes the cloud service layer. This is where all the computing resources are live, such as storage, servers, networks, and security tools, and many more things, which is provided by the cloud service providers, by the companies like AWS, GCP, Microsoft Azure that manage the cloud infrastructure and provides the resources. So this was it for the cloud computing architecture diagram. So yeah, with cloud computing, the internet becomes like your personal virtual space where you can store, process, and access anything you need without ever worrying about managing the hardware yourself. It's like renting a super powerful computer that's always ready to serve you. But wait, how does this all actually work? Why is everyone from fresh startups to the biggest tech giants moving to the cloud? And what makes it such a game changer for businesses? Well, that's exactly what we are going to break down in the coming topics. Let's start by looking at how things used to be done before cloud became a thing. In the past, businesses had to do it really hard way. Let's say you start a company. The first thing you would need to buy is tons of expensive servers and hardwares. And not just that, you would need to constantly maintain and upgrade these servers to make sure everything is running smoothly, which could really be an headache. And then you can launch your product successfully into the market. Now imagine your product gains the traction and more people are starting using it. Great, isn't it? But here's the problem. As the product grows, so does the databases. And more data means more servers. So what's next? The company has to spend even more money buying extra servers to keep up with the demand of the traffic. But here's the catch. As you add more servers, the risk of server crashing also increases, especially if the traffic spikes suddenly. So now you got a big problem. Your servers are overloaded and when they break down, you can't just wait around and sit there, right? To get things back on the track, you need a maintenance team to fix everything, to patch the servers and make sure nothing crashes again and everything works just fine. But this sounds expensive, doesn't it? Not to mention it's incredibly time consuming. You need to have experts available around the clock to keep those servers running, and this process could take days or even weeks to fix every time. Imagine how much time and money gets wasted in this process. Now, there comes another scenario. Let's say the traffic slows down over the time. The extra servers you bought earlier, well, what about them? Now they are just sitting there wasting resources. But here's the kicker. You still have to maintain them regularly, which means extra charges for something you're not even using fully. This is the classic problem businesses used to face. Spending money on servers they didn't need or use all the time, but still they had to maintain them. So, to sum up the traditional setup, businesses and companies had to buy, maintain and upgrade expensive physical servers, which comes along with huge costs for expensive hardware and software, maintenance and IT teams, offering limited flexibility as upgrading as per the traffic spike means buying new hardware every time, which is a time-consuming approach as setting up and updating servers might take weeks or even months sometimes. The result? A lot of wasted time and money for businesses just to keep things running. And that's exactly where cloud computing steps in. Imagine starting a business today. Would you rather spend thousands of dollars buying servers and hiring teams to manage and maintain them? Or would you prefer to just rent the services and resources as you need on demand and only pay for what you actually use? Sounds pretty simple yet super efficient, isn't it? Well, that's the power of the cloud. With cloud computing, you don't need to worry about cost and hassle of owning and managing hardwares like servers. You just rent exactly what you need from a cloud provider whenever you need it and on a pay-as-you-go basis. So what makes the cloud such a game changer for businesses? Here's why. It makes them more agile, cost-efficient and scalable by providing a pay-as-you-go model where they don't need to invest huge upfront investments. They can only pay for what they actually use. It provides scalability and flexibility as well, where there is no need for more resources. The cloud scales up or down instantly based on the demand. It is also fast and efficient, as forget waiting weeks to set up your hardware. With the cloud, resources are deployed within the minutes, not even months. It also provides remote access and security. You can access your data from anywhere and have top-tier security without any kind of hassle. Where you also no need to worry about server crashes. The cloud ensures your data is backed up and properly secure. In a nutshell, the cloud gives businesses the ability to be more agile, cost-efficient and scalable without getting bogged down in expensive or time-consuming IT infrastructure management. Now, instead of worrying about servers, businesses can focus on building better products and serving the customers right. So that was it. The cloud is changing the game by giving businesses exactly what they need when they need and at a fraction of the cost of maintaining the physical servers. Alright, now that we have understood what cloud is, the next big question comes is, how do companies actually use the cloud? What are their options based on their needs and why does IT infrastructure even matters? In today's world, every business relies on technology to run efficiently, and having the right IT infrastructure is crucial, as it ensures things like scalability, security, and performance are spot on. But every organization needs are different. They choose the infrastructure based on the cost, flexibility, and the level of control they need. So let's break down the three main types of cloud infrastructure. First is on-premises infrastructure, second is cloud infrastructure, and third is hybrid cloud infrastructure. Let's start with on-premises infrastructure. Here, imagine you're owning a house where you're responsible for everything, the roof, the plumbing, and even deciding when to redecorate or renovate it. In the world of IT, that's what on-premises infrastructure looks like. Here, the company owns and manages all of its servers and IT resources in-house, meaning they have total control but also the full responsibility to maintain and make sure everything is running smoothly and efficiently. So now, what are the key features of on-premise infrastructure? The first one is, it provides the full control over the infrastructure, where you can make all the decisions about how your system runs. Second is, it provides high security and compliance, which is perfect for industries dealing with the sensitive data like banks or hospitals, where privacy is non-negotiable. But it also has some downsides, as it comes with huge upfront expenses. Buying hardware is expensive and it doesn't stop there. Maintenance and upgrades are other ongoing expenses as well. It also comes with limited flexibility and scalability. If you need more capacity, that means you have to buy and set up more hardware, which can take time and can come with huge expenses as well. So when to use on-premises infrastructure? When your business requires complete control, a strict security, and you are prepared to handle the expenses involved in managing everything yourself. Now the next thing is cloud infrastructure. For this, picture using a ride-sharing app like Uber. You don't own the car, but you still get to decide where to go, in which car to go. That's essentially what cloud computing is. You can rent computing resources such as storage, processing power, databases, etc. over the internet and only pay for what you actually use, which is already provided and managed by the cloud service provider itself. So what are the key features of the cloud infrastructure? The first is, there is no hardware ownership or maintenance hassle. Forget about buying, maintaining or fixing servers. Here, everything is managed by the cloud service provider itself. Second is, it is scalable and cost efficient. You can easily scale up or down without any large initial investments. It is also fast and accessible, as you can deploy services and resources quickly and access them from anywhere, anytime. But the trade-off, it gives you very less control over the infrastructure. As the cloud service provider manages the infrastructure, you don't have much control in how things are actually running. So when you should go with the cloud? When you need quick scalability, lower costs, and want to avoid the headache of hardware and maintenance, cloud is the best option to go with. And finally, we have hybrid cloud infrastructure. In simple terms, let's take an example. Imagine you take a subway for most of your daily travel. But for places the train doesn't go, you drive your own car. That's what hybrid cloud is about. It combines on-premise systems with cloud resources as well. So you get best of both the worlds. Now what are the key features of hybrid cloud? Well, the first is it gives you control as well as flexibility, which is considered as best of both the worlds, where you can keep the sensitive data secure in the in-house while enjoying the scalability of the cloud. Second is it provides cost optimization, where you can use the cloud for the things where it is cheaper but keep the critical systems on premises. It also allows you for gradual cloud adoption, where you can move to the cloud gradually without a full commitment initially. But the challenge here is complexity, as managing both on-premises and cloud systems can get tricky and may require extra resources and a hardcore experts handling it. So when to use hybrid cloud? When you need a balance of security and flexibility without fully committing to the cloud, this is the best option in this case. So as we have seen, each of these infrastructure types has its own pros and cons. Now let's take a look at the quick comparison of the types of IT infrastructures we just seen through a comparison table. So the first feature, that is ownership. On the on-premises, you own and control everything, which provides full control but with high responsibility. For the cloud computing infrastructure, it is managed by the cloud service provider itself, while in the hybrid, which provides mix of both, here you can control critical data on premises while leveraging the cloud benefits as well. Coming to the second point, that is cost model. On the on-premises, you have to pay high upfront investments for the hardwares and infrastructure. But with the cloud infrastructure, it provides you with pay-as-you-go model, where you can only pay for what you actually use, making it very cost-effective. Coming to the third, that is hybrid cloud infrastructure, it provides you optimized costs because it balances between capital and operational expenses as of both on-premises and cloud. Coming to the third point, that is scalability. On-premises provides you with limited scalability as it requires buying more hardware if required. Coming to the cloud infrastructure, here it is highly scalable as it gives you option where you want to expand or shrink resources as per the need. Coming to the hybrid cloud infrastructure, the scalability here is balanced as you can scale up with the cloud while keeping the core system stable on the on-premises. Coming to the fourth point, that is security. On-premises provides you with high security as there is full control over the security measures as everything is handled in-house. But coming to the cloud providers or cloud computing infrastructure, here everything depends on the provider as security is shared but it is robust. Now coming to the hybrid cloud infrastructure, the security here is flexible as you can secure sensitive data on premises and use cloud resources for less critical workloads. Now coming to the fifth point, that is maintenance. On the on-premises, it requires an in-house IT team for upkeep and updates, while in the cloud infrastructure, there is no maintenance on your end. The provider handles all of it very well. Now coming to the hybrid cloud infrastructure, the maintenance is partial because you can manage on-premises components while the cloud stays managed by the service provider itself. And coming to the last point, that is deployment speed. On-premises are pretty slow while cloud infrastructure is comparatively fast, while in hybrid cloud infrastructure, everything is moderate. So that's the comparison. Pick what suits your control, cost and scalability needs the best. Now that we have seen, while there are different cloud models that we have just studied, the cloud offers huge benefits for businesses, making operations smoother and faster and more cost-effective. So let's break down the top benefits of cloud computing, as this is what makes it a powerful tool for modern businesses. With the key benefits like, first is cost efficiency. Cloud computing saves businesses money in several ways. Here you can rent resources. No need to buy expensive hardwares. And you can just rent what you need and when you need. Second is, it has very low operational costs, where cloud providers take care of hardware updates and maintenance, so you don't need to worry about any kind of costly IT teams or downtime. Third is, it provides you with pay-as-you-go model where you can only pay for what you use, avoiding unnecessary expenses. This helps businesses control costs and scale up or down easily as needed. Now the second advantage is security and compliance. Cloud providers invest heavily in cybersecurity to keep your data safe and secure, as the encryption and compliance certificates ensure that your business meets all the necessary regulatory requirements such as GDPR or HIPAA, etc. Second is, it provides you with MFA, that is multi-factor authentication, and regular security updates, helping you protect your data from breaches, keeping everything safe and secure. Now the third point is scalability. One of cloud's biggest advantages is scalability. It provides you with auto-scaling. The auto-scaling mechanism allows businesses to instantly increase or decrease computing resources, keeping the cost aligned with actual needs, where there is no need to predict any kind of traffic spikes in demand. Whether you are running an e-commerce site during a sale or streaming a platform during a new release, the cloud adjusts everything in real time. Now, the fourth advantage is performance speed. Cloud providers use globally distributed data centers, which means reduced latency. Data is processed closer to the user, speeding up the access. The second point is the load balancing ensures smooth performance as the traffic is spread out efficiently, preventing slowdowns during high demand too. It also comes with edge computing advantage, which takes a further step by processing data near the user, improving users' response times even more. Coming to the fifth one, cloud computing is all about accessibility, where you can access work from anywhere on any device and as long as you have a stable internet connection. It also comes with collaboration tools like Google Docs and Microsoft 365, which enables the real-time teamwork, allowing users to work together regardless of the location. And the sixth one is disaster recovery. No one likes thinking about disasters, but the cloud helps mitigate risks of this kind too. It is powered by automatic backups, which ensures that your critical data is protected even if the system fails. It also provides replicating the data across multiple locations, keeping your data safe just in case of a failure at one site, so businesses can quickly recover without losing any kind of valuable information or data. It also helps businesses restore lost data within the minutes, minimizing the downtime and keeping the operations real smooth. While the cloud makes life much more easier, but it's not without challenges. Companies need to be mindful of certain risks and concerns before fully making the move. Let's look at some of the main challenges businesses face when it comes to the cloud, as it is very important to address these challenges to maximize efficiency and enhance the security. The first one is the constant internet connection requirement. Cloud services rely totally on a stable internet connection. If your internet goes down, you lose all your access to the critical systems as well as your data. This means your entire business operation could be at risk if the connection is interrupted, especially if you're working remotely. Now the second challenge is the downtime and reliability issues. Cloud providers, just like any other servers, can experience downtime. If the cloud provider faces downtime, your business might also face interruptions impacting productivity and customer experiences, which can lead to major damages and huge loss. For example, in 2021, AWS went down, disrupting their services and resources for major platforms like Netflix and Reddit. Coming to the third one, that is data security and privacy issues. Moving data to the cloud means trusting a third-party service provider to manage your security and authentication. If a data breach occurs, sensitive customer information could be exposed, as businesses must assess the provider's security measures to ensure that the data is handled properly and is secure on the platforms. The fourth one is complex pricing models. The cost of cloud services can fluctuate unpredictably if the usage isn't monitored closely and properly, where the companies might need to overpay for resources and services they don't need, especially if they don't track the usage regularly and properly. It's important to choose the right plan to avoid unexpected charges as well. Now coming to the last challenge that we have and is majorly talked about is vendor lock-in. So what is vendor lock-in? Let's first see that. So vendor lock-in is when you're totally relied and dependent on a single cloud service provider that when it comes to migrating your systems or resources, it makes it difficult to switch to the another cloud service provider. So that is basically called as vendor lock-in. Here, moving data and services to the cloud often involves proprietary technologies that make it hard to switch providers later, as we discussed just now. It comes with high migration costs and compatibility issues that can prevent businesses from easily moving to a different cloud service provider if needed. This is a critical consideration when deciding on a cloud service vendor. So as we have seen, while the cloud comes and offers with huge and immense benefits, businesses must carefully consider these challenges as well before migrating. There are ways to mitigate risks, but understanding the trade-offs is must and crucial. Now that we know the advantages and challenges of cloud computing, the next step is diving into how businesses deploy their resources in the cloud. In the next module, we will explore cloud deployment models, what they are, how they work, and why they matter for your business. So your business can run efficiently, securely, and cost effectively. Alright, let's dive in by understanding what cloud computing services are. In simple terms, cloud computing services are on-demand computing resources delivered over the internet. This includes servers, storage, databases, networking, software, and much more. These services allow users to access and manage computing power without the need to own or manage and maintain physical infrastructure. Think of it like renting tools from a hardware store instead of buying them. That's exactly how cloud services work. These services allow users to access and manage computing power without the need to own or maintain or manage any kind of physical infrastructure. Think of it like renting tools from a hardware store instead of buying them. That's exactly how cloud services work. But wait, even these services are categorized into two main models. These cloud models are basically different business models adopted by a cloud service provider. They operate on two main models. That is, first deployment models and second is server models. First, we will explore the deployment models as well. So what are the deployment models in the cloud? A deployment model basically defines the cloud services you are consuming, who is responsible for managing them, your cloud architecture, the scalability of your computing resources, and the level of control and customization you can have over your infrastructure, and the services provided to you versus how much you own of the infrastructure. In other words, it's like choosing the type of housing you want. Do you want to rent it, own it, or share your space with someone? That's how exactly cloud deployment models work, defining how you can access and manage your resources. Based on this, there are four major types of cloud deployment models. First is public cloud, second is private cloud, third is hybrid cloud, and fourth is multi-cloud. So, to make it easier, let's compare choosing a cloud deployment model to choosing a ride. When you pick a ride, you think about cost, control, and convenience, just like selecting a cloud model. Public cloud is like taking a bus, which is accessible for everyone, is cost effective, but offers shared resources. While the private cloud is like owning a private car. It's exclusive only for you. It gives you full control and high security, but it comes with higher expenses as well. While the hybrid cloud is like using a taxi, which offers privacy and flexibility without the burden of full ownership. See how relatable that is. Now let's explore these models one by one, starting with the public cloud first. So what is public cloud? A public cloud is a cloud computing model where the third-party providers offer computing resources and services over the internet, which is shared among multiple organizations at once. For that, imagine using a gym. You get to access all the equipments there, but you share it with others as well, right? That's how public cloud works. Shared resources at an affordable price. So what are the key features of public cloud? First is scalability. Here you can dynamically scale resources based on the demand. Second is it is cost effective. There is no upfront hardware costs. You can only pay for what you actually use. Third is accessibility. You can access services from anywhere with a stable internet connection. Fourth is Managed services. The provider handles the complete infrastructure, updates and maintenance. So you don't have to worry about any of the technical side. But yeah, there are certain challenges that you need to address. First is security and compliance risks. Shared resources and environments may introduce certain vulnerabilities as well as risks. Second is limited customization, which means it gives you very less control compared to the private clouds. The third is potential downtime. Here you have to rely on the provider's reliability, which may occasionally lead to the service interruptions leading to the downtime. Now, what are the common use cases of public cloud? Well, it is best for hosting websites. Think of platforms like WordPress or Shopify, just like them. The second is it works great for big data analytics, where you need to process large data sets quickly. Third is cloud storage and backups, which works like Google Drive or Dropbox, but in an efficient and scalable way. Now, the fourth is running AI and machine learning models efficiently. Here, it provides you with a lot of options and features where you can run and manage your machine learning models very efficiently, and they are also secure. So, the public cloud is great for the businesses that prioritize cost efficiency and scalability, but are okay with sharing resources. Now that we have explored the public cloud, let's see and talk about the private cloud, the more exclusive option in the cloud world. Imagine having your own private car. You control where it goes, how fast it drives, and who gets in. Sure, but it's more expensive than public transport, right? But you get the privacy, comfort, and full control over your car. That's exactly what a private cloud offers for the businesses. So, a private cloud is a cloud computing model where the computing resources and services are dedicated to a single organization. Unlike the public cloud, these resources aren't shared with anyone else. These private environments can be hosted on premises like within the organization's own data center, or can be managed by a third-party provider but still dedicated exclusively for a single organization. This model is ideal for the businesses that need strict security, compliance, and control over their infrastructure. So what are the key features of private cloud now? Well, the exclusive use. Resources here are reserved solely for one single organization, ensuring maximum privacy. The second is enhanced security. Organizations have greater control over the data and privacy compliances, making it ideal for the sensitive industries like healthcare, banking, and finances. Third one is customization. Here you can tailor the infrastructure to meet specific business goals and needs, something that's limited in the public cloud environments. But in the private cloud, you get the full customization option. Now the fourth is consistent performance. Since there's no resource sharing, you avoid the slowdowns or downtimes and get predictable, reliable performance. But again, it comes with huge upfront costs. So let's address the challenges of private cloud. While the private cloud offers huge and significant benefits, it comes with few challenges as well. The first is higher expenses. Building and maintaining a private cloud requires a significant upfront investment as well, from buying hardware to hiring a skilled IT staff. Thus, it comes with huge expenses. Second is complex management. Here, you will need in-house expertise or third-party management to handle the infrastructure. It's not like just set it and forget it. You have to manage and implement each and everything efficiently and seamlessly. The third is scalability limitations. Unlike the public cloud, scaling a private cloud often means physically adding more hardwares, which again comes to on-premises, taking your money and time. So when does it make sense to use a private cloud? Well, for the organizations with strict security and compliance requirements, such as healthcare, finance, government sectors, where data privacy is non-negotiable, or businesses needing customized infrastructure solutions, where they want tailored environments for unique business needs. And the third one is enterprises, where the requirement is for high performance computing without any kind of shared resources. This is ideal for workloads like scientific simulations, financial modeling, or big data analytics without the risks of any kind of shared resources. So, this was for the private cloud. It gives you privacy and control, but it again comes with higher expenses and management responsibilities. But what if you could get best of both the worlds? That is, cost effectiveness of the public cloud and the security of a private one. Exactly. That's where hybrid cloud steps in. So let's see what hybrid cloud is. We have looked at the public cloud like taking a bus, affordable but shared resources. Then the private cloud like owning a car, private but costly. But what if you could combine both? Imagine using a public transport for daily travel but driving your own car for special occasions or private trips. You get the cost savings of the bus and the privacy of your car. Adds best of both worlds again, right? That's exactly what the hybrid cloud offers. But what is hybrid cloud? Hybrid cloud combines both public and private cloud environments, allowing data and applications to move between them seamlessly, which provides better flexibility, scalability, and security. Why is that useful? Well, sometimes you need extra resources for certain workload spikes. That's when you can tap into the public cloud. But for the other times, when you need a strict security and control, that's when you can use the private cloud. It's all about flexibility and smart resource management. So, let's see the key features of hybrid cloud. First is, it provides flexibility. Here you can run sensitive workloads in the private cloud and less critical ones in the public cloud, where you can choose what works best for each situation individually. The second one is scalability. The need for extra power during peak seasons, right? Now expand resources instantly using the public cloud without any investment in more hardwares. The third one is security and compliance needs, where you can keep the sensitive data secure in the private cloud while enjoying the public cloud scalability for non-sensitive tasks, which is again cheaper than private cloud. The fourth one is cost optimization. Here you can avoid overspending by balancing the workloads, as you can use private infrastructure for the critical operations and public cloud for the variable demands. While the public and the private offers great benefits, and then comes the hybrid cloud, which is a perfect solution, but it does come with its own set of challenges. The first one is the complex management. Integrating two different environments means you will need to manage both and ensure they work together seamlessly and without any downtimes or any infrastructure complexity. Thus, it can be complex to manage both of it. The second is security risks. Moving data between the clouds. Well, that really requires a strong security measures to prevent data breaches or data leaks. And the third one is higher upfront costs. Managing both a private infrastructure and a public cloud can be expensive, especially if not optimized properly. As we have seen in one of the challenges, complex pricing. Remember? Yeah, exactly. This refers to that. Now, what are the common use cases of a hybrid cloud? So, when you should use a hybrid cloud? For the businesses needing data privacy and regulatory compliances, such as healthcare or finance sectors that also require cloud stability and scalability. Or for the companies with variable workloads, think of for e-commerce platforms where during holiday sales they need extra resources during peak times, but not around the year, like seasonal demand spikes. The third one is enterprises with on-premises infrastructure. The organizations that want cloud benefits without completely moving away from their existing on-premise setups. This is the best option to go with. Now, while the hybrid cloud offers best of the both worlds, that is flexibility, security, and cost optimization, but managing it can be tricky. But here's another interesting thought. What if you don't just stick to one cloud provider? What if you can use multiple cloud providers to avoid dependency and get the best features from each of it? While the hybrid cloud offers the best of the both worlds, providing you with flexibility, security, cost optimization, but managing it can be tricky and expensive. Here's another interesting thought. What if you didn't just stick to one cloud provider? What if you could use multiple cloud providers to avoid dependency and get the best features from each one of it? Yeah, that's exactly what the multi-cloud model is about. In the multi-cloud, you can just shop around and pick the best features from different cloud providers instead of sticking to one. It's like when you're shopping online, you might buy electronics from the Amazon, clothes from the Flipkart, and groceries from the Zepto. Why? because you are looking for the best deal, quality, and convenience from different platforms. That's exactly what the multi cloud approach is all about. The multi cloud model involves using resources and services from multiple cloud providers like AWS, Azure, or Google Cloud Platform, that is GCP, simultaneously to optimize the performance, reduce dependency on a single cloud provider, and again enhance the resilience. Think of it like instead of putting all your eggs in one basket, you are spreading your workloads across different providers for better reliability and performance and easy access. So let's see the key features of multi-cloud. The first is, it comes with vendor independence. You remember I told you about the vendor lock-in and we have studied this concept into the challenges of cloud computing? Exactly. It gives you vendor independence, which means here you can avoid getting locked up into one provider's ecosystem. If one service becomes expensive or unreliable, you have got the alternatives as well. Here you no need for the high migration costs that comes with vendor lock-in as well. The second is best of breed services, which means here you can use different cloud service providers for the different multiple utilities. As you can use AWS for storage, GCP for AI tools, and Azure for enterprise solutions, getting the best each provider has to offer. The third one is resilience and redundancy. If one cloud goes down, others keep your services running, which means minimizing the downtime and reliability risks. The fourth one is optimized performance. It can help you deploy workloads on the cloud that best suits them. Need fast data processing? Choose the provider known for that. It's easy as that. So how does a multi-cloud environment actually works? Since this concept might seem new to you, let's break it down with a simple scenario. Imagine you run a global e-commerce platform. You use AWS to host your website for its scalability. Google Cloud manages your AI-driven product recommendations, and Azure handles financial transactions because of its strong compliance features. Yes, this is how it works. These services work together, ensuring your customer get the best experience without you being tied to a single cloud provider. So that is how it works. While multi-cloud has many perks, it's not all smooth sailing. It also has some challenges that need to be addressed. So, how does this actually works? Since this concept might seem new to you, let's break it down with a simple scenario. Imagine you're running a global e-commerce platform. You use AWS to host your website for its scalability, Google Cloud to manage your AI-driven product recommendations, and Azure to handle financial transactions because of its strong compliance features. This is exactly how it works. These services work together, ensuring your customers get the best experience without you being tied to a single cloud service provider, where organizations can distribute workloads across different cloud service providers, and the data and applications can interact across multiple cloud platforms as well. While the multi-cloud has so many perks, but it's not all smooth sailing. So the first challenge is complex management. Handling multiple cloud service providers means more dashboards, tools, and processes to manage and handle, which can be complex and tricky at times. The second is security risks. Different cloud service providers mean variety of security protocols, making it harder to maintain consistent protection as well. And the third one is integration issues. Ensuring a smooth communication between different cloud providers can be tricky and may need specialized tools and hardcore experts around you all the time. So, what are the common use cases and when you should use multi-cloud? For the enterprises needing high availability and disaster recovery, as if one cloud goes down, other clouds or other cloud service providers can keep things running smoothly and ensure everything is running just fine. The second is when you need cost optimization, where businesses pick best price services across clouds to save money. And the third one is businesses adopting to different cloud strength for different workloads. As we already discussed about this, you can use GCP for AI/ML projects, run databases on AWS, or handle enterprise applications on Azure. So now that we have explored how companies set up their cloud environments through different deployment models, let's quickly compare cloud deployment models with just enough context to make things crystal clear. Let's dive in. Alright, Now that we have explored the different types of cloud deployment models, that is public, private, hybrid, and a multi-cloud strategy, let's bring these concepts to life with some real-world examples as well. Because, let's be honest, theory is great, but seeing actually how big companies use cloud deployment models in action, that's where the real learning happens, right? So, starting with the first, that is public cloud, let's take an example of Netflix here. Have you ever wondered how Netflix seamlessly streams your favorite shows to millions of the users across the world without any kind of buffering issues? Well, here's the secret. They use the public cloud, specifically speaking AWS, that is Amazon Web Services, to manage their massive streaming traffic, store terabytes of video data, and process big data analytics for the personalized recommendations. Since public cloud is fully managed by the provider and scales automatically, Netflix can focus on delivering an uninterrupted binge watching experience while AWS handles the heavy weightlifting behind the scenes seamlessly. That was it for the public cloud. Now, what about industries where security is the number one priority? For example, take Bank of America. For an example, financial institutions handle sensitive customer data and they have to comply with the strict regulations as well. And that's why they use the private cloud, which gives them full control over their data, security, and infrastructure, while keeping it accessible only within their internal network. As this ensures that the customer data remains private and secure, meeting all the compliance requirements necessary for this. Now moving forward with the hybrid cloud model, have you heard about Lego? Yeah. Lego isn't just about colorful bricks anymore. It's also a tech-savvy company. To handle their operations efficiently, Lego uses a hybrid cloud approach as well. They store the sensitive data on premises for security and compliance reasons, while they use the public cloud, that is, Microsoft Azure, to scale their operations during high-demand seasons like Black Friday or holiday sales. This combination gives them the best of both the worlds, that is, security and flexibility on demand. Now, coming to the multi-cloud strategy, let's talk about Spotify here. Your go-to app for music streaming. Spotify uses the multi-cloud strategy relying on different cloud providers for different kind of tasks. For instance, they store the data on AWS while they also use Google Cloud for the AI-driven recommendations that suggest your next favorite song. Thus, by using multiple clouds, Spotify ensures high availability, cost optimization, and advanced analytics without being locked up into a single cloud provider. Efficient, isn't it? And there you have it. These real-world examples actually show how businesses use different kind of cloud deployment models to match their specific needs. Whether it's a global streaming service, a high-security financial institution, or a hybrid retail tech company, or even a data-driven music platform, cloud computing plays a crucial role in making all of this happen. So next time when you watch Netflix or shop online or even stream your favorite song, you will know there's some serious cloud stuff happening behind the scenes. Now let's quickly compare the cloud deployment models once again to make things crystal clear with the comparison table here. So coming to the first point, that is the ownership. In the public cloud, everything is owned and managed by the third-party providers like AWS or Azure, which is great when you don't want to manage the infrastructure. Coming to the private cloud, which is dedicated to a single organization, it is ideal for the companies needing full control. Now moving to the hybrid cloud, which is a mix of public and private clouds, is perfect when you need flexibility as well as security. While the multi-cloud approach, here it uses services from multiple providers, which helps avoid the vendor lock-in and provide you with optimized performance. Coming to the second point, that is scalability, in the public cloud, it scales easily to handle varying workloads, which is good for unpredictable demands. But in the private cloud, the scalability is limited, but it is best for stable and consistent workloads. While in the hybrid cloud, it offers you with the flexible scaling, as you can use the private cloud for the critical data and public cloud for the extra capacity you need. While in the multi-cloud, it provides you with high scalability across the multiple cloud providers, which is ideal for the global operations. Now coming to the third point, that is security. In public cloud, the security is of moderate level, which is sufficient for the general applications. While in the private cloud, it provides you with the high security, which is best for sensitive data and compliance needs. While in the hybrid cloud model, it provides you with the balanced security where you can control the sensitive data privately while you can also leverage the public resources on the public cloud. Coming to the multi-cloud approach, the security here varies depending on each provider and how the security is managed in it. Now coming to the fourth point, that is cost. In the public cloud, it provides you with the low cost option as it has the pay as you go model which suits the startups and small businesses the best. While in the private cloud, it comes with high cost which is actually worth it for the organizations prioritizing security and control both. But in the hybrid cloud, the cost is kind of balanced as it is more than public but less than a private cloud alone. While in the multi-cloud approach, the costs can vary according to the service provider you actually choose and the services to balance price and performance. Now coming to the fifth point, that is customization. In the public cloud, it provides you with a limited customization, while in the private cloud, it is highly customizable. Here you can also tailor it with your exact specification and requirements. While in the hybrid cloud, it provides you with a moderate level of customization as here you can customize the private side while using the public for the general needs. But in the multi-cloud approach, the customization depends on the chosen providers that you have opted like AWS, Azure or GCP. Now, which cloud is best for which? The public cloud is best for the startups or web apps needing quick and affordable solutions, while the private cloud is best in case of enterprises handling sensitive data with strict regulations, where security cannot be compromised at all. Coming to the hybrid cloud, which is best for businesses seeking both security as well as the cloud flexibility. Now, the multi-cloud approach is best for the large companies optimizing costs and avoiding the reliance on a single cloud provider, which also helps you to avoid the vendor lock-in. Thus, here it is. Now that we have explored how companies set up their cloud environments through different deployment models, it's time to dive into how they use cloud services like storage, servers, and softwares. In the coming module, we will explore the cloud service models, that is, infrastructure as a service, platform as a service, software as a service, and even function as a service, and how they help businesses build, deploy, and manage the applications more efficiently and seamlessly. So, now that we have explored how companies set up the cloud environments through different deployment models, it's time to dive into how they use cloud services like storage, servers, and softwares efficiently. In this module, we will explore the cloud service models, that is infrastructure as a service, platform as a service, and software as a service, and how they help businesses build, deploy, and manage applications more efficiently and smoothly. So let's begin by understanding what exactly are cloud service models. So according to the definition, cloud computing service models define the different levels of computing resources that cloud providers offer to businesses and individuals. In simple terms, they define the levels of computing resources that cloud providers actually offer. They answer the one big question: who manages what? How much is handled by the provider itself, and how much do you actually manage? But why do we even need these service models? Think about it. Every business has different technical needs. Some companies want full control, managing their servers and softwares. Others just want ready-to-use applications without the headache of maintenance. And that's where cloud service models comes to rescue. They provide different levels of control, flexibility, and convenience so companies can actually choose what works best as per their needs. The major four cloud service models are: first is infrastructure as a service, second is platform as a service, third is software as a service, and fourth is function as a service. Now to make things easier to understand, let's take a real world analogy here. Imagine you are setting up your dream house, or in this case your IT setup. Infrastructure as a service, think of it as renting an empty plot with the utilities. Here you can build the house your way, but the land and power supply are provided by a certain provider. While in the platform as a service, here think of it as renting a partially built house, where the walls and plumbing are already given to you. You just need to decorate and furnish it as per your needs. While in the software as a service model, think of it as booking a fully furnished Airbnb where you can just walk in and start living. Now, coming to the function as a service model, think of it as ordering room service in that Airbnb. You don't even need to worry about the kitchen. They deliver what you need when you need as per your demands. Now, this was the simplest example to understand each one of the services. Now, let's break this down with a relatable scenario. Imagine you're launching a new business. Now, to start your business, you will need a website, a database to store the customer information, a secure network connection, a software to manage your daily operations. Now, how do you will set it up? Traditionally, you would have to buy expensive hardware, set up physical servers, install all the necessary softwares, and constantly maintain everything by yourself. And damn, sounds like a lot of work and money, right? But thanks to the cloud service models, you get to choose how much responsibility you handle versus how much the cloud service provider manages. It's like deciding between cooking at home, which gives you all effort and full control, or using a meal kit where you require less effort but you don't have much control over it as well, or simply dining at a restaurant, minimal effort, sit back and just enjoy your food. You pick here based on how much effort and time you want to invest in it and how quickly you need things up and running. So, here instead of owning and managing everything, businesses can just rent IT resources from a cloud service provider based on their needs and specifications. So, let's understand them in detail. Let's begin with the foundation model, that is, infrastructure as a service. Infrastructure as a service is like renting the land and utilities to build your own house. Here, you don't own the land. For example, that is the infrastructure here, but you actually build and manage the house, that is, apps or data in your infrastructure, the way you want and exactly as per your specifications and requirements. In technical terms, the provider supplies and manages the infrastructure components needed to run applications such as servers like your house foundation, storage like closets of your data, networking, the roads connecting everything in between, and the virtual machines for running your applications. Here you can manage everything else like installing software, setting up firewalls, and maintaining the system. So what are the key features of infrastructure as a service? The first is, it provides you with the compute resources where you can quickly create virtual machines for various workloads. Second is, it gives you storage options where you can easily scale the storage up or down as per your needs and requirements. The third is, it provides you with also the networking part where you can manage networks, load balancers and firewalls to secure your connections. The fourth is, it comes with pay-as-you-go model, as you can pay only for what you use. No need for massive upfront investments as well. Even with all the benefits, infrastructure as a service isn't without hurdles. There are some challenges as well. The first one is management complexity. Here you will need technical expertise to configure and manage the infrastructure. The second is security concerns. While the provider secures the physical data centers, but you are actually responsible for protecting your apps and data. The third point is data transfer costs, as moving large amounts of data from on-premises to the cloud can come up with huge upfront expenses as well. Now, what are the common use cases of infrastructure as a service? It is best in case for the companies handling variable workloads like e-commerce sites during holiday sales or businesses needing data and privacy compliances but still wanting cloud scalability, or the enterprises expanding their infrastructure without buying any kind of new hardware. And it is also the best option for the startups wanting a cost-effective way to test the new applications without any kind of major investments. Now that we have seen how infrastructure as a service provides the building blocks of your IT setup, what if you don't want to handle the entire construction yourself? What if you just want a ready-made platform to build and deploy applications seamlessly without any kind of worry about underlying hardware? And that's exactly Platform as Service steps in. Platform as a Service is a cloud computing model that provides a ready-made platform for developers where they can build, deploy, and manage web applications without any kind of worrying about underlying infrastructure like servers, storage, or networks. Think of it as a one-stop shop for all the app development, perfect for teams that want to focus on coding and innovation rather than the boring IT management stuff. So, what are the key features of Platform as a Service? Well, the first one is it provides you with the development tools. Here you have the access to frameworks, libraries, and tools to make the app development even more faster. Second is it provides you with the managed kind of hosting. Here you no need to manage servers or worry about the maintenance. The platform handles it all efficiently and effectively. The third one is it comes with integrated databases where you can easily use built-in databases without any kind of complex setups or managements. The fourth one is it again comes with pay-as-you-go model where you only pay for what you use, saving a lot on operational costs as well. Even with all of the convenience, there are favorite things that you need to watch out for. And the first one is vendor lock-in. As switching providers later can be tricky once you are tied to one particular cloud service provider or one platform. The next is customization limits, as it gives you less control over the underlying infrastructure, which is great for simplicity but not always for the flexibility and scalability you want to implement. And the third one is security concerns. While the provider secures the platform, but you are also responsible for the app level security. Thus, there can be risks of data breaches and data leaks if not properly configured. Now, what are the use cases of platform as a service? Well, it is best in case of web and mobile app development purposes where you can quickly build and deploy applications seamlessly. It is also best for API development and integration, as here you can create and manage APIs with even bare minimal effort. It also comes with database integrations, which is best in case of database management, where you can effortlessly set up databases to power your applications. So, with Platform as a Service, you can focus on your app and the provider takes care of all the techie backend stuff by themselves. Now, what if you don't even want to develop anything by yourself? You just need ready-to-use softwares like email services or project management tools. And that's where software as a service comes into the play. Here, you don't need to deal with infrastructure or development at all. Here you can use the software without worrying about how it runs. Think about it like streaming movies on Netflix. You don't need to download anything or manage servers or even update softwares. You just log in and enjoy it. And that's exactly what software as a service is all about. It is a cloud computing model that delivers ready-to-use software applications over the internet, often on a subscription basis, where there is no need to install any kind of softwares, no hardware requirements. You can access it anytime through a web browser. Here, the provider handles everything, infrastructure, maintenance, and updates. So you can just focus on using the software and doing your work. Now, what are the key features of software as a service? The first one is there is no need of any kind of installations. You can access the softwares directly through your web browser. No downloads required. The second is it gives you automatic updates. There is no need to manually update anything. The provider takes care of all of it. The third is it comes with scalability. It can easily adjust to the usage based on users' numbers or needed features. And again, it comes with pay-as-you-go model where you only have to pay for what you actually use, no hefty upfront costs required. And then again, while software as a service is super convenient, but there are certain challenges that you need to address. So the first one is the total dependence on internet connectivity, which means no internet equals to no access. A stable internet connection is a must requirement for you. A stable internet connection is a must requirement here. Now the second one is security concerns. Since the data is completely stored on the third-party servers, ensuring strong security measures is essential as well. And the third one is limited customization. Here you get a pre-packaged solution which might not fit every unique need or any kind of personal requirements or specification needed for your application or utility. Now, what are the common use cases where software as a service can be ideal? The first one is email and collaboration tools like Gmail, Microsoft Outlook, or even Microsoft 365. Now again, for the customer relationship management, tools like Salesforce or HubSpot, which helps to manage customer relationships. Now the third one is for the project management purposes, For the platforms like Trello, Asana, or Slack streamlined teamwork management tools. And the fourth one is accounting and financial softwares like QuickBooks Online, Xero for financial management, etc. So this was it for the software as a service. So with software as a service, it's like enjoying a ready-made meal you ordered from a restaurant, right? But the question is, what if you need to run the code without worrying about servers or infrastructure at all? But now, what if you need to run the code without worrying about any kind of servers or infrastructures at all? And here comes function as a service, the ultimate set it and forget it model. To understand this, imagine a simple scenario. You walk into the coffee shop, place your order and get your coffee and leave. You don't care about how the coffee machine works or how the beans were roasted. You just want your coffee quickly. That's it. And that's function as a service in a nutshell. Here, you only focus on the code and the provider handles the rest of the things in the backend. So let's see what is function as a service. It is a serverless cloud computing model where you can write small pieces of code called as functions that run in response to events like a website click, a file upload, or even an API request. Here, there's no need to manage any kind of servers. The code runs only when it is triggered. And you only pay for the actual execution time of the function and not for any kind of servers. And it automatically scales based on the demand. Think of it like a vending machine. For an event, you push a button. And then as a cloud provider, that is the machine, delivers your snack. That is running your function. Easy, right? Now this is how function as a service works. So what are the key features of function as a service? The first is its event-driven execution, where the function triggers when something happens like an HTTP request, a file upload, or even a database change. And it is completely serverless. Serverless, it doesn't mean that there are no servers here. They are there. You just don't need to manage them. The cloud provider handles all of it in the backend. It also provides automatic scaling, whether you got one request or a million requests. Function as a service scales automatically to handle the demands. It comes with pay-per execution, which actually means here you only have to pay when your code actually runs and not a second more than that. The fifth key feature of this is it provides faster time to market where you can deploy your code quickly without worrying about any kind of infrastructure. But it comes with some challenges as well. The first is cold start latency. Now, if a function hasn't been used in a while, it might take a few extra seconds to start. This is what we call as cold start latency or a cold start. The second one is state management, which means the functions here are stateless, which means it makes it a little bit of tricky to manage the ongoing data across the executions. The third one is debugging and monitoring. Without traditional servers, troubleshooting can be a bit more challenging than it seems. So what are the common use cases for the function as a service? The first is it comes with microservices architecture, which means it makes it easier to break down large applications into smaller and manageable services. The second one is real-time file processing. Here you can automatically resize images when users upload them. The third one is API backend. You can handle the API requests on demand without any kind of dedicated servers in the real time. The fourth one is IoT event processing. Here you can trigger the functions based on the sensors or sensor data from the devices. So with function as a service, you just write the code, set the trigger, and the cloud takes care of all the backend and manages your function efficiently. Now that we have explored all the cloud service models, that is infrastructure as a service, platform as a service, software as a service, and even function as a service, let's simplify them with some quick context and relatable examples with a comparison table as well. So the first point is definition. For the infrastructure as a service, it provides virtual server, storage, and networking, which is ideal when you need raw infrastructure but want to avoid physical hardware, as in short term, it is a virtualized infrastructure. While for the platform as a service, it offers a platform for developers to build and deploy apps without any worry about hardware or operating systems management. Thus, it provides a platform for web as well as app development purposes. While in the software as a service, it delivers fully functional software through the cloud. While in the function as a service, it lets you run the code triggered, while in the function as a service, it lets you execute the event-driven functions with the help of the triggers, which is perfect in the case of small or tiny tasks without any kind of server management. Now the second point is control. In the infrastructure as a service, it provides you with the high control over the servers and configurations, which is great for IT teams wanting flexibility as well. While for the platform as a service, it provides you with a medium level control where you can handle app, the provider manages the infrastructure. But in the software as a service, it provides you with a low control as you use what's provided, focusing purely on the usage. Lastly, in the function as a service, it again provides you with the low level control as here you just write the functions. Scaling and servers are handled for you by the service provider itself. Now coming to the third point, that is scalability. In the infrastructure as a service, it can scale manually or automatically depending on how you set it up, while in the platform as a service, the scalability is automated based on the app needs as developers don't have to worry about it. In the software as a service, the auto-scaling happens with the user demands. Lastly, in the function as a service, it instantly scales up with the number of function calls, which is perfect for fluctuating workloads. Coming to the fourth point, that is the pricing. In the infrastructure as a service, you only pay for the resources used, like storage or compute power. Thus, it goes with pay per use. While in the platform as a service, here you only pay for the platform services you consume. Coming to the software as a service, it is completely subscription based where you can pay monthly or yearly for software access or subscriptions. But in the function as a service, you only pay for the function execution, saving costs for event-driven tasks as well. Now for the examples, in the infrastructure as a service, take the example of AWS EC2, Google Compute Engine, like renting virtual machines. While in the platform as a service, you can take the example of Google App Engine, AWS Beanstalk, where you can focus on code and not on the infrastructure. While for the software as a service, Google Workspace and Salesforce are the softwares which are ready to use from day one. And lastly, for the function as a service, AWS Lambda and Google Functions are best examples of function as a service, where you can run the snippets of the code whenever needed. And that's it. Here, each model serves different needs, whether you want full control or just want things to work out of the box. Alright, so far we have explored the cloud deployment models and service models as well. But have you ever wondered who's actually behind the cloud services we use every day? Well, let me introduce you to the top players in the cloud market, the companies that power the internet's backbone and make the cloud possible for us. Alright, let's see who provides the cloud services. The cloud services are provided by cloud service providers, the companies that own and maintain large-scale data centers worldwide, offering the computing power, storage, networking, and more over the internet. These providers own massive data centers across the world, packed with thousands of server storage systems and networking equipments. Now imagine a warehouse the size of several football fields filled with blinking servers. That's the scale we are talking about here. Now, who actually runs the cloud and makes sure it's safe? Let's break it down in a simple terms. Cloud governance is a shared responsibility, meaning multiple parties work together to keep the cloud services secure, reliable, and running. So the first one is cloud providers. They own and maintain the cloud infrastructure, making sure the servers are running, the data centers are secure, and services comply with regulations and compliances. Then comes the government and regulatory bodies like GDPR and HIPAA. They create the laws and guidelines to protect the user data, ensure companies follow the security standards and compliances as well. Then comes businesses and users. That's exactly you. You are responsible for setting up security controls, managing your data, and ensuring the best practices are followed within your cloud environment. Think of it like renting an apartment, where the landlord, that is the cloud provider, takes care of the building and ensure the utilities work just fine. Then comes the city government regulations, which enforces safety codes and makes sure the building meet legal requirements and compliances. Then comes you, the tenant, who are staying there. You are responsible for locking your doors, managing your belongings, and keeping your space secure and clean. So, While the cloud providers give you the infrastructure, it's up to the businesses and users to ensure their data is safe and secure. Next, we'll see what is a cloud provider. The cloud provider is simply a company that rents out IT resources like servers, storage, databases, and software over the internet, where instead of buying expensive hardware and maintaining it, you pay for what you use. We have studied it already. So, why do businesses use or choose or prefer cloud providers? Ever wondered why businesses don't just build their own massive data centers instead of using the cloud providers like AWS, Azure, or GCP? Simple. It's because cloud providers don't just offer storage. They offer powerful technology that helps businesses grow faster, smarter, and safer. The first one is security and compliances. Cloud providers offer built-in encryption, firewalls, and compliances with the industry regulations like GDPR and HIPAA, so businesses don't have to worry about setting up security from scratch and about the regulatory bodies. They can just focus on their own growth. The next is AI and big data capabilities. If you need to process huge data sets or even build AI-driven applications, AWS, Azure, and GCP provide powerful machine learning tools and analytics solutions as well. So, businesses can run and turn their data into insights effortlessly and without any kind of hustle. Then comes the seamless integrations. Each provider has its own strength. For example, Azure integrates seamlessly with Microsoft tools while AWS offers the broadest range of cloud services. Then, Google Cloud leads in AI, machine learning, and analytics. The fourth factor is hybrid and multi-cloud flexibility. Companies don't have to stick to a single provider. Many use hybrid, that is mixing cloud plus on-premises infrastructure, or multi-cloud, that is using multiple providers, to maximize the flexibility and avoid the vendor lock-in. Thus, you see, at the end of the day, businesses don't just choose cloud providers for cost savings. They are about giving businesses the tool to innovate, scale, and stay secure while they focus on what truly matters, that is growth and innovation. And that's why businesses rely and prefer cloud providers. Okay, now that you know what cloud providers do, let's take a look at the top players dominating the cloud market. So this is the revenue graph. You can see it clearly that AWS, being the industry giant, holds the largest market share, that is 31%. It's known for its wide range of services, global reach, and scalability. Then comes the Microsoft Azure, holding the 20% of the market. Then comes our Google Cloud, which holds nearly 12% of the market share. And then comes other notable players like IBM Cloud, Oracle Cloud, and Alibaba Cloud, serving major industries and regional markets offering specialized solutions. As we already saw, the top cloud providers in the market. The first one is AWS, the largest and most widely used. Then comes our Microsoft Azure, which is popular for enterprises and Microsoft users. Then comes Google Cloud Platform, which is strong in AI and data analytics capabilities. Then comes other notable players like IBM Cloud, Oracle Cloud, Alibaba Cloud, etc. These providers are in fierce competition, but each has its own strengths, so choosing the right one depends on your own business needs and specifications. Now let's see the biggest player in the cloud space, that is AWS, which stands for Amazon Web Services, which was launched in 2006, as AWS was the first major cloud provider and has become the go-to choice for startups, large enterprises, and even governments worldwide. But why is AWS so popular? It provides vast range of services, that is over 200 services covering everything from computing to the AI. Second, it provides global infrastructure. The data centers, called availability zones, in regions are spread all across the globe. Third, that is reliability and scalability. It is trusted by companies like Netflix, Airbnb, and even NASA. Now let's see what are some AWS popular services. For the compute, EC2, which provides virtual machines to run your applications. Then comes Lambda, which is widely used for serverless computing. Remember the function as a service model? Yep, that's Lambda. Then comes the storage. For that, S3, which is a scalable object storage, which provides storage for files and backups. Then comes EBS, that is block storage for virtual machines. Then comes the databases. AWS provides RDS and DynamoDB. RDS is managed relational databases like MySQL and PostgreSQL, while the DynamoDB is a NoSQL database for high-speed applications. Then comes AI-enabled. AWS provides platforms like SageMaker, where you can build, train, and deploy machine learning models easily and smoothly. It also provides the recognition, where it provides the analysis tools for images and videos too. Yes, it can recognize faces and objects. So, that's AWS. Powerful, versatile, and the market leader. But what about the competitors? Yeah. How does Microsoft Azure stand out? And why do companies choose Google Cloud for AI projects? Now, next up, let's see and talk about Microsoft Azure, the second largest cloud provider launched by Microsoft in 2010. Azure is one of the top cloud provider. But why is it so popular? Well, imagine you're already using tools like Microsoft 365, Teams, or even Windows servers in your company. Wouldn't it be convenient for you if the cloud platform just clicked with everything that you're already using? Well, that's exactly where Azure shines. It provides seamless integration with all the Microsoft products. It is the second largest cloud provider with around 20% of market. Impressive, right? Now let's see what are some popular Azure services. For the compute, it provides virtual machines. Here you can run various operating systems and applications as well. And then it also provides Azure Functions for serverless computing, which is perfect for event-driven applications. Then for the storage, Azure provides blob storage, where you can store massive amounts of unstructured data as well, like images or videos. Then it also provides Azure Files, which is used for file sharing across multiple machines. For the databases, it provides you with SQL database, which is fully managed relational database. Then Cosmos DB, which is globally distributed NoSQL database with ultra low latency. This is a major fact about Cosmos DB, that it is globally distributed NoSQL database with ultra low latency. Then for the AI and analytics, Azure provides AI tools for speech recognition, computer vision, and more. It also provides Azure ML, where you can build and deploy ML models without starting from scratch. Now here's a quick thought. If AWS is like the popular all-rounded charmer in the class, Azure is a super organized one who always has the notes in sync with the teacher. Like Microsoft tools in this case. Got it? Now, let's meet the third largest player in the cloud game. That is Google Cloud Platform, or GCP, which was launched in 2008 by Google. GCP is like tech-savvy friend who's really good with data and AI. Companies focused on big data analytics, AI, and machine learning often turn to GCP. Why? It already holds a market share of around 12% and it's growing really fast. Now let's take a look at the popular GCP services. For the compute, it provides compute engines where the virtual machines are tailored to your needs. Actually, they are tailored to your own specific needs. Then for the serverless execution, it provides you with cloud functions. For the storage, it comes with cloud storage, which is reliable object storage for files, backups, and media. It also provides you with persistent disks, which are durable and high-performance storage for virtual machines as well. For the database, it provides you with BigQuery, which provides super fast data analytics, handling massive data sets with ease. It also provides you with FileStore, which is a NoSQL database for building scalable and real-time apps as well. Then for the AI and ML, it provides TensorFlow, which is the open source machine learning framework, and yes, it's Google's. Then it also provides AutoML, which helps you to build custom ML models with minimal amount of coding. Then Vertex AI, which provides you with end-to-end platform for ML model deployment and management. Fun fact, have you ever used Google Maps or Google Photos? Yep, that also comes under GCP. AI working behind the scenes. So there you have it. AWS, the versatile leader, Microsoft Azure, the enterprise favorite with seamless Microsoft integrations, Google Cloud, the go-to choice for the data-driven and AI-powered solutions. Now let's see how to choose which provider is best for you. Let's break it down with the help of the comparison table here. For the business needs, when it comes to AWS, it is great for scalability and a wide range of services as well. and it is ideal for businesses of all sizes needing global reach. While for the Azure, it is best if you are heavily using Microsoft products, where you can seamlessly integrate it with the tools like Office 365 and Windows Server. While for the Google Cloud, it is perfect for AI-driven data-heavy workloads and startups looking for innovation and speed. Second point, that is pricing. AWS offers pay-as-you-go with options like reserved instances for cost savings on long-term use, while Azure provides volume-based discounts, which is ideal for large enterprises planning for long-term usages. Then Google Cloud features per-second billing with sustained use discounts, which is great for the cost-conscious projects as well. For the third point, that is performance and availability. AWS has the largest global infrastructure, which is also reliable for businesses needing worldwide availability, while Azure is strong in hybrid cloud solutions and is trusted by enterprises for consistent performances. Then, the Google Cloud excels in AI services and resources with high-speed data processing, which is perfect for analytics-driven applications. The fourth point, that is security and compliances. AWS offers strong compliances with standards like GDPR and HIPAA, which is suitable for sensitive industries, while the Azure matches AWS in compliances, making it a solid choice for regulated industries as well. Then comes the Google Cloud, which focuses on advanced security with robust measures for data protection and enhancements. So now, which cloud is best for what? When it comes to AWS, companies needing global services and a broad range of services and solutions, this is the best one to go with. While for the Azure, enterprises relying on Microsoft products and hybrid environments can be the choice. Then lastly, for the Google Cloud, the businesses which are more focused on AI, data analytics and cost efficiency, this is the best option for you. So that was it. A quick rundown. Now you can choose the provider that aligns with your business goals and tech needs. Not to forget, each provider has its unique strength and businesses should choose based on their needs, budget and existing tech stack. Now that you have got a solid foundation in cloud computing, it's time to dive into the core concepts and understand what truly powers the cloud. These are the essential building blocks that you will need to understand how the cloud operates behind the scenes. So let's begin by understanding what are the core concepts of cloud computing. Speaking of it, cloud computing is a powerful and transformative technology that enables the organizations to leverage computing resources without the need for any kind of heavy investments into the physical hardware. But how does this thing actually works? It's all because of these core concepts that keep everything running smoothly. So let's see what are those. The first one is virtualization, second are containers, the third is serverless computing, fourth is scalability, fifth is elasticity, and sixth is, the most importantly, cost optimizations. So first, let's see what is virtualization. Virtualization is the process of creating virtual versions of physical hardware resources such as server, storage systems, devices or networks. To make things even more simpler to understand, let's take an example. Imagine you are having one giant pizza, but instead of giving the whole thing to just one person, you slice it up into many pieces so that multiple people can share it and enjoy it. Virtualization works the same way. It's the process of creating virtual versions of physical hardware resources like server, storage or networks so that they can be shared among multiple users. Now let's see what are the benefits of virtualization. First one is efficiency. What does this mean is, you can maximize the hardware usage without wasting resources by creating a multiple virtual versions of it. The second is cost savings. Here you no need to buy tons of hardware. You can rent whatever you need virtually. The third one is flexibility. Here you can also run different types of operating systems and apps simultaneously on your system. The fourth one is isolation. Here each virtual machine works independently so that one issue won't affect the others. So this was about virtualization. But now, how does virtualization actually works? Cloud providers use virtualization to host multiple virtual machines on a single physical server, as you can see in the picture. Here, each VM acts like its own mini computer. You seeing this? VM guest 1, VM guest 2, VM guest 3. That is how each VM acts like its own mini computer, with its own operating system, apps, but they all are sharing the same hardware underneath. Think of it like roommates sharing an apartment. Everyone has their own room, but they share the kitchen and living room. That is the hardware resources in this case. So that was it for the virtualization. Next we will see about what are containers. Alright, let's take an example so that will make things easier for you to understand. Imagine you are packing lunch. You put the sandwich, salad and dessert into 3 separate containers so that they don't mix with each other but can still be carried together. The containers in cloud computing works exactly the same way. Here you can package an application along with everything it needs, like the code, libraries and dependencies into a single unit. This means the app can run anywhere without any kind of issues. So by the formal definition, containers are lightweight portable units that package an application and all of its dependencies such as code, libraries and runtime together to run consistently across any computing environments. Now let's see what are the benefits of containers. The first one is portability. Here you can run the same container on any machine so that there will be no issues if we switch the machine. The second one is efficiency. Containers are lightweight and can start up really super fast. The third one is isolation. Each container runs separately so that the apps don't interfere with each other. The fourth one is scalability. The containers can easily scale up or down based on the demand. So, how does containers work? Unlike virtualization, which uses the full-blown virtual machines, containers share the operating system, but keep the app environments separate. Think of it like a hotel, that is OS in our case, with different rooms that are the containers, and the guests in each room have their own privacy, but they all use the same building structure and services. So that's how it works. The most popular containers are Docker and Kubernetes. You might have heard about them, don't you? So the next up, that is, we'll see serverless computing. And no, it doesn't mean that there are no servers. There are servers, but you don't have to manage them. The cloud provider takes care of that for you. So what is serverless computing? Serverless computing is a cloud service model where developers write and deploy code without managing or provisioning any kind of physical infrastructure. The cloud providers handle the underlying servers and scaling and all the maintenance of it as well. For that, let's take an example here also. You're at a restaurant, you order the food, it gets served and you enjoy without worrying about cooking, cleaning, handling anything. Just order, it gets served and you enjoy it. That's how serverless is like for the developers. They write code and the cloud provider runs it automatically whenever the trigger happens. We have seen this before, didn't we? So what are the benefits of serverless computing? The first one is there is no need of managing any kind of infrastructure. You only focus on your codes and not on the servers, and everything is handled in the backend by the cloud service providers. The second one is automatic scaling. The functions you write here can scale up or down depending on the usage and on your needs. The third one is it is cost effective because you only pay for when your code actually runs. No idle charges of the servers. And the fourth one is faster market time. Here you can deploy apps faster without any backend headaches or managing any kind of infrastructure or servers. But how does this actually work? In the serverless computing, the code that are your functions are triggered by the events like HTTP requests, a file upload, or a database changes. Imagine flipping the light switch. The light, that is the code here, turns on only when you need it. No power wasted otherwise. Just like that. And the popular tools for serverless computing are AWS Lambda, Azure Functions, and Google Cloud Functions. Now moving next, let's see what is scalability in the cloud computing and why it is so important. So basically scalability means the cloud's ability to handle growth without breaking anything. The formal definition goes like scalability refers to the ability of a cloud system to handle a growing amount of work or its potential to accommodate to the growth that is necessary and demanding. To understand this in a simpler way, let's take an example of an ice cream truck. On a hot day, you need more staff to serve the crowd, but on a cold day, fewer people show up, right? And that's how scalability works. Scalability in the cloud works similarly. It allows resources to expand or shrink based on the demand without any wastage of the resources. That is the most important thing, without any wastage of resources. So basically, there are two types of scaling. The first is vertical scaling. Here you are to add more resources like CPU, RAM to an existing machine, like upgrading your phone to a newer model. The second one is horizontal scaling, or another called as scaling out. Here you have to add more machines to handle the load, like opening more ice cream trucks to serve more people. So what are the benefits of scalability in the cloud computing? The first one is improved performance. Here you can handle more users without any kind of lagging. The second one is it is cost effective. Here you can scale down whenever the demand drops to save money that will be wasting on the idle or extra resources. The third one is business growth, as it supports increasing workload seamlessly and there is no any kind of wastage of the resources here. So that was it for the scalability. Next we'll see what is elasticity in the cloud computing. Yeah, it is closely related to the scalability, but there's a difference. Elasticity is about automatic scaling. The system detects the change in demand and adjusts the resources on the fly. The formal definition goes by elasticity is the ability to automatically adjust the amount of cloud resources, that is compute, power, storage, which can go up or down based on the real-time demand. It involves adding resources to handle increased demand without affecting the performance of the system. To understand this easily, let's take an example of a self-driving car that speeds up or slows down depending on the traffic rate without you touching the steering wheel, accelerator, or brake. And that's how elasticity works. So what are the benefits of elasticity? The benefits of elasticity are, first is on-demand resource adjustment, as you don't have to do any kind of manual intervention. It adjusts automatically. The second one is cost optimizations. Here you only pay for what you actually use, nothing more, nothing less. The third one is improved user experience, as it prevents slowdowns during high traffic times. As we already seen how it works, right? I will read it again for you. Cloud resources automatically scale resources in response to any kind of change in the demands. When the demand decreases, resources are reduced to save the costs. But when the demand increases, resources are again brought into the usage so that everything runs smoothly. That's it. Now the next thing is, what is cost optimization? Cost optimization in the cloud is all about reducing the expenses while keeping your services efficient, reliable, and high performing. It's like getting the best value for your money without compromising the quality. It also involves strategies and tools to reduce the cloud service expenses while maintaining the performance and reliability of your application or systems. So, there are several techniques that are used to optimize the cost. The first one is using reserved instances. Here you can commit to certain resources like reserved instances for 1 to 3 years and again enjoy the significant discounts, that is up to 75% compared to on-demand pricing, which is perfect for predictable and long-term workloads. The second one is auto-scaling, where you can automatically add or remove resources based on the real-time demand. It is best in case when you have to handle peak loads without overspending when demand even drops. The third one is right sizing, which means matching your resources to actual workload needs. Like, why pay for an 8-core server when you can handle everything on a 4-core one, right? That is how it works. Now the fourth one is using cost management tools, which are already provided by every cloud service provider. For example, AWS Cost Explorer or AWS Budgets, Azure Cost Management, and Google Cloud Billing helps to track, analyze, and control your expenses. So what are the benefits of cost optimization? The first one is it prevents resource wastage. Here you don't pay for idle or unused resources. You only pay for what you actually use. The second one is here you get to control the scalability costs, as you can scale efficiently without overspending. The third one is you can manage the dynamic usage patterns and adjust the resources as the demand fluctuates. The fourth one is budget control. Once you enable the budget control, you can stay within the spending limits, and even when you exceed the spending limits, immediately the alert is issued on your Gmail account that you have used in it. The fifth one is cheaper cloud billing. When you learn to manage these resources and services smartly, you can save a huge amount of money on this. So, cost optimization isn't just about saving money, but it's also about spending smarter while keeping your system reliable, efficient, and smooth. Pro tip: please regularly review your cloud usage and adapt to your strategies as per your business or project evolves. These were the concepts which are seen as the backbone of modern cloud solutions, helping businesses innovate faster, smarter, and speedier. So that was it for the core cloud concepts. Let me know if you have any doubts in the comment section. And let's move forward to the quiz now. Alright, now that we have explored the foundation of cloud computing, it's time for a quick knowledge check. Let's see how much you understood. So beginning with the first question, what is the key difference between on-premises and cloud computing? And your options are: A. Cloud computing requires physical servers while on-premises does not. B. On-premises needs in-house infrastructure while cloud computing provides resources over the internet. C. Cloud computing is free while on-premises always has costs. D. On-premises is more scalable than the cloud. Think about it and answer. Alright, the answer is option B. On-premises needs in-house infrastructure while cloud computing provides resources over the internet. Yes, cloud computing lets business access computing resources without any kind of maintenance of their own hardware. Alright, let's see the second question. That is true or false? So the question is, serverless computing means there are no physical servers involved. What? Do you think that this is true or false? Tricky, right? Think about it. Alright, it is false because servers still exist. But in serverless computing, you don't have to manage them. It has already been taken care by the provider itself. Now moving to the third question, which is a scenario-based question. The question is, a healthcare company needs to store patient records and comply with strict data privacy laws like HIPAA. Which cloud computing model should they choose? And your options are: A. Public cloud, B. Private cloud, C. Hybrid cloud, D. Multi-cloud. What do you think? Which suits the best? And the answer is B. Private cloud. Because it ensures maximum security and compliances with the healthcare regulations. Thus, a private cloud would be the best option to go with. Now moving to the fourth question. Here, a company uses AWS for hosting its website but relies on Google Cloud for AI-based customer insights. What cloud strategy are they following and which is the most suitable here? So your options are: A. Public cloud, B. Private cloud, C. Multi-cloud, D. Hybrid cloud. So what is your guess? Yeah, it's C. Multi-cloud. Because multi-cloud means using multiple cloud providers for different services, which is best when it comes to AI-based customer insights. So moving to our fifth question. Here, a startup wants to launch a mobile app but doesn't want to worry about its infrastructure, scaling, or any kind of updates. So which cloud model is the best fit for this? And your options are: A. Infrastructure as service, B. Platform as a service, C. Software as a service, and D. Hybrid cloud. What do you think about this? Exactly. It's B. Platform as a service. It gives developers a platform to build and deploy apps without managing any kind of infrastructure. And here, everything they need to build and deploy applications without any kind of management issues. Thus, platform as a service serves the best. Now moving to the sixth question. Now, a company subscribes to Google Workspace, that includes Gmail, Docs, Drive, for their daily business operations. Which cloud model are they using here? Remember about the service models that we have studied earlier? Exactly. So the options are software as a service, infrastructure as a service, platform as a service, function as a service. So what works right here? The answer is software as a service. The applications are fully managed and accessed via the internet. Thus, the right answer is software as a service, because Gmail, Docs, Drive, this all are softwares provided over the internet, right? So here's your answer. Now coming to the seventh question. Here, a global e-commerce company needs the cloud provider with the wildest global reach and largest data center network in the world. which provider should they choose? And your options are A. AWS, B. Azure, C. Google Cloud, D. IBM Cloud. No, come on, this is so obvious. Yes, you're right, it is AWS. AWS wins this one as it has the largest cloud infrastructure across the globe. Now, moving to the next question, that is eighth one. A startup wants to build an AI powered chatbot that actually uses advanced machine learning models. Which cloud provider would be the best choice for this? And your options are A. AWS, B. Google Cloud, C. Azure, D. IBM Cloud. What do you think about this when it comes to AI? Yep, your guess is right. It's B. Google Cloud. It excels in terms of AI/ML services. It is a leader in AI/ML services with tools like TensorFlow and AutoML. It simplifies the process of building an AI-powered chatbot. Thus, Google Cloud would be the best fit for this. Now, moving forward with the ninth question, an e-commerce site experiences sudden traffic spikes during sales events and needs a cloud solution that automatically scales based on the demand. What should they use? And your options are A. Virtual machines, B. Auto scaling, C. Static hosting, D. On-premise servers. Yes, you guessed it absolutely right. The correct option is B. Auto scaling, as auto scaling adjusts resources in real time based on the traffic demands. Now, coming to the very last question. A gaming company wants to run a multiplayer game where servers need to handle unpredictable spikes in users. Which cloud computing model should they focus on? And your options are A. Virtualization, B. Elasticity, C. Software as a service, D. Edge computing. And when it comes to handling unpredictable spikes, the correct option is B. Elasticity. Elasticity ensures the game servers scale up and down dynamically based on the demands. And that's it for the quiz. How did you do? If you got most of these questions right, you are on the way to mastering the cloud. If not, don't worry. Every expert was once a beginner, so keep learning. So, we have learned all about cloud computing as for the foundation, right? But what if you're asked about it in an interview? No worries. Here are some golden tips to ace any cloud related discussions. The first one is explain concepts clearly and concisely. Keep your answers simple and to the point. No overcomplicated jargon at all. Now, the second is use real world examples. If you are asked about cloud deployment models, why not mention how Netflix uses AWS or how Lego balances security and scalability with a hybrid cloud model? Just like that, use real world examples to support your answers. Now, coming to the third point, that is compare different cloud models and services. Like, why would you choose infrastructure as a service over platform as a service? And don't just define it, explain when to use what. That makes you stand out. Now, the fourth one is discuss security, cost, and scalability. These three factors drive cloud adoption. Show awareness of how businesses balance them in an effective way. And the last one is show understanding of multi-cloud and hybrid trends. For example, like companies are no longer relying on just one cloud provider nowadays. Highlight why businesses mix AWS, Azure, and GCP for better optimization and performance. Follow this and you won't just answer interview questions, you will impress them. So congratulations, you have officially completed this cloud computing course. And here, you have built a strong foundation in cloud computing from its core concepts to the real-world applications. You also understood how businesses use cloud services and how to choose the right deployment and service models. Most importantly, you are now ready to take the next step, whether it's exploring hands-on labs, preparing for the interviews, or even getting certified. But remember, cloud computing is always evolving. The more you explore, the better you will get. Keep learning, keep experimenting, and most importantly, keep innovating and practicing.
We discussed about the data centers, right? We discussed that an organization would require data center, and those data centers will have the servers inside them, right? So the servers are deployed inside the data centers. Servers are deployed where? Within the data centers. Now the question comes in that what about the data centers which are owned by Amazon Web Services? Because your organization, for example, you work for a company like Accenture, Wipro, HCL, Infosys, JP Morgan, AIG, Apple, right? Now, when these companies start using cloud computing vendors like AWS, Microsoft Azure, GCP, Salesforce, these companies become their customers. For example, Apple says we want to use Microsoft Azure to deploy our workloads and applications, right? So in that case, Apple would be the customer of Microsoft Azure or Microsoft. Okay, so think of yourself as a customer, or you are the employee for working in that organization who's the customer of any one of these three providers. The next question that comes in is that how exactly you leverage that infrastructure which is owned by your cloud vendor. Let's suppose you're working for Apple, or let's suppose you're working for Netflix. Netflix is a customer of AWS. Now, Netflix is running all its videos, its applications, workloads on AWS. Now, being a part of Netflix, you have to understand exactly that how Amazon Web Services has scattered its data centers, or how it is managing its data centers in different parts of the world. Because Netflix doesn't offer services only in US. It offers its services in a lot of countries, including India, right? So you have to make sure that how you understand its global infrastructure of AWS, you understand that how they place the data centers in different parts, or in different countries or different continents. Where we discuss. That's where the concept of the global infrastructure comes into play. Global infrastructure means that you understand exactly that how our cloud provider, which is Amazon, has placed its data centers and clustered those data centers in a different location, or what's exactly, not exactly location, but exactly how these things are being placed in let's suppose in Africa and India, in US and Europe, how they have clustered their data centers in these different countries. So in this case, we need to understand concept that's called global infrastructure. Let's try to understand that. Okay, so we're trying to understand first topic. I would say that of AWS, which is the actual topic. The name of the topic is AWS Global Infrastructure. Now, it consists of different components, different parts like regions, availability zones, edge locations. We have, for example, local regions, local zones. I'm sorry, local zones, regions, local zones, availability zones. Uh, we also have edge locations, but there will be two things I'll be discussing with you right now: regions and availability zones. Edge locations, local zones, we'll discuss afterwards. Okay, this discuss the AWS global infrastructure. Let's try to understand that. Okay, so the very first component or the part of this infrastructure includes a region. Okay, what is an AWS region? An AWS region is nothing but it's a geographical region. It's a geographical location, or a geographical region, or a piece of land which consists of which consists of a cluster of data centers owned and managed by AWS. Okay. What's a cluster? What do you mean by cluster? Some people ask me this question: what do you mean by cluster? Cluster means group, right? So a region is nothing but it's the geographical location. It's a basically it's a piece of land. It can be on the name of any city, uh, or maybe, for example, most of these are based on cities or named after countries. So it can be any name. It can be based on a city. Like for example, in India, there are two regions: Hyderabad and Mumbai. Uh, for in Australia, Sydney and Melbourne are two regions. For UAE, they have a separate region. For let's suppose for South Africa, Cape Town, there's a separate region. Singapore is a separate region, right? Japan is a separate region. A region is nothing but it's a geographical location which consists of a group of data centers which are being owned and managed by Amazon Web Services, which is our cloud provider. We are the customers, right? Like let's suppose we work for Netflix, we work for JP Morgan, we we use AWS to deploy our resources into. So those cluster data centers are used by us, right? But who owns and manages those data centers or cluster data centers? It is the cloud provider. Okay. So a region is nothing but it's a piece of land. It's a geographical location where the cluster of data centers, the group of data centers which are being owned and managed by Amazon Web Services exist over there. I would say it's a geographical location or it's a piece of land where Amazon's owned and managed data centers run and they are being operated by Amazon. So Amazon Web Services says, let's suppose in Cape Town, I have my 3 data centers running. So I mark Cape Town as a region, right? So a region is a geographical location which consists of data centers, a chain of data centers. Now, in these cluster of data centers are being denoted by a special term. Okay. So what is that special term that we use over here? This cluster of data centers that we these cluster of data centers are denoted by a term that is called availability zones. What's that? It's called availability zones, right? Okay, availability zones in the short form are called AZs. These are the data centers or these are the facilities consisting of racks of servers. These are data centers only, right? So these are the facilities which houses racks of servers, right? These are the facilities which consist of racks of servers. Now, one availability zone or one AZ is equal to one or more data centers. A single AZ can have one or more data centers, okay? And in each region, there are at least 3 AZs, right? To make your data more redundant, to make your work applications more available. So basically, these are the 2 terms you have to remember and learn. A region is a geographical location which consists of a cluster of data centers. These cluster of data centers are called availability zones. So availability zones are the data centers only, or they're the facilities which consist of rack of servers. One AZ equates to one or more data centers, and each region will have at least 3 AZs. There could be more than 3 AZs, but you'll find minimum 3 AZs or availability zones. Fine. These are the 2 terms you have to remember. I'll just give you a few examples over here so that you understand that and understand this concept in and out. Okay. Now I've just logged into my AWS Maven console to my account. Now you're going to be seeing one thing is that once I just go to the top right hand corner, right? I'm talking about this thing where you see my this cursor over there. In this case, you're going to be seeing that these are the listed regions over here: North Virginia, Ohio, California, Oregon, Hyderabad, Melbourne, Mumbai, Seoul, Singapore, Sydney, Tokyo, Canada, Frankfurt, Europe. These are the existing regions, right? Frankfurt, Ireland, London, Paris, Stockholm. Uh, we have Cape Town, Hong Kong, Jakarta, Milan, Spain, Zurich. Right, so these are the regions. It shows exactly the regions and it gives the details of the regions and the availability zones which are owned by AWS. Okay, so in this case, if I just go back and show you exactly, this is the map. So as of now, they have 31 launched regions. So presently, when I'm talking to you, they have 31 running regions, which are running to 24 cross 7, right? This is the map that shows up. On this map, the green dots that you can see, these are the existing regions. That's why we say a region is a physical location. It's a geographical location. It's a piece of land. For example, so the green dots you can see, those green dots represent regions. For example, this green dot represents Sydney. This one Melbourne. This one Jakarta, Hyderabad, Mumbai, UAE, Bahrain, Spain. This is, for example, North Virginia. This is, for example, Milan, Spain, Ireland, right? So the green dots represent existing regions. Each region is a physical location which consists of a chain of data centers or a group of data centers. And those group of data centers are called as availability zones. Now, the one that you can see in the form of red dots, these are the upcoming. They are coming soon, which means that they will be set up in the next few months. It's work in progress. Amazon is still setting them up because launching a chain of data centers take a lot of time, and it is still in progress. And very soon you're going to be seeing these data centers being showing up. So as of now, you can see the exact details. There are 99 availability zones. Now, each availability zone can be one or more data centers. Generally, we assume it's one data center. Okay. So let's suppose there are 99 data centers. There could be more than 99. 99 data centers in 31 geographic regions. All right. With announced plans for 15 more data centers or more than 15, could there could be a possibility that one AZ because there are few AZs which consist of two data centers. So 15 or more availability zones in 5 more regions in Canada, Israel, Malaysia, New Zealand, and Thailand. So I think by the end of this year, you will be seeing most of these the regions being deployed. Okay, I think Canada will show up because they announced Canada region in Montreal few months back. But let's see. Okay, so these are the regions which exist, and some of the regions they are still in plan. They will be deployed very soon. Fine. Now, I can also show the definition just in case if I just go to this other link. Um, okay, so you can see that AWS has a concept of a region, which is a physical location around the world where we cluster the data centers. We call each group of logical data centers as an availability zone. So that's why I said an availability zone can be one or more data centers. And there are 3 availability zones at least in one region. Okay. So AWS has a concept of a region, which is nothing but it's a physical location around the world where we cluster the data centers. And this group of logical data centers are called as availability zone. Each region consists of a minimum of 3 isolated, physically separate AZs within a geographic area. So each region will consist of 3 availability zones within a geographical area or in a region, so that uh, they isolate any hardware failures, any power outage. So I think there's a distance of around 50 to 60 kilometers between each of the AZ. That's the minimum distance. So if one AZ, so the distance between two AZs is at least 50 to 60 kilometers, right? So because if one AZ goes down because of a power outage, maybe because of floods, natural disaster, you can easily have other regions, other availability zones serving you the services in form of workloads and applications running inside them. Now, what is an availability zone? An availability zone, in the short form we call it as an AZ, is one or more discrete data centers with redundant power, networking, connectivity in an AWS region, right? So it's a kind of an AZ is equal to one or more data centers which has its own power, networking, connectivity inside that region. Okay, let me just give you two, three examples, then I'll take the questions forward. Let's take 1 or 2 examples. First thing first, we need to understand that each region is given a special name. For example, the one which is labeled as US East 1, that's the North Virginia. What's that? North Virginia. So Basically, they don't go with this with the geographical names. They give their own special names. For example, the one which is the US East one. US East one means that they're talking about the Northern Virginia, right? So for California, it's okay. How they labeled US East one? North Virginia is on the east coast of US, right? And this was the very first region on the east coast of US. So they labeled as US East one. Now, by the way, US East one is the very first region Amazon set up when they started giving AWS as, or when they started as a cloud provider. So this is the Amazon's web services first region. So this is the on the east coast of US, the very first region. So they labeled as US East one. Ohio is the second region on the east coast of US. So it's US East two. On the west coast, the first region is California, US West one, and US West two is Oregon, the second region on the west coast. For example, let's take in India we have AP South one. AP stand for Asia Pacific. In the southern region, the very first region was Mumbai, AP South one, and the second was Hyderabad, so it's AP South two. You don't have to learn these names. So they've labeled these names. They've given us the abbreviation or special names for these different regions. Okay. So for example, let's go with US East one, which is North Virginia. Okay, let's take this one. Uh, let's go with Mumbai. Okay, Mumbai was the very first region in India, launched a few years back. I think 2017 or 2018. I'm not sure about the exact date, but anyhow, every region you have, every region is a separate infrastructure on its own. It is independent from other regions. Fine. For example, if you deploy my resources in Mumbai, they will stay in Mumbai only. They will not be visible. I would say they will not be the part of Hyderabad or California or Virginia. So assume that every region is a complete infrastructure on its own or by itself. So, for example, if I use Mumbai and deploy my resources in Mumbai, they stay in Mumbai. Of course, I can access them remotely from other location, but they would be the part of Mumbai region. That's why you have to switch dashboards between regions, right? For example, right now I'm in Mumbai dashboard, so I can access my resources in Mumbai. Similarly, if I switch to California, so in this case, I'll be accessing my resources in California. Understood? So each region is its own. It's an infrastructure on its own. I would say it is a complete infrastructure which is independent from other regions. That's the reason you have to switch back and forth between different regions to access the individual dashboards. So if I deploy my resources in California, they stay in California. If I have to, let's suppose, access my resources in Sydney, I have to switch to Sydney's dashboard. That's the reason once I switch between different regions, the link or the URL changes at the top, right? So every region is isolated or it's kept separate from other regions. Uh, if I say it is a separate entity, this means that it has its own identity, right? So to access and deploy the resources in Sydney, I have to explicitly go to Sydney, switch to the dashboard, and start launching my resources inside Sydney. I can't deploy resources in Sydney while just using Melbourne dashboard. I can't do that. Okay, so that this thing you have to understand. Okay, let's take the example of Mumbai. I was trying to give you some examples. Mumbai is labeled as AP South One. This is a special name assigned to it. Okay, now let's suppose I want to show you. I want to see the availability zones in Mumbai. I need to see the availability zones inside Mumbai. So I go to EC2. EC2 stands for Elastic Compute Cloud, which helps me to deploy the virtual machines in the Amazon's cloud. So if I want to deploy my virtual machines or the instances or EC2 instances in the cloud, I use EC2 dashboard, which stands for Elastic Compute Cloud. Very well. Now, if I just go to Mumbai right now, let me show you the Mumbai region. Okay. So in this case, this is the region of Mumbai, which is labeled as AP South 1. What's that? It is AP South 1. Okay. Inside AP South 1, I have three availability zones: AP South 1A, AP South 1B, and AP South 1C. Right? So, what is the AP South 1? It is the region of Mumbai. This is the one. So, AP South 1A, 1B, and 1C are the three availability zones which are interconnected with high speed fiber optic cables. Okay. So, these are the three clustered interconnected availability zones which operate inside Mumbai. Fine. I'll give you two or three examples, two or three more examples to give you some more clarity. Let's go to Sydney. Sydney is labeled as AP Southeast 2. Okay, let's go there. Now, AP Southeast 2 is which region out there? AP Southeast 2 is the region which is the Sydney. So, AP Southeast 2 is Sydney region, or the region of Sydney. So, AP Southeast 2A, which is this one, 2A, 2B, and 2C. These are the three interconnected regions, sorry, availability zones. What are these? I'm sorry, it was slip of tongue. These are, what are these? These are the three availability zones or three AZs. Fine, these are three AZs which are interconnected with high speed fiber optic cables. And where they're being deployed? They're launched inside this region, which is Sydney, which is AP Southeast 2. So, AP Southeast 2 is the region of Sydney, which consists of three interconnected availability zones: AP Southeast 2A, AP Southeast 2B, and AP Southeast 2C. Let's take one more example. Let's jump to the next region, which is Frankfurt. Frankfurt is EU Central 1. If you click on that, you will see that immediately the page will change. The details will change automatically. So, Frankfurt is represented using this term, which is EU Central 1. It's the central part of Europe, Frankfurt in Germany. So, EU Central 1. It consists of three interconnected availability zones. They're labeled as EU Central 1A, EU Central 1B, and EU Central 1C. So, these are the three AZs interconnected and located inside EU Central 1, which is the Frankfurt region. So, a region is a geographical location which consists of at least three AZs or availability zones. These availability zones represent group of data centers. There are at least three AZs inside a region. At least. I'll show you. North Virginia consists of most of the AZs. If I go to North Virginia, the very first region which was set up by Amazon Web Services. So, North Virginia is labeled as US East 1. What is that? It's the US East 1. Fine. It consists of these six availability zones: 1A, 1B, 1C, 1D, 1E, 1F. So, six availability zones inside the region of North Virginia, which is US East 1. Okay. So, this is the concept of regions and availability zones. Now, the thing is, I know that this question will come up, that how we achieve high availability between them. Can we use all the regions or all the availability zones? The answer is yes. We have to make use of some tools like load balancing, global accelerator, Route 53, auto scaling to disperse and scatter your resources across these AZs and regions and use them as a part of a single application. How they cluster the data center? Basically, the data centers are interconnected with high speed fiber optic cables. That's how they cluster them. Okay. I guess this is clear. Now, how to make use of all of them or some of them? We're going to be discussing the services. Based on the services that we discuss, we're going to be understanding each one of these different, I would say, how to use them. Right now, we are just seeing them how that these are the list of regions, these are the list of availability zones, but how to make use of them, we'll be discussing that when we start with the process of launching of services. Right? For example, if we deploy the servers or virtual machines, I can explicitly choose the region of my choice and the availability zone of my choice. I can do both. But once we start with the launching process, we start understanding that stuff, how to use them. Okay. So to access the availability zone, you have to go to EC2 dashboard, and there's the service health status or service health dashboard. This is where you can see a list of availability zones inside the region. All right, that's about the stuff.
Just a quick info, guys. Intellipaat brings you executive postgraduate certification in cloud computing and DevOps in collaboration with I have Divya Sampar, IIT Roorkee. Through this program, you will gain in-demand skills like AWS, DevOps, Kubernetes, Terraform, Azure, and even cutting-edge topics like generative AI for cloud computing. This 9-month online bootcamp features 100 plus live sessions from IIT faculty and top industry mentors, 50 plus real-world projects, and a 2-day campus immersion at IIT Roorkee. You also get guaranteed placement assistance with 3 Azure job interviews after entering the placement pool. And that's not all. This program offers Microsoft certification, a free exam voucher, and even a chance to pitch your startup idea for incubation support, up to rupees 50 lakhs from IAP Divya Sampark. If you are serious about building a future in cloud and DevOps, visit the course page linked in the description and take your first step toward an exciting career in cloud technology.
This is the AWS console, what you see on your screen. This is the AWS UI from where we are going to work. Okay, from where you will work in any real world project. Okay, so this is AWS console. Here you will find all the services. Okay, so this is your AWS console, and here you will find all the services. See, simple logic. Whatever we can do in local data center, okay, whatever we can do in our local data center, everything can be done on it. Okay, so if you are a data engineer like me, I can do data engineering work without cloud, and I can do it on cloud. If you are a DevOps engineer, you can do DevOps work without cloud, or you can do DevOps work. Okay, no matter in which domain you are working, you're a database administrator, you're in cyber security, everything can be done on. Okay, so now let's start with, and we in our course we are going to cover many services. See, here I'll show you. On the left side, you see all of this category. For example, I am a data engineer, so I work with this analytical service. Here you see there are different services, and cloud is nothing but collection of services. Okay, cloud is nothing but collection of services. Here you see all of these are analytic services, right? Like this, if you're a database administrator, these are all the database services. If you are into networking, then these are all the networking services. So we are going to understand many services across different domains. Okay, we will understand different services from different domains. Now, the very first service that we are going to start with is EC2. Okay, Elastic Compute. Okay, this is the service that we are going to understand first. Why? Why EC2? Okay, why we are starting with EC2? Because EC2 is the fundamental. Okay, see, EC2, why we are starting with this? Because EC2 is a fundamental. Yeah, see, generally nowadays, Ankit, what happens? If someone is getting into DevOps, they don't just work with DevOps, they work with either AWS DevOps or they work with Azure DevOps. Because as I said, nowadays every domain is operating on cloud. But before you understand AWS cloud, AWS DevOps, you need to understand AWS cloud first. That's the reason we need to first learn AWS. Then only we can jump into AWS DevOps or AWS data engineering. Before that, we need to understand AWS. Okay. Now see, EC2 is the fundamental service. No matter what is your profile, whether you are a data engineer, whether you're a DevOps engineer, whether you are a web developer, everyone uses EC2 because it is such a fundamental service, right? So we will understand this. But right now, if you look at your screen, you see it's very complex. There are so many things on your screen. And trust me, when it comes to UI, AWS or Amazon is very bad. Their UI is never friendly. Okay, so ignore everything that you see on your screen right now. Okay, just follow on what I'm going to show you, and I guarantee you Okay, now see, ignore everything that you see on your screen. You will not understand it. Just look at this launch instance. What is the meaning? Instance means server. Okay, instance means when I click here on launch, it will show, okay, it will show me a page where I need to provide some values and I will get my server. On your screen, you can see there is a page where there are different values. There is an entire form. Our task, our job as a cloud engineer is to provide our values in this form and we will get, right? So here, first of all, I will EC2 demo, right? What is this? This is the name of the server. Okay, this is the name of the server. But along with name, here we can add what is tag? Tag is nothing but key value. Okay, tag is nothing but key value pair. So here I can provide a key, let's say, for example, who is the owner? Who is the owner of this EC2? Here I will add a value called as Pratik. So you see, tag is nothing but key value pair. This is the key, this is the value. Okay, and it can be anything. Okay, tag is there for your convenience. It can be anything. You can provide whatever you want. Why do we provide tags? We provide tags because when we are working on a project, there can be hundreds of server. Okay, how you will identify your server? For example, here I will add one more tag. I will add a tag, let's say purpose. What is the purpose of this EC2? The purpose of this EC2 is training. So you see, we provide tags so that we can identify our server. Tags are there only for your convenience. Is it okay if I don't? Yes. It is totally fine if you don't provide any tags. Totally okay. You will not get, okay, very good. So here we provided tags. After that, you see the next thing is AMI, Amazon Machine Image. Now, what is AMI? Guys, when we talk about, can I say the two most important thing in a server is software and hardware? Correct? Can I say in a server that is a computer, a software is represented, its can I say operating system is the main software? Very good. So AMI is nothing but operating system. So if you want a Linux operating system, then select Linux AMI. If you want a Windows operating system, then select Windows AMI. If you want a macOS operating system, then select macOS AMI. So AMI in EC2 is simply the operating system. Whatever AMI you select, you will get that particular operating system. Now here, a simple use. I have a MacBook. But let's say tomorrow I need a Windows laptop. There is a task that I need to do. Let's say there is a 1 hour task I need to do, and that can only be done in Windows laptop. Now, do you think I need to go and buy a Windows laptop for a 1 hour of task? Don't you think I can simply create a EC2 for 1 hour? I will pay for that 1 hour of money and I will also be done with my task. Don't you think that will save a lot of money? Okay, I can simply create a Windows EC2 and I can do my task. I don't need to go and buy a new Windows laptop. So AMI is nothing but very good. Okay, but is it only operating system? Because see, here I'll show you. Here I'll click to browse more AMI. See, here in Quick Start AMI, you get many AMIs. You get around 45 AMI from AWS side. And you will see this AMIs will range from many different operating systems. Okay, most of the operating systems are available here. But is AMI only operating system? No. It is operating system, but AMI can be even more than operating system. Okay, for example, if you go with this AMI, you will get a simple Windows. But if you go with this AMI, you will get Windows machine, but along with that Windows machine, you will also get SQL Server. So there are some AMI that comes with extra, correct? So AMI is not only operating system, AMI is operating system, but in some AMI there can be addition. Okay. After this, you see here, these are the quick start AMI. These are the AMI provided by AWS. But then you see there is something called as marketplace here. What is marketplace? Here I will tell you a simple analogy. Guys, do you know Microsoft provided Word software for desktop user in the form of Word? Okay. But can I say in today's time, today, I can get the same Word software in my Android phone. I can get the same Word software in my iPhone also, right? If I want the same software on my Android, where I will go, very good. If I want the same software in my iPhone, I will go to. Okay. Similarly, now today we don't have our own data center. Today we are working on AWS data center. Now, how you will get the same software on AWS? That's the question. If I want the same software, how I will get it? Can I say I will have to go to this marketplace? Just like there is a Google Play Store, just like there is a Apple App Store, there is a AWS Market. Okay. So on AWS Marketplace, you will find name of many big enterprises like Cisco that are selling their. How do see? If I need a Cisco, how I will get it? I don't have my own. Okay, your data center is there in AWS physical data center. You are using their data center. So how I will get the same? You get it. You get the same software in the form of AWS Marketplace. Do you still need to pay money? Of course, yes. Do you still need to buy the license? Yes. But the way you are getting that, right? Like in the older days, we used to get our software in the form of CDs. We used to install them. But now every software you get on usage basis. This is AWS Marketplace. Now AWS Marketplace is the place where companies sell, right? So community AMI. Community AMI is the place where developer upload their AMI for free. If marketplace is the place where enterprises upload their AMI, community AMI is the place where developer like you and me, we can upload our own AMI for free. It's clear. And here you see my AMI. Now guys, think about it. We have 6,000 plus AMI in marketplace. We have 500 plus AMI in community AMI. We have 45 kickstart AMI. Even after having so many AMI, why anybody will create? Can I say for our need? For our custom, it's very easy. But why we create a tomorrow? If I need a tool in my team, if tomorrow if I need a common OS or common tool, I can create it once and I can use it every day. Or I can create it and I can give it to my okay. So this is AMI. Now in AMI, what I will do? I will go with this Amazon Linux 2023 AMI. Why this one? Because this is one of the most commonly. Okay, great. So I will show you a separate demo on. Okay, very good. So here I'll go with Amazon Linux 2023 AMI. So this was the AMI, that was software part. Now comes the hardware. Now in EC2, here you see we have something called as instance type. Instance type is basically the hardware of. Alright. Here instance type represent the hardware. And when we say hardware, what do we mean? Hardware is the CPU and RAM memory, or even. Okay. So here if I click on now you see there are more than 900. Okay. And right now again you see so many things on your screen. Okay. There are many things on your screen. Ignore all of that. Whatever you see on your screen, ignore everything. Just pay attention on this CPU and this memory. Pay attention on, right? Here you see this will define how much CPU or how many CPU your server is going to have, and this define how much RAM memory your server, right? This two columns is your main configuration. Now you tell me, if you look at this list, don't you think many of this instance type, they have similar CPU and RAM memory? Don't you think many of them have almost similar CPU, similar RAM memory? Here comes a very big question. The question is how to select a instance type for our requirement. Okay, there are so many options. There are 900 plus. See, here I will give you a process. I will tell you few steps. Okay, I will give you a process. I will give you few steps that will help you understand how to select the instance type for you. See, the very first thing you should do is to understand what is your. Okay, the very first thing we do is to understand what kind of workload. Okay, what kind of workload we are dealing. Right? Are you working? Are you working on a workload where there's a lot of computation, or are you working on a workload where a lot of RAM memory? What kind of workload you're dealing with? So see, here we have few. Okay, here is the general purpose workload. What is general purpose workload? General purpose workload is that workload where a combination of CPU, RAM memory, you require a combination of CPU, right? Here in general purpose, you require everything in balance. You require CPU, RAM memory, and nets. Nothing. Or are you working on compute optimized use cases where there's a lot of CPU power is required, where there's a lot of CPU computation required? Compute optimized are those workload where a lot of CPU is required. Memory optimized are those workload where a lot of memory is required. Accelerated computing are those workload where a lot of GPU. Sorry, this is your task. First, identify what is your workload type. Once you identify what is your workload type, after that, we need to, like, let's say we decided that we are going to work with a lot of computation. Okay, we are working on compute heavy workload. So here you see there are different C4, C5A, C71, all of these different instance. Okay, here you see whatever you see on your screen here, C7G, C7I, C6G, all of this, they are called as instance family. Okay, so once you understand your workload, then you see there are different instance family and they are basically different hardware. For example, C4 family provides you Intel hardware. But if you C5 is also Intel. If I go to C6G, C6G is AWS hardware, Graviton. If I go to C7I, this is also in. Yeah. If I go to C7A, you see it's a AMD. Okay, this is AMD hardware. So as you can see, the hardware, the instance type you have here, different instance type have different hardware. Okay, different instance type have, right? So what you can do when you're working on a project, and especially if you're a tech lead or someone who decide all of this thing, you will know what kind of workload you're dealing with. Once you identify that, you will go to this documentation and you will have to select which hardware you require. Do you require 3.7 gigahertz, or do you require more, or do you require less? Do you require fourth generation AMD hardware or second generation or third generation? So you need to decide all of this thing, right? So the very first thing is decide your workload. Then based on your hardware, whether you want Intel hardware, whether you want AMD hardware, based on the hardware required, decide what kind of instance family you will go with. Let's say for our use case is training. Okay, we don't require any. Okay, we don't require anything special. So what we will do, we will go with general purpose. And in general purpose, let's say we will go with T2 family. Require T2 family instance family. Now in T2 family, you see it is divided into T2 nano, T2 micro, small, medium, large, X large, 2X large. So T2 instance family is divided into, and all of these types, they are called as instance type. All of these types, they have different CPU and RAM. Okay, all of them have different CPU and RAM memory. So T2 Nano will give you one CPU and 500 MB RAM. But T2 Large will give you two CPU and 8 GB. You get my point? Instance family in turns divided in. So you understand the process. You don't need to start from how much CPU or RAM I require. No, you don't need to start from there. You need to start with what is my workload. Okay, my workload is general purpose. So I'm going with, let's say, T2 micro. I thought that this T2 micro hardware is good enough. Nowadays it's very simple. Nowadays ChatGPT can give you such answer very quickly. But back in the days before ChatGPT, we used to read through this documentation and we used to. Okay. So let's say I decide that I will go with T2 family. Now in T2 family, I can decide. Now I need to decide how much CPU and RAM I require. Because based on that, I will select instance type. So T2 is the family, but nano, micro, small, these are the types. These are called as instance. Our instance, whatever we create is specific to region. And region, I will come to region, the instance type. Instance types, as you can see, there are 900 plus. You will never need to customize them. You get them in all shape and sizes. Okay, but they are pre-configured, so we can't change them. In our this example, I'm going to get T2 micro. Why I will get because T2 micro is free tier clear. So here we define AMI, that is operating system of our EC2, and here we define the hardware of EC2, that is CPU and RAM. These two are the most important thing when it comes to EC2. Okay, now there are other things also remaining. We will understand them as well. But these two are the most important thing. Okay, AMI is your software and instance type is your. Okay, now here you see. Next thing we key pair. Key pair. What key pair is your password? Guys, see. Let's understand this in simple language. In our laptop, all of us have, right? Only when we provide that password, then only we get access to our laptop. Similarly, don't you think there should be a password facility for your EC2 as well? Because EC2 is what? EC2 is also computer. EC2 is also a machine. Don't you think there should be a password involved? Yes, there should be a password. So, key pair is the password of your EC2. Got it? Now, here when I click on create key pair, here I can provide the name of the key pair. Now, what is key pair? Key pair is just a file. Okay, key pair is just a file that is downloaded in our laptop. Okay, this file will be downloaded in our laptop. And whenever we try to access our EC2, and I will show you this, I will show all of this to you practically. Whenever we try to access EC2, we will have to select. If we have key pair, good, we will get access to our EC2. But if you don't have key pair, right? Now see, here I will create a key pair EC2 KP. What is today's date? Today's date is 7 June. 7 June. Okay, now you see these are the two algorithm, RSA algorithm and ED algorithm. You can select whatever algorithm you want. Okay, both the algorithm provide same security, so you can go with any one of them. I will go with RSA algorithm. All right, I will go with RSA. Okay, and here is the format. Now here also you can select whatever format you want. We will go with .pem. Okay, now you see when I click on create key pair, this key pair will be downloaded in my laptop. When I click on create key pair, this key pair will be downloaded in my laptop. Can you see when I clicked on this download symbol, here my key pair is this is the key. Okay, this key pair is downloaded in my laptop. Got the concept, guys? I will show you practically how to connect with EC2, and when we connect with EC2, how to provide key pair. The theory concept that key pair is your password. Key pair is a file that you need to provide whenever you are trying to access EC2 CD. Now, obviously, if you are talking about will be there network topic. right? What is security group? Security group is a firewall. Now, firewall, I hope firewall, security that blocks any kind of okay. Let's say your website is hosted on AWS server. Now, of course, don't want any random request from anywhere. You want to allow only accepted, only requests that are let's say within your organization. Any other request coming from any other, so firewall will block that traffic. Firewall will block unwanted. Okay, so security group is the firewall. If security group is the firewall, security group is the firewall for EC2, firewall around EC2, and security group is mandatory. You cannot have a EC2 without security. Not possible. You cannot have a EC2 without. Okay, and one default nature of security group that you need to understand is security group. Security group. So security group, basically, the default nature of security group is that it will block everything. By default, security group blocks any kind of okay, any kind of incoming traffic is blocked by security group. But here you see allow SSH traffic, allow HTTP traffic. When we select this, then this traffic will be allowed, right? So here we are creating a Linux server. So that's why it is mandatory for us to allow this SSH traffic. Because I just told you, by default, security group will block any kind of income. Okay, by default, security group will block any kind of income. Okay, only what you select here, only that, whatever you select here, only that concept. Here I'm selecting this, so my security group will allow my SSH request. And here I can select allow from my IP. So here you see my IP address. It will detect IP address. And now request coming from only from my. But can I say here if I select anywhere, that is this 0.0.0.0/0, if anywhere, whether request comes from my laptop or it comes from your laptop, from everywhere. So if I select allow SSH traffic, then request will will allow from anywhere, from your laptop. Okay, so here we are done with network, and the next thing is storage. Now do not worry about storage. Here you see GP3, GP2, IO1, IO2. All of this part we will see tomorrow. Okay, storage part I will come, right? Right now, all you need to understand is here you can add more, right? The more volume you add, the more storage you will get, right? But even if you don't add more volume, you can individually scale, increase or decrease this one volume. This is your root volume. You can increase or decrease this root volume. You can increase or decrease, right? We will go with the default value of 8 GB. You cannot go B, because understand this is the root volume. And in root volume, you cannot go below 8 GB because that is the minimum. See, in root volume is that place where your operating system, okay, root volume is that place where your operating system, right? So minimum 8 GB is, so this maximum is around 16 byte. But understand, if you go above 30 GB, it will money. Below 30 GB of cost. Okay, if you go above 30 GB, then it will. So here you see, I will go with 8 GB in storage. Okay. See, you can create, there is no limitation there, how many instances you can create. But how long the CC2 will be running, there is a limitation on this link. You will see, you will get all. Okay, here on this list, you will get whatever number of create. All of them together can run for maximum 750 hours. Not okay, all of them can run for maximum 750 hours. Not all right. So if you create one server, that one server can run maximum 750 hours. But if you are Prasad, then all those three server can run for maximum 250 hours. Beyond that also they can run, but then it will be out. Then it will cost you money. Understand, free tier does not mean everything is free. Free tier means some part up to certain limitation things are free. That okay. So we will go with So here we are done with our form. And the last thing is here we can define our number. If you define 1, you will get 1 server. If you define 10, you will get 10 server. If you define 1000, you will get 1 server. Okay, obviously we require server. And with that, I will launch. Okay, everybody pay attention. You will see within a minute, my server. Okay, our server is ready. If I go to instances, and you can see demo. Our first server is okay. Our first it is okay. So as you guys can see, within 10 or 15, right now our server is ready. Our server is created. Next question is how to connect with this server. How to connect? Okay, now for connection there are two ways to connect with it. Okay, there are more ways, but mainly 2 ways. The very first approach is the easiest one. Okay, how to connect with this EC2? Simply select this server, click on okay, click on this connect button, and here you see this is the method called as EC2 instance connect. This method is called as EC2 instance connect, right? And now you see here there is a I will click on this connect button, and you will see this will open my EC2 right inside. Okay, right inside my browser, it will open my EC2. Now here this is the simplest method to connect with EC2. Okay, this method, that is EC2 instance connect, this method will open your EC2 right with, okay, it will open your server right in. Now here guys, what to do after this? Okay, we created the server. Now we can access the server. Now what? Here inside this server, what you do now depends. Okay, what you do inside this depends on your profile. If you are a data engineer, you will do data engineering work. If you are a web developer, you will do web development. If you are a tester, okay, what you do here will depends on your job profile. As a cloud engineer, you need to understand how to create the server, and Ravi already gave the answer. Don't you think something earlier I told, okay, earlier I told you that key pair is the, okay, key pair is the password. So whenever we try to connect with EC2, it should ask us the key pair. But did I provide it? Guys, pay attention. I connected with EC2 from this console. I mean, the connect button was right here. Okay. So can I say for this method of EC2 instance connect, anyone who is using this method, anyone who is, can I say that person is already logged into the account? Can I say that person is already logged in? Yes. Now, if a person is already logged inside the AWS, does that person need does that person need to see here in this case, whenever you use this method connect method, it will not ask you key pair because of this basic fact that since anyone who is using this method, the person is already logged into the account, so it will not ask that person to log in, right? But now I will show you a second method where we will log in from out, okay, where I will log in from outside of AWS account, basically from my local machine, from my okay, and in that method you will see I will have to provide key, because whenever we log in from outside there, of course we are not already logged in, so we need to provide CMA as CLI. Now here I will go inside downloads folder because that is the place where my key pair is downloaded. Right now here I'm going to run a SSH command. Okay, this SSH command will give us access to, okay, so here let me show you the command first. Okay, I will give you template. Okay, I will give you I will give you template of that command. See, the SSH command is this. Then you provide -i. Here you need to provide space, but I'm providing tab because just to show you clearly. SSH-i. Then we provide our key pair. Okay. Then we provide our key pair. Okay. Then we provide our username. Okay. Then we provide @ symbol. And then we provide IP address of our server. Okay. We provide IP address of our server. Right. This is the you have to do is to simply put the value here in this. Okay. Now, before we run SSH, we need to, like the file that we downloaded, we need to provide some permission for that file. Okay, whenever you download any file and you want to use that file, you need to change permission. There is a command called chmod. Okay, so here I will provide that command chmod 400. Using this command, we are going to change the permission of. Okay, and when we run this command, it will ask us our password. It will ask the password of. Okay, we provided the password. Now the command. Sorry, we are ready to run. Okay, so here I will type the SSH command, SSH-i, then provide the. Okay, then provide the username, and the default username is ec2-user. This is the default username whenever you create a. Okay, then @ symbol. Okay, and the final thing is IP address of our server. So select your server, and here you will see all the detail. And from this detail, I will simply copy paste this public IP. Okay, I will copy this, and I will. Now I will enter, and you should see we will get access to our EC2 server. Yes, I want to continue. And there you see, we got access. Okay, now let me show you Windows EC2. One thing you will notice now that when we created Linux server, it took us a lot of time to create that Linux server. Okay, but now when we will create Windows server, you will see it will be created very quickly. So I will go to EC2. Here I'll click create new server. Because if you try that, see, in Windows laptop, you don't need to change it. When you work from Windows laptop, simply run your PowerShell as an administrator. Okay, in your Windows laptop, you don't need to change it. But in Linux or MacBook, the file permission is different. Whenever we download any new file, the file permissions are different. So there it is required to change. But in Windows laptop, just simply run PowerShell as an administrator. You will not. All right. Now see, creating Windows server, now that you understand how to create. Now creating Windows server is very easy. All you have to do is to simply select. Okay, simply select Windows AMI. That's it. You want Linux server, select Linux AMI. You want Windows server, select Windows AMI. That's okay. Then you see here, if I go down, now you see T2 micro is no longer available. We have T3 micro. Why T2 micro is not available? T3. Okay, because see, all of you guys will agree that Windows server, Windows operating system is more heavy than Linux. Windows operating system is more heavy than Linux operating system, because in Windows operating system you have the entire UI and everything. Correct? So T2 micro is not capable of hosting Windows AMI. T2 micro is not capable of hosting Windows machine with Windows operating. Okay, that's why here whenever you create Windows AMI, T3, right? After this key pair, I will select. Okay, I will select the same. Okay, should we create another key pair to use? Ideally, the to use different key pair for different server, but it is okay. If you want, you can use the same key pair for multiple. Okay, so we'll go with the same key pair. Now, do you notice any? You see, instead of SSH traffic, we have RDP. Okay, so if you want to work with Linux server, SSH protocol is required. But if you want to work with Windows server, RDP protocol is required. Remote desktop. Very good. And one more change you will see here, instead of 8 GB, now we have 30 GB. Again, the reason is simple, because we are working with Windows EC2. And Windows EC2 is obviously, so it requires more. 30 GB is required for minimum required for Windows server. If you try to go below 30 GB, you will get the error, just like how we got error when we tried to go below 8 GB on. Okay, so you see, we just selected Windows AIM. Okay, do you understand this fact, everyone? Understanding EC2 for the first time, creating our first server took us more than 1 hour, but creating second server it got so easily. In few minutes we are done with our, because all we did is to select different AMI. All right, so our server is ready. Now, how to connect with Windows server? Because in Windows server the method is very simple. See, I'll show you. See, select your Windows server, click on connect button. Okay, click on connect button, and here you see RDP client. Okay, here you will see it will ask you to download remote desktop file. Okay, we need to download this remote desktop file, and here you will see it will be downloaded. Okay, now here is your, but what about password? You guys know password in Windows EC2. For Windows EC2, we need to upload the we need text password. So here you see have to provide password. So here you see get password. Click on this get password, and here we will have to upload. What it will do is, it here when we upload our, okay, here when we upload our key pair will be converted into a text password. So look at this. Here I'll upload key pair. I will provide my key pair here. Okay, I provided key pair here from my laptop. And when I click on decrypt password, here you see decrypt password. When I click on decrypt password, it will convert my key pair into password. Look at this. This is the password I got. Everybody understood how to convert your key pair into password? Here you will see get password method button. Click on that button, upload your key pair, and your key pair will be converted. Now here is your username, that is administrator, and here is your password. Simply execute that file. Okay, that file. Okay, I will execute this file. Okay, you see Windows EC2 RDB file. I will run this file. Let me share my screen. I'll show you how. Can you see the screen? When I executed that file, here my EC2 address. Okay, here is my username, and here I will simply copy paste my password. Look at this. Hope you're understanding. Now what I will do, here I will continue. Now when I click on continue, just wait and watch now. Can you guys see in my MacBook, a Windows server is getting started? We create server yesterday. Where are this server? As you can see, based on what is the concept of cloud computing, now we understand that these are the virtual server. Now we understand that these are the virtual resources. Okay, we know that both of these are correct. Where they are, where are they stored physically? Where they are hosted physically? Okay, see, even though I'm getting this server virtually, but here you see there is something called as United States, North Virginia. Okay, so physical hardware of this two server is coming from where? The physical hardware of this two server is coming from North Virginia. So this simply means that in North Virginia, there is a physical data center. Okay, in North Virginia, there is a physical data center where this virtual machines are being hosted. Okay, so this concept, all of this names you can see here, North Virginia, Ohio, Oregon, Mumbai, all of this thing that you see here, they are called as regions. Okay, all of them are called as regions, right? What is region? Region is just a geographical, just a location, nothing else. Okay, North Virginia's region. But region is made up of, so let's say this is the region. Okay, this is the region. Region is made up of availability zones. Okay, region is made up of availability zone. What is availability zone? Availability zone means data center. Okay, availability zone means data center. This basically means that in North Virginia, there are these different data center. Okay, inside one region, there can be multiple data center. So if I created a server, there is a chance that my server is hosted in this data center. There is a chance that it is hosted in this data center or this. Okay. So if we are creating server, or let's say in cloud, when we upload our data goes to this data center. So whatever you see here, this North Virginia, Mumbai, these are just a location. They are called as region. But a region is made up of data center called as availability zones. Okay, so this is the concept of region and AZ. AZ means first method was EC2 instance connect. Another method was SSH method, SSH command method. So this is the concept of region and AZ, right? Now we work in one region at a time. That's why I created this server, because if you see, if I let's say go to Mumbai, now here you will not see the server. See, there is no server here because our servers are created in North Virginia region. So at a time you can work only in one region. Okay, you cannot do half of the work in one region, another half of the work. I hope that is clear. Now, if here a question comes to mind, if there are so many regions, okay, and there are 16 more regions, if there are so many regions, then which nearest and most secured zone? See, all of them are secured, but you are correct with the part that nearest. See, a logic is very simple. Let's say my development team is in Mumbai. Okay, my development team is in Mumbai. We are working from Mumbai, and we are developing a app that is targeting Australian. Okay, then which data center we should work with? Should I should my team work in Mumbai data center, Mumbai region, or they should select Sydney region? Which one? We will select Sydney region. Why? Very easy. Performance matters. Okay, if my customers are physically closer, to my data center, right, then they will get better performance. Do you agree with this? See, developer distance does not matter. It is okay that developers are not the users. Developers are developing the app. For them, this performance does not matter. Performance matters for customer. If your customer, okay, if your customers are closer to your data center, then obviously they will get better performance, because closer the distance, lesser the lesser the latency, and better the. Okay, so we will always go with the region which is close. Your next. Okay, Pratik, if I had customer from Australia, then I will go with Sydney region. But what if I have customer from all over the world? What if I have a global audience? then which region to go with? In that case, we will go with North Virginia or Ohio region. Because North Virginia region and Ohio, see, North Virginia is anyway by a default region. North Virginia region and Ohio region, these are the main US region. Whenever AWS releases any new services, whenever AWS releases any new feature, they release those new services and feature in North Virginia and Ohio. Okay, so and slowly they release those services and feature in other part of the world. So if you always want latest update from AWS, then you can go with North Virginia and Ohio. These two are the preferred regions. Okay, so if you have a global audience, we always go with North Virginia or sometimes. Okay, so yesterday we created this server and I showed you I did yesterday. But if you select this and here you go to instate, yesterday if you remember I clicked on this terminate instance, that is delete. When we click on this, our server is deleted. Okay, and deleted means what? It is permanently deleted. Once you delete your server, you will, right? Here we clicked on terminate. So this here you can see it is shutting down, and in few seconds you will see let it get done. You will see terminate message here. But even after termination, you will still see the server here for some time. Do not worry, just because it is there, it will not cost you money. As long as this is terminated, okay, it will be there for few minutes. After that, it will be removed. But do not worry, it is not costing you any money. But this is a permanent delete option. Obviously, if you delete something, it will not cost you money. But if I stop this, okay, what happens when you see, if a server is terminated, there is nothing can be done about it. We'll have to create a new server. But if a server is stopped, that server can always, okay, if a server is stopped, that server can be, right? So what do you think? When it is stopped, here you can see added again. But when it is stopped, do you think it is? Yes, it is not working, but it is still there in the cloud. This server is still assigned to you. So even though it is in stop state, it is still assigned to you and you can start it whenever you want. So of course it will not cost you that much money, but still it will be costing you some amount, right? When your server is in stop state, it is still costing you money. Because the answer is simple. See, you rented out an apartment, okay? But you are not living in that apartment for 3 months. Now, does it mean just because you're not living there for 3 months, you don't need to provide the money? You don't need to pay the money? You don't need to pay the rent? No, right? That's your lookout. Whether you are living in that place or not. If you rented out an apartment, you'll have to pay the rent. So stop server is like that. It is stopped, but it is still assigned to you and you can start it whenever you want. So some, some bit of money, it will still. Okay, so here you see it can be started again. Okay, very soon you will see the server. See, it is in pending state now. Now it will be in running state. See, it is running. So a stop server can always be started again. Right? So let me terminate this. And now I will create a new server. Okay, so now we will get into EC2 storage. Okay, so here I will provide the name EC2-EBS. Okay, see, regarding EC2 storage, what you need. This is the EC2. Okay, EC2 have a internal storage. Okay, it have a root volume. It have an internal storage. Okay, this yesterday we saw that there was a root volume called as EBS, elastic block storage, and the same root volume can also be attached externally. Okay, so if you remember yesterday when I was creating the EC2, at that time, so I will proceed without keypad today. At that time, you see this 8 GB. Okay, this is the root volume. So this root volume is nothing but this EBS that is attached to the server. And we can add external EBS. So here if I click on, let's say, add one more volume. Now this is your external EBS, but this is the root volume which is attached to the server. Now you tell me everyone, let's say this EC2 stores some data in this root volume and the same EC2 stores some data in this volume. Data from our root volume Can I say if my EC2 gets deleted, data from my root volume will also get deleted? But data from external volume should not get deleted. Do you agree? Seems this is a EC2 and this is a internal EBS. Okay, so this is the root volume. Okay, this is the internal volume which is attached to my EBS. And here is the external EBS which is attached over a network. Now you tell me what I'm trying to say. This EC2 stores some data in internal EBS. This EC2 stores some data in external EBS. If my EC2 goes down, can I say data from my internal EBS is also, but data from external EBS should still be there? Do you agree? Right? Because if the server goes down, obviously the storage attached to that server will obviously go down. But the storage which is not attached to it, which is connected over a network, nothing will happen to that storage. So when we create EC2, this root volume you see here, this root volume is the internal storage, and the storage that we attach separately, like this one, this is the external. Okay, this is the external volume, right? So I will create this server. Let me create this one. Okay, so here you see, I will go to the server. Here I will give the filter instance state is equal to running. Okay, so you see this is the server. If I select this server, if I go to storage, now you see I have bought the storage. This first storage is the root volume that comes with our server, and this is the external volume. Okay, now if I want to add more storage separately, can I do it? Or we can add storage only while creating? Yes, we can add, but edit. Very simple. So this is my server. Okay, and this is, we are covering EBS. This storage is called as EBS. EBS is a storage of EC2 and it stands for elastic storage. Okay, now EBS is not some different AWS service. Okay, EBS is not some separate service. EBS is the part of EC2. So on the left side you will see elastic block store. So if I go here you will see elastic block store. This is the EBS, and whatever EBS that you can see on my screen right now, these are the EBS that are currently there in my account. Out of these two EBS, these two, okay, look at this. These two are the EBS that are attached to my server. You remember this server I just created, EC2 and EBS. So these two servers, these two EBS are attached to my EC2, right? Okay. So this other two storage here, you see those other two storage, their volume state is available. Available means what? They are not attached to any server. Here you see these two servers are in use. Why? Because they are attached to my server. Okay, let me show you that server. Here you see, if I select this server, look at the name of the server, EC2-EBS. These two volumes are attached to EC2-EBS. Okay, look at their name, dev SDB, dev XVDA. If I go to this server and if I select its storage, here you see the same name, dev SDB, dev XVDA. So these are the two volumes that are attached to my server. That is why it is showing in use. But other two server, this first one and this last one, they are available. Available means what? They are not attached to any server, so they can be attached to some new server. Okay, but I will delete them. I do not need them right now. So I will delete both of those storage. Okay, and I will create a new one. So how to create a new storage and attach it to my existing server? Because we just saw that while creating server, okay, while creating server at that time, we can attach more storage. Okay, but if my server is already created, then how to attach storage to it? Very simple. See, here we will click on create volume. Okay, now look at this page. Just like yesterday we saw EC2 page, we provided the value. We'll come to snapshot after some time. Okay, we'll come to snapshot. We'll go step by step. First, we'll understand few other things. Then snapshot part we'll cover. Like yesterday, while creating EC2 also, there were many things that we provided. So while creating EBS also, there are many things we need to provide. And by the end of it, we'll get our subjects. Okay. Here is the size of your storage. So this is the part where you define the storage of your EBS. And look at the range. The minimum value can be 1 GB and the maximum value can be 16 terabyte. So here we understand one thing. Okay. Here we understand one thing, that EBS, okay, have maximum 16 terabyte of we are covering. Okay, the storage is minimum 1 GB, maximum 16. Okay, here is the size 100 GB. Here I can select, let's say, 4 GB. Of course, I don't need 100 GB. I will not go with it. I'll go with 4 GB. Right, so this will decide the storage of my volume. Okay, storage of my EBS. Then you see here of it. IOPS means input, simple language. IOPS define how quickly you can read and write data from storage. That's the simple meaning. Okay. So here you see we are getting somewhere around 100 slash back to this point. But IOPS define how good your storage will perform. Then you see here availability zone. Okay, here I'll select AZ1D. Okay, here you see snapshot ID. Ignore it. We'll cover this soon. Here I will give a name. Name will be, let's say, EBS demo. Okay, and I will create this volume. Okay, I will create this volume. You see, all I did is selected some storage, a 4 GB storage. Okay, and I'm going with all the rest of the default value. So here I will create the. So you see my volume is created. And if I go here, check it. So you can see it is available. Available means what? Available means it is not attached to any server as of now. And we can attach it to. Okay, it is available. Now what I can do is I can select this EBS. How to attach to my server? Very simple. Select the EBS, click on action. Here is the attach volume. When we click on attach volume, here is the instance, just click on this and it will show you your running server. So you see in my account right now, there is only one server, EC2-EBS. Same server I can see here, EC2-EBS. So I will select this server. Here I will select the device name. You can take any device name, whatever you want. Okay, it doesn't matter. You can go with any one of them. So I will select this SDC. So this is the device name. So you see, I clicked on attach volume. I selected my server. I selected my device name. And now I can attach it. But before I attach it, let me show you. I will go back to that server. You see, our server had only 2. Okay. Here you see, there are only 2 volumes. But the moment I click on attach volume, okay, the moment I clicked on attach volume here, if I come back here, can you see the third storage is also added, 4 GB SDC. Can you guys see the third volume is added? This is how you can attach the volume even after server. But let me show you the same example again. I will create one more volume. Okay, for this volume also, let's say we go with 4 GB. Okay, and let us go with the same value, 100. I have 300. Here I will add a tag, name EBS2, and I will create this volume. Okay, here I create one. All right. Why its name is not reflecting? Its name should be there. Okay, no problem. Let me give it the name again. Okay. Now here I'll click on action. I will again attach it to my existing server. I'll click on attach volume. And here you see it is saying no matching running or stop server. Why do you think earlier it detected the server? Then why it's not detecting it anyone? Because answer is in front of good Balaji. Different availability zone. Sorry, when I created it first time, I changed the. What happens is I'll tell you the logic. Okay, so this is the region. There are multiple AZ. in a region. Now let's say in this region I have my, okay, in this region I have my EC2. Okay, now one more EC2 we have, let's say in this region, in this AZ, sorry, one EC2 in this AZ, another EC2 in this AZ. Now in this AZ, if I have a EBS, then this EBS can only be attached to this server in this AZ. Okay, but this EBS cannot be attached to this EC2. Why? Why it can only be attached to this server? Because EBS have that limitation, right? You can also write down their EBS have mainly two limitations. The very first limitation of EBS is that EBS can only connect with the server from same availability. Okay, if your EBS is in one AZ and your server is in another AZ, then they cannot be connected. Your EBS can only be connected to the server from same AZ. That's the first limitation. Second limitation is within the same AZ. Okay, within the same AZ, your server can be connected with, sorry, your EBS can be connected with multiple, sorry, within the same AZ, your EBS can only connect with one server at a time. It cannot be connected with down this. Okay, EBS have two limitations. First limitation is EBS can only connect with EC2 from the same availability zone, from the same, okay, and even in the same AZ, it can only connect with one EC2 at a time. Okay, EBS can only connect with one EC2 at a time. It cannot be connected with multiple EC2. And this is a very big limitation. So that was EC2, that was EBS. EBS have two limitation, and we will see their solution as well. Okay, EBS have there is a solution in AWS for this two limitation of EBS. Okay, we will see that solution. Clear? Now what I'll do is I will go and delete this EBS. Okay, I will delete. And by the way, this EBS, this EBS demo, which is attached to my server, if I click on action and try to attach it to another server, you see attach volume option is, come on guys, why it is not available? Because it is already attached to another, so that's why to one more server. And okay, here you can see the practical proof as well. So whenever you want to attach EBS to another server, you will have to detach it first from one server and then attach it here. So I will delete this EBS. We don't need this one anymore. I will delete this one. Okay, so let me create a new volume. Now, a very amazing thing that you need to understand about AWS cloud or any cloud for that matter is, here you see there is an encryption option. Okay, this you need to understand. In cloud, everything that you get. See, you need to understand this one very beautiful example here, right? EBS is a volume. EBS is a storage, correct? EBS is a storage. Now, in this storage, what happens is we want it to be secure. We want EBS volume to be secure. We want it to be encrypted. Okay, we want this storage to be encrypted. Now, all you have to do is to select this option, and you're done. Okay, all you have to do is to select this option, and you're done. Okay, select the default key that you get here. If you select this one option, encryption is done. Okay, encryption is done. If you upload any data, the data will be automatically encrypted. You don't need to do any encryption. You don't need to maintain any encryption key, nothing. And when you download the data, your data will be automatically decrypted. You don't need to do any decryption. You don't need to maintain any key. In AWS, this feature is basically, it is called as managed service. The meaning of managed service is simple, that everything will be handled or everything will be managed for you from AWS. All right. So we are going to cover another very important service from your AWS course, that is IAM. Okay, extremely important, right? Especially for people like you who are into getting into DevOps. So for DevOps people, this is very important service. Okay, now what is IAM? So see, this is my account. Okay, on your screen you can see my AWS account. Now let's say I have a project, and for that I need some developers. Okay, let's say I want you guys to work with me in my AWS account. Okay, I want you guys to work with me on in my AWS account. So how we can make sure of it? How we can make it possible? Am I going to share my username and email address and password with you? No, that is not at all secure. Okay, sharing your credentials with other. So how we can allow other people to work with us in our AWS account? By creating their user. Okay, so IAM, which stands for identity and access management. Okay, IAM is the AWS service that allows us to create users in our account. Okay, so whenever, let's say, new employees joins a company. Okay, whenever new employees joins a company, you want them to work. Of course, you want to create their AWS account. Otherwise, how they will work in your AWS account, right? So if you want to allow other people to work with you in your AWS account, you need to create their IAM users. Okay. Now, not just you can create their users, you can also define what they can do and what they cannot do. Okay, you cannot not just create their user, you can also define what they can do and what they cannot do. Both the things you can define, right? Now I will show you. See, there is not much theory here. Okay, IAM is a very practical service. So I will show you a practical directly. So first of all, we will see how to create an IAM user. Okay, now we are going to create IAM user, but before that, we already have a root user. What is root user? So for example, in my account, whenever I log into my AWS account, I use an email address to log into my account. You guys also have your email address to log into your account, correct? So this email address that you use to log into your account, that email address is basically your root user. Okay, the email address that you used to create your AWS account, that is your root user. And what is root user? Root user is the god of the account. Okay, root user can do anything. Root user can delete the entire account. Root user have no root user have all the access, all the privilege. Okay, it is like an admin, but here I'll tell you, here in IAM, admin is a different user. Admin is less powerful than root user. Root user have everything. Root user can delete the entire account. Okay, that is why in real world project, what is recommended is, see, for our practice, it is okay if you use root user. That is totally fine. But in real world project, you will never see the root user. Okay, because a company that have their AWS account, once they create a account and they have a root user, using root user, they will create admin user, and using admin user, they will manage everything. They will not use root user. Okay, why? Because what if your root user credential got compromised? What if somebody got access to your root user credential? Then your entire account is in danger. Okay, so it is not recommended to use root user for your day-to-day activity in a real world AWS account. For our practice, it is fine, but in a real world AWS account, it is not recommended, right? So always remember, email address that you use to log into your account, or simply the email address that you use to create your AWS account, that email address is the root user. Root user have all the access. Root user can do anything. But obviously we cannot, and root user is only one. You can create multiple admin user. You can create multiple admin user, but root user is always the one, always only one user, no replacement of that. Okay. Now what I will do, I will create an IAM user. Okay. Now let's move forward. Now I will show you the practical. Okay. Now I will create an IAM user. Okay. So for that, here you see, I will go to the users. Who is the one? The owner of the account. Owner of the account is nothing but the root user. So the person who owns the account, obviously he is the one who will use it because he is the root user. Okay, so in a project nobody uses root user. Root user we use, and we create admin user, then we do not use root user. We do all the work using admin user, and root user is the one that who will be the solution architect. That person will take care of it, or it can be taken care by a admin team also. Okay, now here I will go to the users. Okay, and here we will create a new IAM user. Okay, so I'll click on create users here. Okay, so here I will give a name, let's say John. Okay, so this is going to be the name of my user. Let's say a employee named John joined my company. Now this employee John is a developer. Okay, he can work with database, he can work with EC2, he can work with S3. So this new developer, new employee joined my company. Now what I'll do, I will create a John user here. And here you see it is asking me username. Okay, it is not asking me email address. Understand this. Root user had an email address. But here IAM user does not require email address. IAM user just require a name. Okay, so email address is for root user, not for your IAM user. Okay, for creating IAM user for your employee, you don't need their email address, right? So let's say here I provided the name of the employee, that is John. Then here is the provide user access to management console. I'll select this. Okay, now you'll, and what is this? Access to management console. What is management console? This entire UI that we use every day. This entire AWS UI is called as console. Now tell me, if I do not select this, do you think my user will be able to work with this website, this console? Of course not. Your user will not be able to work with it. Okay, your user will not be able to work with it. See, remember this thing. When you create an IAM user, okay, when you create an IAM user, your IAM user have no access in the beginning. Okay, always remember this. Whenever you create an IAM user, the IAM user by default have no access, right? So when you create an IAM user, it is your responsibility to give that IAM user access as well. So here you see, I'll provide access to the management console. Now when I select this, here I'll select I want to create an IAM user. So basically my user will be able to log into my AWS account. Okay, my user will be able to log into my AWS account. And here I can set up a password for my user. Either I can go with auto-generated password, so random password will be generated for my user, or I can go with custom password. Okay, right now we'll go with auto-generated password. Okay, and then you see here user must create a new password at next sign in. Okay, so we will select this. Why? See, if a random password is generated, so that password will be very complex. Okay, and our user of course cannot memorize that password. Or if we provide custom password, then we know the password. So whatever way you go, whatever way you go with, you want your user to change their password. You want your user to update their password, right? Okay, so if I select this step, if I select this will force my this will force my employee, this will force my IAM user to change the password first time when he or she log in. Okay, this will force my IAM user to update their password so that they can provide their own custom password that they can memorize. Okay, so in this first step, we define the identity part. Okay, understand this. In this first step, we define the identity of our user. We define the username and we define their password. Now, in the second step, we will define what this user can do. So as I told you, your user cannot do anything by default. Okay, I told you, your user cannot do anything by default. Why? Because that's how it is created. Whenever a user is created, that user is created without any permission. That user have no access at all. Okay, the user have no access at all, right? Identity center we use when we need to provide multiple users. If you are creating one user at a time, you just go with that IAM user. Active Directory is basically the database of your employees in a company. Okay, where we can create their, whenever a new employee join, we can create their user, we can manage what access they have, we can manage their portal access and everything. Similarly, in AWS account, IAM is basically the database of your AWS user. Who are the users in your account? What they can do, what they cannot do. Okay, so here I'll tell you that, as I said already, your IAM user by default have no access, zero. So it is your job to give it access. So on your screen, you can see there is something called as permission policy. Now, what is this? These permission policies are the predefined. Predefined means it's already there in all of our AWS account. These are the predefined permissions from AWS. For example, here you will see, let's say this developer, I want to give this developer access to S3. Okay, so here you see Amazon S3 full access. Okay, now when I give this access, when I give this permission policy, then my user will have full access over S3. My user will have complete access over S3. Okay. Similarly, let's say I want to give this user RDS full access. So here I'll give RDS access. I want to give this user DynamoDB full access. So I'll select this policy. Okay, so you see multiple policies are there for all the AWS service for different scenario. Okay, here you see there are some job permissions also. For example, if I give this administrator access policy, now this user will become admin user. And as an admin user, he will have access to everything. But obviously, we don't want to create admin, so I'll not select this. Right? So here you see, I will give EC2 full access. Now my user will have EC2 access. Okay? So here, I'll tell you this part also. You can add your user to existing group, but since we haven't covered group, I'll not get to that right now. So this is important. Okay, these are the predefined AWS policies. Okay, and here you see these are the JSON policy. That's why I told you to prepare JSON. See, okay. Do not worry. I will show you how to easily create such policy. So we provide policy to our user based on requirement. Attach entity means to whom this policy is attached. Okay, to what different role or different service this policy is attached. Okay, for example, this policy is not attached to everyone, but admin policy is attached to two people or two different things in AWS account. So that's what it represents. All right. Now I will go to the next. So I provided for permission. I provided permission for S3, RDS, DynamoDB, and EC2. I'll go to next now. Did I uncheck those permissions? Let me provide that again. Okay, sorry. I think they got unchecked. RDS full access. Yeah, all of these policies that you see here, all of them are predefined. But obviously, we can create our own policy also. That also I will show you. All of these policies that you see on your account, these are the policies given by AWS. So they are predefined. Okay, now you see here in the review, we got this 4 policy. Okay, so here you see these are the 4 policies. And you see this one more policy, where is this coming from? You remember in the first step, we selected that option that will force our user to change their password first time when they log in. Now look at this. This shows you how secure AWS is. Even for user to update his password, he requires a permission. If we remove this permission, user will not be able to update their password. Okay, so here I will create this user. Okay, now you see on your screen, when you create a user, you will see the screen where you can see the password also. Okay, but remember this password that you see here, this screen that you see here, you will never see this screen again. Okay, the screen that you see right now, you will never see this screen again. This is shown only one time when you create user. So what you can do is, here you can click on this email. Now this will open your Outlook app, and you can email your employee this credential. Okay, here you can email your employee your credential, or you can download the CSV file. When the CSV file is downloaded, in that CSV file you will have your user credential. Okay, so what I'll do now, I will return to user list. So you see now this is the new user in my account. Okay, now I'll show you how to log in as a IAM user. Right, so here I'll click on add session. It will add a new session. Okay, now see, generally what we do, we log in like this. Okay, tell me everyone, you guys log in like this, right? Here you provide your email address, correct? So when you log in like this, when you provide email address like this, you are basically logging as a admin, logging as a root user. Okay, here you are logging as a root user. But when you click on when you want to log in as an IAM user, you need to select this. Okay. Now, when you log in as an IAM user, basically you're logging into somebody else's account. Okay. Whenever you log in as an IAM user, you're logging into somebody else's account. So you need their account ID. First of all, you need their account ID. Okay. How to get account ID? You can get it from here. So my account ID is this. Okay. Look at this. This is my account ID. Okay. So here I'll give my account ID. Next. Now here you see we need to provide IAM username. We need to provide password. Okay. So in username will provide our user, that is John user. Okay. And here in password, I will copy paste the password. Oh, sorry. I'll take the password from here. Let me show you this also. Here you see this password. Okay. This is the CSV file that was downloaded. And here you can see our username, password and everything. Okay. So here I'll copy my password and I will paste it here. Now pay attention. Okay. Now see, here I'll provide the password, sign in. So John user is trying to log into my account, and you see the very first thing that is happening, that this user is being forced to update the password. Okay. So here I will provide my old password. Here I'll provide my new password. Here I'll click on confirm password change. Okay. Now here I will log into my this account. Now look at this. Here you see my account ID. This is the same account ID as this one. Okay. But here it is logged in as a John user. Okay. Here it is logged in as a John user. Now you see one more thing here. If I go to my home page, here you see I can see the cost and usage. I can see it because I'm the root user. But here you see my IAM user cannot see that. For my IAM user, it is blocked. Why it is blocked? It is blocked because remember, by default, whenever a new user is created, by default it have no access. That's why when we give access, we just give access to for service. We did not give access to see the cost. Even to see the cost, user require access, right? That's why here you see access denied. But if I go to S3, now look at this. If I go to S3, here you will see my IAM user can see all the bucket. Okay. So here you see my IAM user can see all the buckets, right? And similarly, if it goes for, okay, now here you see all the buckets, but I will go back to my root user. I will go back to IAM. Now, can we remove this permission? Okay. So here I'll go to my user. Here I'll go to my John user. Now here you see in the permission tab, here you will see all the permissions. Okay. So here you see, I will, let's say, remove this S3 permission. Now look at this. The moment we remove this permission, and if we go here, and if I just simply refresh here, and there you go, now we are getting access denied error. So guys, you understand now. Earlier, my IAM user was able to see all the bucket, and when we give full access, you cannot just see the bucket, you can delete the bucket, you can create a new bucket. But the moment I remove the policy, in the next second, we lost access. Okay. So here, if I go to, let's say now EC2, if I go to the EC2, see what happens. Okay, you can see, we can see all the information, right? Now let me remove EC2 permission. Okay, now see, here if I just simply refresh this page, and you can see we are immediately getting all the error. Okay. If you want your user to get able to do this thing, then you have to give the permission. Do you see? Now look at this. Just wait for it. Do you see IAM is also not loading correctly? Here you are getting error. See, even key pairs are also not loading. API is basically all of this information you get through API. Behind the scene program is there. So this API is application programming interface. So that API fetches all the data. And when you do not have permission access denied error, you also get API error. So guys, you can see clearly we are getting all of this error, and there is no way we can create the EC2. Okay, so let's say if I select if I go with proceed without key pair, and if I try to launch instance, see, we are getting error. Okay, because our user don't have permission. But the moment I give this EC2 permission again, EC2 and S3, look at this. Yeah, it is related to coding. API is all that is done in coding. Here I'll give EC2 full access, and I will also give S3 full access. Now look at this. The moment I add this permission, and if I simply refresh this page, can you see things are loading perfectly now? Earlier, you couldn't see so many things. Earlier, you couldn't see all of this thing. Earlier, you couldn't see any of the key pair, but now key pairs are also loading. Why it is working now? Because you gave the permission, right? Now, if I launch an instance will be launched. Look at this. I hope it is now perfectly clear for all of you. Okay, so now our instance is there. See, but understand this now. Many people get confused here. see, you try to answer this, okay, based on your logical thinking. John user created this server, right? But again, if I remove this EC2 full permission, okay, I remove this. Now, do you think John user can access or even delete this server since it is created by John? What do you think will happen? I remove the permission, but this EC2 was created by John. What will happen? See, forget about deleting. The John user will not even be able to see the server, even though it was created by that user. Obviously, he cannot delete. But forget about deleting, he cannot even see the server. Because even to see the server, you require permission. Understand the granularity of it. It's not just that you give the permission, user can create server. Even to see what are the different server, you need to give permission for it. It is at such a granular level. Okay. But can my admin or root user can see that EC2? Obviously, other people in your account, not just admin or root user, other people in your account who have access to EC2, of course, they will be able to see the EC2. See, right? So that was IAM user, guys. Now, next thing is IAM group. Okay. Now, what is IAM group? See, here I just showed you for one user. But what if instead of one user, multiple people are joining your organization? Now, what? Instead of one user, multiple people are joining your organization. At the same time, let's say 20 people are joining, and all of them are developers. All the 20 people are developer, and they are joining the same project. Tell me one thing, can I say all these 20 people, let's say they are at the same level, can I say all these 20 people who are at the same level in the same project and all of them are developer, can I say all of them will have the same permissions? Okay, but don't you think it will be very hectic to create all 20 user and give them give all of them same permission again and again? That will be very hectic, right? So rather what we will do is we will create a group. Okay, we will create a group. Let's say we are creating a group of, let's say, developers group. Okay, for our project. So this is the name of the group. Now I will assign permission to the group. Earlier what we were doing, earlier we were assigning the permission policies to the user. Now what I'm going to do, I'm going to assign permission policy to the user, not to the group. I will assign policy to the user, okay, not to the group. So what I'll do here, I will give the permission, let's say S3 full access, RDS full access, EC2 full access, DynamoDB, EBS or EFS. Okay, like this multiple permission I will give, Lambda permission or SQS permission, SNS permission. Okay, like this multiple permission I will give, and we will create this users. Sorry, we will create this group. Now understand this, policies is a kind of thing that can be assigned to the user or it can be assigned to the group. Now we have this group, okay? In this group, I will add user. Now when I add a user in this group, that user will get those permission. So if I go to John user, earlier you saw how many permissions were there. Now look at it. Okay. See, first of all, you see all of these permissions are here. Now look at this. EC2 permission we provided directly to my IAM user John, and it is also coming from group. Oh, sorry, DynamoDB permission. And EC2 and S3, EC2 and EFS permission. Here you see they are coming from the group. RDS and S3 both are coming from group and they are also attached directly. SNS and SQS are coming from group. Okay. So if you want to give a user some extra permission, simply click on add permission and give it. Okay. See, if your group have 20 permission and in your group you have 10 user, then each of those 10 user will have all those 20 permission. Does it mean you cannot add any extra permission for any individual user? No, you can add. Definitely you can add. Let's say all the 10 user have 20 permission, but for one user you give extra permission. So that user will have extra permission also. Understood, guys? Okay. Now look at this. So here is my user. Now what if, let's say, can we do something like this? Let's say I don't want this SNS permission that is coming from group. I told you, you can give additional permission to the user. But can I remove this permission from group and have other permission? I don't want this one permission. Can I do that? Let's see. If I remove this permission, you see all the other permission from the groups are removed, right? So you see it removed all the other permission. Why? Because your user itself is removed from the group. See, the rule is either you will have all the permission or you will have no permission from the group. If you cannot say that I want I want all the permission, but few one or two permission I don't want. If your user is in the group, it will have all the permission. If you try to remove one permission, it will remove your user from the group. It's either or all. See, one more thing I'll show you here, security credentials. Okay. Now you see here we have multi-factor authentication, that is MFA. Now what is this MFA? MFA is a guys in your root user you have a MFA, right? In your Microsoft Authenticator app is there, right? You provide OTP. Okay. Now AWS have made it mandatory for root user. Earlier it was not mandatory, it was optional, but you can assign it for your IAM user also. The MFA that you have for your root user, same you can have for your IAM user. Okay. See, what is MFA? Multi-factor authentication. See, just like whenever we do shopping, okay, we get a OTP code, right? Whenever we use a credit card or debit card, we need to provide OTP password, one-time password, right? Because that's a one additional layer of security. Similarly, whenever you log into your AWS account, what if somebody else got access to your name and password? Now any person can log into your account. So to prevent that, we will add one more layer of authentication. That is MFA device. Here I will give, let's say, my MFA. Okay. And here we will select authenticator app. Okay, you can select other things also, but go with this one. This is better. Right? I'll go with this one next. Now here you see setup device. Here I'll click on show QR code. Now I will scan this. Okay, in my authenticator app, scan this code. Now here I will provide the MFA code. What is the current MFA code? 562991. If you scan this QR code, all of you will see the same MFA code. And what is the second code you're seeing? 785976. Okay, so here we need to provide our consecutive MFA code. And once you provide this two consecutive code, this app will be assigned to my user. Okay. Now you see from today onwards, this app, this MFA is assigned to my user. Okay, everyone. Now let me show you this practically. So I will again log out as a IAM user. Sign out. Okay, so you see I logged out as a John user. Now I will again sign in. Okay, here I'll provide my John user credential. And now you see it is asking me MFA code. Did it ask earlier? No. It is asking now. Okay, what is the current MFA code? 536890. It was not asking it earlier. But now it is asking because now we have a MFA device assigned to our user. Okay. So even if my password get compromised, even if somebody else knows my password, they will not be able to log into my account because they will not have OTP. This OTP code will be in my mobile only. Okay. Now, moving on, one more thing I want you guys to understand is, see, here I'll give you a scenario. Have you guys read about fan-out architecture? See, let's say there is a person. Okay, this person wants to work with EC2. Okay, so let's say there is this person who wants to work with EC2. What we will do? How we will make this possible? Can I say we will simply create an IAM user? Okay, when we create an IAM user and we provide EC2 full access policy, okay, when we create an IAM user and we provide EC2 full access policy, this person can work with EC2. Okay, now let's say from this EC2, from inside EC2, he wants to connect or work with S3. Okay, he wants to connect or work with S3 from inside EC2. Okay, now let's say I will give S3 policy also. Okay, I will give S3 policy also. Now, do you think it will work? No, it will not work. Okay, what will work is this. This will work. Okay, your user will be able to work with S3 directly. But from inside EC2, your user will not be able to work. Okay, from EC2, your user will not be able to work. Why this will not work? Because just like your user by default have no access to work with any AWS service, similarly, by default, no AWS service have access to work with another AWS service. Okay, any AWS service cannot directly work with any other AWS service. Understand this as a rule. Okay, I will tell you the solution also, but understand this as a rule. Any AWS service cannot work directly with any other AWS service. See, understand it as a rule. When you create an IAM user, you understood this thing that IAM user cannot work with any AWS service by default. Similarly, one AWS service cannot work with another service. So when this person as an IAM user log into EC2 and from EC2 he's trying to work with S3. So this person credential does not matter. Here what is happening? EC2 is trying to work with S3. even though this person is driving the EC2, but EC2 is trying to work with S3. So this will not work. Okay, but how to make it work? For this, we have something called as IAM role. IAM role. Okay, so for a person who want to work with service, we create IAM user. For a AWS service that want to work with another AWS service, we create IAM role. Right? Understand this three entity: IAM user, IAM group, and IAM role. Okay, we create IAM user and IAM group for whom? We create it for a person. And we create IAM role for what? We create IAM role for a AWS service. Okay, see, understand. Person to service access. Let me write here. Okay, so this is a person and this is a AWS service. Okay, see, this is what I was saying. When a person wants to work with a AWS service, we create IAM user. And when one AWS service wants to work with another AWS service, we use IAM role. Okay, all right. Now we will see IAM role. IAM role is something that allows one AWS service to work with another AWS service. Okay, so that's what we will see. So let me go to my user. Okay, here I will give my IAM user John EC2 permission. Okay, so you can see John already have S3 permission. I will also add EC2 permission. Okay, I will also add EC2 permission. Now I will go to that John user. Here you will see if I open S3, here you can see the John user can see all the S3 bucket, right? Now I will go to EC2, and since we have given EC2 permission, full access, it should be able to create EC2 server. Okay, so it will launch, I will launch a new server, EC2 IAM role demo. Okay, we'll go with all of this default value, proceed without key pair, and we will create this one server. Okay, so here you see our server. Let's wait for it. Let me terminate the older one. Okay, so you see my server is running. Now what I will do is I will connect with this server, and here you see we got error. Okay, while connecting with this EC2, we got error. Why do you think we got this error? Okay, so guys, you remember whenever we create EC2, SSH rule is there by default. So it's not a security group issue. Then what is this issue? This is the issue of EC2 itself. This is the issue of permission. Okay, so understand this. We have given EC2 full access to our John user. See, we have given EC2 full access. But sometimes what happens? There are few things that are beyond full access. For example, this feature of EC2 Instance Connect. This feature is beyond full permission. Okay, for this there is a dedicated different permission that is required. Now if you Google this, and generally this is what we do, you cannot memorize which permission is required for what. You cannot memorize so much. So what we generally do, we Google, and if you do Google, you will see that there is a service, add permission. Okay, you know what, let's take it as a task, how we can make it connect. Here you see access denied for by EC2 Instance Connect. Okay, so here you see these guys googled and they found out that some permissions are required. So here I will search them, EC2 Instance Connect. See this one. Okay, this is the permission required, right? And this is exactly what is required. So understand this, it happens sometimes. Like if you provide EC2 full access permission, you might think that that will be enough to connect with EC2 as well. But what we found out is that to connect with EC2, separate permission is required. I know that that doesn't sound right, but that's what it is. And we have to deal with it. Okay, we have to deal with it. Right? So I will select this policy. Next, add permission. Okay, now if I again go here and or if I simply refresh this, now you see it will work. So here you see shows again. See here I added that policy, this one, EC2 Instance Connect. This is the policy we added. Okay, so here we learned one thing, that sometimes not everything is covered in full access. Sometimes we have to Google and find out what is the missing permission, and we have given that. And you see, the moment I give that permission, immediately it is working. Okay, it is working here, right? Now we got access to EC2. Now from this EC2, I will try to work with S3. How to work with S3? Here I will type AWS command. Okay, now I will show you how to run CLI command in AWS. How to work with AWS through CLI. So here you see, I will type AWS S3. Okay, AWS command always start with AWS. Then we provide the name of the service, and then we provide command. Okay, So you guys already know what is ls command, right? Now, if you run the ls command with AWS S3, then this command will give you list of all the bucket. So if I enter and you see we are getting error. Okay, so this is what I was telling you. See, my IAM user can see all the bucket. Look at this. This is exactly what I was saying earlier. My IAM user can see all the bucket. Okay, but when my IAM user go to EC2, from inside when my IAM user try to work with S3, here you see it cannot see the bucket. Okay, so you see we are getting error. Now, how to solve this error? We will solve this error using IAM role. Okay, so now so here what happens? Let's say there's an employee who is getting such error. So that employee will reach out to you if you are a DevOps engineer. He will tell you that here I'm getting error, and you as a DevOps engineer, you will have to create a IAM role for that person. Okay, so what I'll do here, I will go to roles, right? And here you see there are many roles in my account. So these are related to my account. Here I'll create a new role. Okay, now you see when we click on create role, here you see I will create role for AWS service, and here I will select the use case. Now basically what I was telling you earlier, AWS IAM role allows your one service to work with another service. And here you can see list of all the AWS service. Okay, here you see list of all the AWS service. So you can create role for any one of them. But do you see Lambda and EC2 is mentioned separately? Why do you think EC2 and Lambda is mentioned separately? See, what is happening here? Lambda and EC2, these are the services where you can write code. In EC2, you can write CLI command. In EC2, you can write programming code. You can do anything. In Lambda also, we can write code. So obviously, wherever you can write code or CLI command, can we say there it increases your chances of working with other AWS service? Lambda is also AWS service where we can write code, just like EC2. Okay, so these two services are mentioned separately because these are the two services where we can write code and CLI command. So here it increases chances of working with your other AWS services more. It's also a compute service just like EC2. Lambda is very similar to EC2, but it works differently. Okay, so now since I'm working with EC2, here I'll select EC2. So I'm creating role for my EC2. Okay, next. Now, just like we have given policy for IAM user, just like we have given policy for IAM group, now similarly, we will give policy to our IAM role. Okay, we will give policy to our IAM role. So here I will select, let's say S3 full access. Okay, so if you look at this diagram, okay, so here you see when S3 full access is assigned to your IAM user, your user can work with S3 directly, right? When EC2 service wants to work with S3, we need IAM role. So you need to provide this or you need to assign this permission to your IAM role. Okay, then your IAM role will work. Okay, so here what happens? I will in the role, I will select S3 full access. Next, here I will give a name EC2 S3 IAM role 20th July. Okay, so this is the role name I've given. Now, IAM role is doing what? Here you see this trust policy and all. What exactly is this? Okay, you don't need to know all of this in detail. But here what happens? When we use this IAM role, your EC2 will get temporary credentials to work with S3. Basically, you can say behind the scenes, some temporary password is given to your EC2 so that your EC2 will be able to work with S3. Your EC2 will be able to access S3. Okay, so it will give temporary access and I will create this role. Okay, now what I need to do, role is created. Okay, but you need to attach this role to your EC2, right? So I will go to my EC2. Here I'll click on action. Here I will go to instance setting. Oh, sorry, here I'll go to security. If the role is created for EC2, it can be attached only to EC2. Now see how I will attach. I will simply select my EC2. I'll click on action. I'll go to security and here I will modify IAM role. So by default, there is no role attached to your EC2. So here I'll select my IAM role. And there you go, we are getting error. What is the error we are getting? Your user is not authorized to perform IAM list instance profile. All the EC2, Dilip. Your choice. If you want, you can apply it to one EC2 where you required, or you can apply it to all the EC2. Another permission we need to add. Do you see, even to see the IAM role, we don't have permission. What is the problem here? For my EC2, I'm trying to attach a IAM role, but I cannot even see those IAM role. I'm getting error for that also. I cannot even see the IAM rule. Because to even see the IAM rule, you require permission. Making sense, everyone? Okay. Now, how to go about this? Because if you go here, if you go to your user, my user cannot see IAM rule. Okay. Here, if you go to user, here if you click on add permission, here you if you give IAM full access. Okay. Next, add permission. And if you go back here, if I refresh now, see now my user can see the permission. But do you think it is correct to give IAM full access? Don't you think giving full access of a critical service like IAM can be very dangerous? Now this John user can remove other user, right? Now this John user can remove other user if you have given it IAM full access. So generally, it's not recommended to give full access of services like IAM because these are the critical services. Okay, so what we will do? I will remove this permission. I will remove this permission. Here I will click on add permission. And here now I will see. So I will not add any permission from there. Here what I will do, I will create a inline policy. Basically, we will create our own policy. Right? Now, either you can write JSON code for it. Okay, you can write a JSON code for it, or you can use this visual editor. Okay. So what is the permission that is required? This permission is required. This permission is inside which service? Okay, so we require this permission inside IAM. Okay, so this permission comes under IAM. But I don't want to give other permission. I don't want to give IAM full access. I just want to give this permission. So here in the visual editor, I will select the service. So my permission that I want belongs to which service? It belongs to IAM. So I will select IAM here. Now which permission I want? I want list instance profile, this one. Okay, here you can click on info and you can read what this permission will do, right? When you give full access, basically you are giving all of this permission. Okay, so many permissions are there when you go with full access. Do you need all of them? Absolutely not. I just need list instance profile. I just need this one permission. Okay, that's it. And you will see behind the scene a JSON code will be created. Okay, so I will create this permission. Do not worry, I will show you this in more detail, but understand the process. So here I will give a name, IAM inline policy, 20th July, create policy. Okay, so here I attach this inline policy to my user. Now, do you think we should get this error? If we have given correct permission, we should not get this error. Refresh, and there you go. Guys, do you see it is working now perfectly fine? See, what we did is we clicked on here add permission. So when you click on add permission, you will attach existing policy given by AWS. But what you can do is you can click on create inline policy. Okay. Now you see here, select a service. I selected IAM services because the permission I required, that is this list instance profile, that permission was here inside IAM. So here I selected IAM service and here I'm selecting the permission I required. That's it. Click on next, your policy is created. Okay, and you see behind the scene JSON code will be created automatically. Okay, so let's say you don't want to give your user complete access of S3. You just want to give your user to allow your user to create bucket. What should I do? Here I will select which service. I will select S3 service. Then here I will select which action. I will select create bucket action. See, understood now? Okay, so now what I'll do, I will attach that role to my EC2. And again, we got error. Just take it as a rule. Even any little action that you want to do in AWS account, everything require permission. Not only via root user, it can be done by admin user also, right? You don't need to remember this. None of this you need to remember. Understand the process, and whenever you get error, Google it and you will do the job. Nobody expect you to remember this. Okay, so you see again the same thing. So this time we require which permission? This time we require pass role permission. This time we require pass role permission inside IAM. So can I say instead of creating a new inline policy, I can simply edit our existing inline policy? I will edit this one. Okay, so here I'll come to visual, and what I will do? Earlier here we selected list instance profile. Now I will search for pass role. Are you guys understanding how simple it is to solve this error? You just need to Google. See, I know this error because I've been working on this since many years. You guys just need to Google. That's it. And nobody expect. I don't know. I hardly know few rules. I myself hardly know few policies. Nobody expects you to know all the policy. Not even one. Okay, just Google it at runtime. Nobody will ask you this in interview. So I will select this pass rule. Now you see in my JSON, along with list instance profile, pass rule is also added. Now if I update this, so I added pass rule to my John user. I added pass rule to my John user. So if I go here, now if I click on update IAM rule, do you think it will work this time? Yes, it will work this time and we will not get error. This time role will be attached. See, it is not giving any error. See, it worked this time. Okay. Now if I connect with this EC2, okay, here I'm already connected. Now if I run this ls command, okay, now if I run that ls command, do you think it will work this time? Yes, obviously it will work. See, now I can see all the bucket. Why am I able to see all the bucket now? Because IAM role is there. And IAM role give the permission of one AWS service to work with another service. So these are all the buckets created. Yes, these are all the buckets in our account. And we can see them here. Okay, so now, okay, we understood IAM role. Now, finally, we will cover IAM policy. Okay, how to create policy. See, you already understood here while creating inline policy. Okay, but I will formally explain it one more time. Okay, so let's understand the scenario. Let's imagine a scenario. Okay, now let's imagine a scenario. Let's say we hired college grads. Okay, and they don't know AWS. Okay, they don't know how to work with AWS. So obviously we will train them. We will give them AWS account to practice for practicing. Okay, we will train our grads. We will give them AWS account for practice. Correct? Now, when these new grads, they are working with AWS, let's say in our S3 bucket. Okay, let's say in this S3 bucket, let's say this two bucket, 25th Jan and 6th June. These two buckets are important bucket. These two are our project bucket. Now, obviously, if a fresh grad who don't know AWS, if they try to work on AWS, there is a chance that they might accidentally delete something. Okay, there's a chance that they might accidentally delete something, right? So what I want is, if if those new grad, if they delete any other data or any other bucket, it is okay for me, no problem. But if they try to delete anything inside this two bucket, or they try to delete this two bucket, then they should get error. Okay, then they should get error. So what we are defining here is that we should give them full access of S3, that they should be able to create new bucket, upload object inside this bucket, delete existing bucket. But when it comes to deleting this two bucket or the data inside this two bucket, they should get error. Okay, then they should get error. So how to take care of this? For this, obviously, we cannot use the default policy. For this, we will create our own custom policy. Okay, great. So we will go to IAM. Here we will create a new policy. Add permission. Oh, sorry, not add permission. Here we will go to policies. Okay, now you see these are all the policies that are these are the AWS policy, AWS managed policy. Basically, these are the policy given by AWS. Okay, but we will create our own policy. Okay, and again you see the same thing. Now my scenario is related to S3. So of course I will select S3 here. Okay. So what I want my user to be able to do everything, all the action related to all the bucket except those two bucket. So what I will do here, I will select all the action. Okay. So S3, I selected service S3 action. I selected all the action. This will include all the actions. And here I will select resource, all resource means all the bucket. And here we got this policy. Do you think this policy will do our job? No. This policy will allow us to do everything, any action with any bucket, but that will also include deleting objects and those two bucket. Deleting object inside those two bucket and deleting those two bucket. So how to take care of it? I will add one more permission. Again, I will select S3, but this time here you see effect. Okay, this time instead of allow effect, I will select deny effect. Here I will select deny policy, deny effect. Okay, here I'll select deny effect, and I just want to deny two things. I want to deny delete object. Here you see delete object, and I want to deny delete bucket. These two things I want to deny. Okay, So in this allow policy, we allow everything. In this deny policy, we will deny only these two action. And do I want to deny delete on all the buckets? No, I want to deny delete on only those two buckets. I will copy their name. First of all, this bucket. I don't want to delete this bucket. Okay, I don't want to delete this bucket, and I don't want to delete any object inside this bucket. So here I will select any object. Okay, if there is only one object that you don't want to delete, give the name of that object. Let's say in this bucket there is file.txt that I don't want to delete. Other than this, any other object can be deleted. So I will provide only this name. But I don't want to delete any object. Okay, so any object in this bucket should not get deleted. Now I will add the second bucket. This one 6 June. Okay, I don't want to delete this bucket, and I don't want to delete any object inside this bucket. Okay, asterisk means all or asterisk means any. Add ARN. Okay, now look at this. For this also, our JSON will be created. Now look at this policy. Okay, a policy is made up of statements. Here you see there is one allow statement and there is one deny statement. A statement is made up of 3-4 things. First is SID. SID is nothing but unique ID. Okay, anything. Visual editor 0, visual editor 1. You can give anything, just give a unique ID like a primary key. Then effect. Effect defines what this statement, whether this statement will allow or deny. Okay, effect is allow, it means it will be allowed. Effect is deny, means these things will be denied. Sorry, these things. But what is allowed, what is denied? So here is the action. Here in this deny statement, there are two actions, that is delete object and delete bucket. Means these two actions are denied. Okay. Here you see in the allow statement S3 colon asterisk means what? S3 colon asterisk means all the actions are allowed. Okay. Then you see resource. In the resource section you see asterisk, but here in the resource section you see those two buckets. And slash asterisk means object inside those two buckets. Okay, so resource represent the actual resource. Like for example, in case of S3 bucket. Now do you see there is a conflict here? Can I say in the allow statement, delete is allowed on these two buckets, right? In allow statement, can I say delete is allowed on these two buckets? But in the deny statement, delete is not allowed on these two buckets, it is denied. Now what will happen? Will it allow or will it deny? Always remember, deny will always take priority. Okay, when there is a conflict between allow and deny, always remember deny always take priority. Okay, whenever there is a conflict between allow and deny always take priority. Now here I will give you one scenario. Let's say my user is in a group. Okay, my user is in I am user is in a group, and in that group a S3 allow permission is there. But my user have S3 deny permission. What will happen? Will my user will be able to work with S3 or not? My user is in a group and that group have S3 allow permission, but there is a S3 deny permission attached to my user. So will it be allowed or will it be denied? It will be denied. Now tell me, my user is in the group and the group have deny permission, but my user have allow permission. Then what will happen? I told you, whenever there is a conflict between allow and deny always take priority. Doesn't matter whether deny is at the group level or is at the user level. Okay, if there is a deny, no matter what, it will always take priority. And think about it. Why this is the case? Don't you think deny is always safer? Giving priority to deny is always safe. Let's say you are accidentally given a deny permission. What is the worst that will happen? Your user will be denied. Your user can raise a request to the admin, and that admin will allow the user. But if allow permission takes priority, don't you think there is a chance that your user might accidentally delete something? There is no priority between user and group. IAM group is basically a collection of user. The policy you attach at the group level are given to the underlying user. User will inherit policy that are attached to the group. But there is no priority between user permission and group permission. Priority is there between allow and deny. And deny always take priority. Doesn't matter whether deny permission is coming directly to the user or it is coming from the group. Deny will always take priority no matter what. Okay, here you see my policy is created. I'll go to next. Here I will give S3 custom policy 20th July. Okay, and I will create this policy. Okay, so I created the policy. I will go back to my user and I will attach this policy to my user. Okay, so you see, this is the policy that I just created. I will attach this policy to my user. Okay, so you see, this policy is attached to my user. Now, if I go here to S3 bucket, okay, so see, now here I'm logged in as a John user. Now, can this John user delete other bucket? Can this John user delete file object inside other bucket? Yes, he can. Look at this. Yes, John user can delete object inside other bucket. Can this John user delete other bucket? Yes, he can delete other bucket. But can this John user delete this 25 Gen and 6 June bucket? Let's see. Can I delete file inside this bucket? The answer is no. You see, immediately we got access denied error. Okay, clear cut message, access denied. Can I delete the bucket itself? Of course not. You cannot even delete the bucket. To delete the bucket needs to be empty, but anyway, you cannot delete the bucket. Okay, but you can delete other bucket. Delete marker will be there when versioning is enabled, right? For the bucket, I did not enable the versioning. So delete marker was not created. Delete marker you get when versioning is enabled. How can you track IAM user from admin user? You simply go to IAM. Here you click on user and here you see all the IAM users. See, if you want to do tracking, then there is a AWS service called as CloudTrail. Here you see there is a AWS service called as CloudTrail. Now CloudTrail is a service. See, if you think that in your office account, you will do something late night, then you will delete it and nobody will know about it, you're wrong. Okay, everything that you do in your AWS account, everything is getting tracked. So here you see there is a service called as CloudTrail. CloudTrail by default, okay, you don't even need to set it up. CloudTrail will by default track everything that is happening in your account. See, it tracked my latest operation that John deleted this bucket. It tracked this operation of root user, that root user attach policy. IAM policy to John. It tracked that root user created a new policy. It tracked that John attach IAM role to EC2. Remember this we added. Everything is getting tracked. Okay. CloudTrail will by default store last 90 days of track. From here onwards, understand, any AWS service can be accessed by either root user or admin user or by that IAM user that have permission. If IAM user do not have permission, your IAM user cannot see work or see that service. Okay, guys.
Just a quick info, guys. Intellipaat brings you executive postgraduate certification in cloud computing and DevOps in collaboration with I Have Divya Sampar, IIT Roorkee. Through this program, you will gain in-demand skills like AWS, DevOps, Kubernetes, Terraform, Azure, and even cutting-edge topics like generative AI for cloud computing. This 9-month online bootcamp features 100 plus live sessions from IIT faculty and top industry mentors, 50 plus real-world projects, and a 2-day campus immersion at IIT Roorkee. You also get guaranteed placement assistance with 3 Azure job interviews after entering the placement pool. And that's not all. This program offers Microsoft certification, a free exam voucher, and even a chance to pitch your startup idea for incubation support, up to rupees 50 lakhs from IAP Divya Sampark. If you are serious about building a future in cloud and DevOps, visit the course page linked in the description and take your first step toward an exciting career in cloud technology.
Okay. We are going to understand auto scaling group. Okay, so auto scaling group. Now, for that auto scaling group, let me go back to my EC2 because I told you already, auto scaling group is not a different AWS service. It's a part of EC2. So here on the left side, you will see auto scaling group. Okay, here I will go to auto scaling group. I'll click on create auto scaling group. And now again, you see there are certain steps that we need to follow and we will get our auto scaling group. Okay, here I will give the name demo ASG. Okay, here in the launch template, I will, okay. Now you see there is something called as launch template. Okay, now what is this? See, in auto scaling group, what exactly auto scaling group does? What is the main function of auto scaling group? See, auto scaling group will add more and more server when the load increases. an auto scaling group will remove extra server when the load decreases. That is the job of auto scaling group. Okay, when the load increases, add more server. When the load decreases, remove extra server. That's the job of auto scaling group. Okay, now removing server is easy. Okay, removing server is easy. Removing server is not a big deal. You can easily remove server, not a big deal. But adding new server is a big task. Why? Because the question is, what kind of server you will add? Okay, what kind of server it is going to add? That's the question. Okay, obviously we want to add same kind of server that we already have with the same configuration, with the same application, with the same software, right? We need to add the same kind of server. That's the point of auto scaling group. Okay, we don't want to add some different kind of server. Okay, so how do we define that? How do we define what kind of server we are going to add? That's the main question. Okay, so to deal with that, we have a concept of launch template. Okay, to deal with that, we have a concept of launch template. Okay, so here I will go. I will on the left side you will see here is a launch template. Now, what is launch template? Launch template is a blueprint. Okay, of what kind of server we are going to get. Okay, launch template is a blueprint of what kind of server we are going to get. Right? Launch template is a kind of blueprint is a blueprint of what kind of server we are going to get. So that's why when we create launch template, at that time you will see all the same option as of EC2. You will see exactly same option that we see when we create EC2. Okay, exactly same option. Here I will give a name. Let's say demo launch template, demo LT. Okay, 15th June. Okay, this is the name of the launch template. Here you see in the AMI, I will select my Amazon Linux AMI. Okay, so you see exactly same option as EC2. Okay, exactly same option as EC2. But are we creating EC2 server here? No, we are not creating EC2 server. All that we are doing is we are defining the configuration. Here we define that we want Linux AMI. If I select Windows AMI, then what kind of server we will get? We will get Windows server. Okay, we will get Windows server. If I select Ubuntu, we will get Ubuntu server. Okay, so here we define AMI. Okay, so if I whatever AMI I define, that kind of server I will get. After that, here in the instance type, okay, in the instance type, I can define what kind of instance type I want. T2 micro, T2 nano, all of that. Okay, whatever I select here, that kind of server I will get. If I select T2 micro, then whatever number of server my auto scaling group create, I will get that kind of server. Okay, if auto scaling group create 100 server, all of them will be T2 micro. Okay, if auto scaling group create 100 server, all of them will be Linux AMI, because that's the configuration I defined here, right? Here in the key pair, I can select, let's say, let's not select key pair. Okay, we can select that also later, right? Here you see I'm saying don't include in launch template, right? So as you can see, I'm defining the same thing. Basically EC2 I'm defining, but it will not create EC2. It's just a blueprint, right? After that, here you see all the same option. Let's go with all the default options. It will select, uh, um, let's say, default security group. This will be replica of your initial server. Okay, obviously we want this AMI to be replica of our existing server. Otherwise, what is the use of it? Then here in the EBS, we can select our volume. Here you see 8 GB. This is the root volume. If we want, we can add more volume, or we can keep it to only root volume. Okay, here we can add tags. Let's say I will add a tag name EC2 launch template. Okay, name EC2 launch template. Right? So this is the configuration I'm defining. Now you tell me one thing. Okay, let's say I already have two server running in production, and those server are hosting some web application. Okay, I already have two server and they are hosting some web application, right? Now the new server that get created, okay, the new server that get created, those new server, obviously you guys will agree with me, they should also have the same web application being hosted. How can we make sure that the new server that are created, they will also have the same web application? Can I say in the user data, I can define the entire script of hosting the web server, connecting with database, everything I can define here. So whenever a new server is created, it will create the server and it will execute the user data script, and we will get the exact same replica. Okay, so here I will create this template. Okay, so you see my template is created. So what will happen if I go with this template? I will get a T2 micro instance. I will get a Amazon Linux AMI. Guys, think about it. When we work with EFS, how we made all the correction, how we set up everything. We set up everything by running commands in our EC2. So the command that I can run in EC2 by login inside EC2, don't you think I can provide the same command in the user data script? Now here is my template created. So this template defines us. Did it give us any EC2? No. Okay. So what I'm saying, here we will get T2 micro. Here we'll get our AMI ID. But what if tomorrow my requirement changes? Okay, tomorrow my requirement changes and we have some other requirement. We have a requirement of some other kind of EC2. How we will get that? So what we will do is either we can create a new template, okay, or we can edit this template. So when we edit this template, let's say today we are working with T2 micro, but tomorrow we have some other requirement. So what I'll do, I will simply update the template. Here I will provide the description version 2. Okay, and here I'll select instead of T2 micro, let's say tomorrow we have a requirement of T3 medium. Okay, I'll modify the template. Now you see this template got two versions. See, in one version I will get T2 micro, in another version I will get T3 medium. Look at this. Okay, now do you think this launch template will cost us money? It will not cost us money. Why? Because it's just a template. It's not creating anything. It's not creating server. It's not creating anything. Using this template, when auto scaling group creates a new server, then the server that are created using this template, those server will cost us money. Template will not cost money. Okay, so here is my template ready. Okay, I'm done with template part. Now what I'll do, I will click on here. Now here I will go to auto scaling group. Okay, now here I will create an auto scaling group. Here I will give a name, demo ASG. And the very first thing we need to do after giving the name is to select the template. Okay, we need to select the template. What kind of template we are dealing with, what kind of template we want. Okay, what kind of template we want, that we need to select here, right? So here you see all of my templates are available. I'll go with this one, and here I can select version. Tomorrow, if my requirement changes, I can simply select the version of the template. I can simply change the version of the template. In this way, you can go with the same template. You don't need to create new template every time. In one template, you will have all the version, and you can keep modifying it as your requirement keep changes. Okay, so we'll go with this one. I'll go to next. Now here in the next screen, you see here we define instance launch option. Okay. Now I will also show you a way where we can define where we are getting our server, in which AZ we will get our server. So here we can do that. So here you see when I click on this again, I can see all the 6 AZ. Now if I select this AZ1A and I just select that one AZ1A. Okay, it means I will get all of my server from this one AZ. Okay, I will get all of my server from this one AZ only. If I select, let's say 2 AZ, now if 100 servers are created, 50 server will be in AZ1A, 50 server will be in 1B. If I select 3 AZ, 33 here, 33 here, 34 here, or here you will get 34. Okay, so now we get that guarantee. So can I say if I select AZ, if I select only this 3 AZ here, AZ1A, 1B, 1C, okay, if I just go with this 3 AZ here, can I say we get a guarantee that now if I create load balancer, now I know where I will get my server, so I don't need to select any random AZ. I can only go with the AZ that I want. Yes, now I get that guarantee. Okay, so if I select all the AZ, then equally and see when auto scaling group create the server, it will equally create server in all the AZ. It's not that it will overload one AZ with more server, second AZ with less server. No, if it creates server, it will create server equally in all the availability zone. Not that in one AZ you will have all the server. How? There is no answer for how. It basically, see, for example, load balancer. You saw that there also equally we were getting response from underlying both the server. I told you that's a round robin fashion. Exact same fashion is exact same pattern is also followed here. When auto scaling group creates server, it will create the server. I mean, see here, you want high availability. High availability means what? You have presence not in only one place, in multiple places. But it's not that in one place you have all the presence. No, you have equal presence in all the AZ. Okay, so let's say today I will not select all the AZ. Today I will go with only 3 AZ. It means what? If I create 100 server, 33 will be here, 33 server will be here, 33 will be here, and the next server will start again from here. So here 34, 33, 33. Okay, so here we can define that. And here you see balance best effort. Here you define the distribution. Okay, so for example, if launch fail in one AZ, auto scaling will attempt to launch in another healthy AZ. So for example, let's say here while launching in you, let's say 33 here, 33 here, 33 here, or let's say first server it is launch here, second here, third here. Now while launching fourth server in AZ1A, if some issue happened in this AZ, it will move forward to AZ1B, right? But if you go with balance only, here you see if launch fail in one AZ, auto scaling will continue to attempt launch in unhealthy AZ. Okay, so for example, let's say it is launching it is launching 6 server. So if you go with balance, if you go with best effort, means what? First server will be launched here, second here, third here, fourth server will be launched here. But let's say while launching fourth server, some issue happened, then it will launch fourth here, fifth here. Then it is launching sixth here, but again some issue happened, it will launch the sixth here. So in AZ1A, how many server we have? One. We have one server. One server we have in AZ1A. First server is launch here. Second server is launch here. Third is launch here. While fourth being launched here, it failed. So it will launch the fourth in second. Then fifth is launch here. While launching sixth here, it failed. And it is launched here. So in AZ1A, how many server we have? We have only one server. In AZ1B, how many server we have? See, AZ1, AZ2, AZ3. Okay. Let's say here server 1 is launched. Okay. Here server 1 is launched. Okay. And it was successful. Okay. It was successful. Then it launched server 2 here. Okay. Successful. Then it launched server 3 here. Successful. Okay. While launching server 4 here, it failed. So what it will do? It will move to second AZ. So it launched server 4 here. Now here it is trying to launch server 5. Okay. Server 4 successful, server 5 successful. Okay. Now it is trying to launch server 6 here. But again, this AZ has some problems, so new servers are not being launched. So again, it will fail. It will launch here. So how many server we have in AZ2? We have 3 server. Okay. In AZ3, we have 2 server. Okay. So this is the distribution we get. All right. Now moving forward, we'll go with best balance, best effort. Let me again select 3 AZ, AZ1A, 1B, 1C. Now here you see, we can skip to review also. Okay. Till this point, it was mandatory. Here we can skip to review now. Okay. Because other options are not so mandatory. They are optional. But let's go through them also. And here comes the load balancer. How load balancer will know about auto scaling group and all? This is the answer. Right? Here we can select our load balancer. So while creating auto scaling group, we can select load balancer. Does any load balancer cost money? Obviously, it will cost money. It is giving you some facility. It is giving. See, understand this. There are some things that are available for free in your free tier account. Okay, but if you talk beyond free tier, understand everything that you create in AWS except few things, except launch template, except few things, and I'll tell you whenever those things comes. Understand everything will cost you money because you are using it for your real world project. You are actively using it, so it will cost you money, no doubt. Okay, very few things are there that does not cost you money. I'll give you something, 1 minute. Okay, on this web page, here you will see all the limitation of free tier account. Okay, all the limitation you will see. Okay, understand this. If free tier account is expired, everything that you create will cost you money. Okay, so whether you create auto scaling group, whether you create load balancer, everything will cost you money beyond free tier account. Yes, there are few things like launch template that doesn't cost money. And whenever we came across such concept, I will tell you that this particular concept doesn't cost money. But rest of all the things will cost you money because you are using it for real world software from which companies are earning billions of dollars. So of course, AWS will not give it to free. One habit I want you guys to include: whenever you do any practical or whenever you start studying, or whenever you do any practical, just search for the service that you're working for. So we are still covering, let's say we are covering EFS. I will search for EFS. And now here I get the information, okay, EFS is available until 5 GB. If you store data more than 5 GB, it will cost you money, but before 5 GB, EFS is available. Okay, you can click on this and you can see even more detail, like up to how much things are available for free and not. Here you can go to pricing page and you can see in detail. Okay, but don't try to memorize any of this thing because this thing constantly changes. So it's not use of, there's no use of memorizing it. Don't try to memorize this. Okay, whenever you are working with anything, check the documentation, check the latest documentation. Okay, so here you see, while creating the auto scaling group itself, okay, while I create auto scaling group, at that time itself I can select my load balancer. I can select my existing load balancer target group, or I can create a new one. Now pay attention, when I create a new one, let's say here it will allow me to create a new ALB. First of all, see, it is not allowing me to create CLB, it is allowing me to create ALB, right? Here you see, while creating the load balancer, here we can select our all this option, and exactly same option we had yesterday. But do you see something new here? Why only these 3 AZs are selected? Because in the auto scaling group, we selected 3 AZ. If we want, we can select additional AZ. Although it is not of any use, but if you want, we can select it. But we can't uncheck this 3. Okay? We can't uncheck this 3. Why? Because these 3 AZ are the one. Okay? These 3 AZ are the one that are where our auto scaling group will launch the server. Got the point? These 3 AZ are the one where our servers will be launched. So we can't uncheck them. They have to be selected. Other 3 AZ, it's okay even if you don't select them, because they are not the one where our auto scaling group will launch the server. See, if you select others, then it can support some other servers in those other AZ, right? But in real world, it's not that useful. I mean, obviously, we want to send traffic to the server that are created by this particular auto scaling group. We don't want to send traffic to the server that are from outside, or that are not that does not match with this one. Okay, so here all the 3 AZs are there. These 3 AZs are selected. Now moving forward here, I will not create the load balancer. I don't want to mix both the thing at once. Okay, but here you can select the exact same load balancer that we created yesterday. Right now, during learning, what we will do, we will cover every concept one at a time. Okay, we will not mix up the concept. Okay, we will cover concept one at a time. But in when you have your project session, there you will see all of this thing being combined. Then VPC, ignore this part, ignore all of this part. This part anyway we are going to cover. Okay, and now in the next step, okay, this is important, this is very important part. The next step, guys, what is DDoS attack? It's a fake traffic that comes on your server, and because of this fake traffic, what happened? Your server will get down because your server will be overloaded. Okay, your server will be overloaded, right? Now how to prevent that? Let's say we don't have anything else. I told you there are some services that will help us prevent this. Okay, or let's just say we can't prevent the DDoS attack. How do we save ourselves from getting lost? What do you think? See, the problem with the DDoS attack is what? You are getting fake traffic. Okay, you are getting fake traffic, right? Now, if you have something like auto scaling group that will keep creating new server when your existing server get overloaded, don't you think fake traffic will keep coming in? Auto scaling group will keep launching new server, and it will increase more and more cost. Do you agree with that? Because AWS is very powerful. AWS can launch unlimited server. But the problem is that you will have to pay money for that fake traffic, fake for those useless servers. So that's why here we have group size. Group size means what? Here we can define minimum capacity. Here we can define maximum capacity. What is the meaning of this? Minimum capacity means when the load is zero. Okay, when the load is zero, the number of server will go down. Okay, till this minimum value, that is 2 server. If you are getting zero traffic, if you are getting no traffic at all, then at minimum you will have 2 server at any given point in time, even if you are getting zero traffic. But if the load increases on your server, okay, it will add maximum 7 server. That is our max capacity. Okay, that is our max capacity. If the maximum desired capacity is reached, what will happen is your existing 7 server will get overloaded, because auto scaling group will not add any new server. And if the 7 servers are getting all the traffic, then they will obviously get overloaded. They might fail also. But AWS will not cross this limit. Okay, this 7 server will get overloaded because obviously you are not launching any new server. So if the 7 servers are there, then they will get overloaded if your traffic is keep increasing. Okay, so I hope you guys are clear with this minimum and max desired capacity. What is this desired capacity here? This one. This desired capacity is your initial value. Okay, this desired capacity is your initial value. So here, if I define 4 means what? Auto scaling group will launch with 4 server. 4 means what? Auto scaling group will launch with 4 server. Got the point? Desired capacity is your, in short, initial capacity. All right, I hope you got the point. This is very important. Okay, this group size is very important. After that, here you see, rest of the things are related to dynamic part. So I mentioned this earlier also. Minimum should be less than desired. Yes. See, here you see rest of the things. Here I want you guys to understand we are covering only the there are we can divide the auto scaling group in two parts. Okay, this is static part that we are covering and the dynamic part. Got the point? Static part does not increase or decrease. Okay, so we'll keep all of this thing as default. We will go to next. And now here you see notification option. Now what is notification option here? What is the meaning of this? Notification here simply means we can add. So basically what is the requirement here? When the load on your server increases, auto scaling group will add server. But you guys know that this can happen at any time. This can happen at morning 3 o'clock or morning 5 o'clock. At any time it can happen, right? Okay. So we want a notification for it, because at morning 3 o'clock, if my auto scaling group adds new server, how will I know about it? That's a simple thought. How will I know about it? Right? So there has to be a way in which we are getting emails. Okay, in which we are getting email. So whenever the server auto scaling group add new server, we should get an email, and that can be done here. Okay, so that can be done using something called as SNS, simple notification service. And SNS is a separate AWS service. Okay, you understand my point, right? There is not even a single service that you can say you can start from beginning. Every service is dependent upon one another. Okay, every AWS service is dependent upon another. So this SNS part also we will cover later. But right now just understand it is used to send notification. And the last part here we can add tags. I will add only one tag, name, ASG, EC2. Okay, so you see my auto scaling group is launching. Meanwhile, I will go to EC2 and you see these are my yesterday's server. Okay, let me terminate them. Now you will see how many server we should see now. Auto scaling group is launching. How many server we should see? We should see 4 server, because that was our desired capacity. And I told you desired capacity is the initial capacity. So while auto scaling group is launching here, okay, we should see our server here, and you see the same tag, ASG EC2. Got the point, guys? This is how auto scaling group works, right? We can see, obviously here I will not be able to show you the dynamic part. Static and dynamic difference basically means, here if you see, if the load on this 4 server increases, you will not see new server getting launched. Okay, right now there is 0 load on this 4 server, but you still see 4 server, you don't see 2 server. And if the load increases, you will not see 7 server. Why? Because this is not dynamic right now. In static auto scaling group, server will not increase or decrease automatically. Okay, so this shows you the fact that for auto scaling group to work, to do its job, for auto scaling group to do its job, it requires some other AWS service as well. Okay, see, auto scaling nobody uses in this static way. Okay, by default, see, if you remember, while creating that auto scaling group, I skipped that part. Okay, I skipped this auto scaling part. Obviously, if we scale this part, then we can't expect it to work correctly. And that's why nobody works with static auto scaling, and there is no words like that as well. I just made it up to explain you the concept, because this concept have a dependency on another AWS service. So we need to understand that as well. Then only you will understand this. Then only we will see auto scaling group as a complete entity. But as I said, every AWS service have a dependency on one another. We have to start from somewhere. And this is the problem, guys. I mean, this is the issue that with the cloud, that there are some services that are recommended to start with, like EC2 or S3, but all of them have some little bit dependency at least. Okay, because there are some, see, it depends on the service. Matrix and pricing, these are the two things that depends from service to service basis. Okay, the kind of policy you have for EC2, they are totally different from storage policy. Okay, and also if you delete the auto scaling group, naturally all the servers that are created by auto scaling group are deleted. And this may not be a big concept, but this is, many times your interviewer may try to ask such question to confuse you. If it is dynamic and they are not getting any load, so they will be removed till the minimum value, right? So your interviewer might ask you, if I delete auto scaling group, what will happen? If you delete your auto scaling group, your server should get deleted. Okay, here you will see server are also deleted. Now here in exam or in your interview, not so much in exam, but in your interview might try to confuse you that if I delete the auto scaling group, okay, my servers are already created, my servers are separate entity. Then if I delete auto scaling group, why my servers are getting deleted? Do you understand my point? They will try to confuse you like this. But yes, and they are correct also. Your auto scaling group is a separate entity. Your servers are separate entity. Okay, both of them are separate entity, right? But still they are connected. That's why if you delete the source from where servers got created, and this pattern you will see everywhere in cloud. Okay, in our course, very soon we will cover some services like CloudFormation. Okay, you will see this pattern in our AWS as well. Whenever there is a source that creates some resource, if you delete the source, resources are also deleted. Guys, there are two types of cloud. Okay, actually there are three types, but mainly there are two types: private cloud and public cloud. Okay, private cloud and public cloud. What is public cloud? Public cloud is basically your cloud like Amazon, AWS, Microsoft Azure. Okay, these are public cloud. Means what? Public cloud are those cloud where you utilize the data center of some other company. That is Amazon. This AWS is what? AWS is nothing but AWS have their own data center all over the world and you are using them. Okay, and private cloud is the cloud created by a company. Okay, let's say you are working for one organization, they created their own private cloud. In private cloud, does people from outside get access? No. In public cloud, outside people can create their account, not in private cloud, right? Now, can we say private cloud is by default in theory? Private cloud is more secure than public cloud. Do you agree with this? Public cloud, everyone is using. NASA uses AWS. Okay, NASA uses AWS. So so does it mean they are anywhere less in security? No. In fact, I would argue public cloud provide much better security than your private cloud. Okay, but how? VPC is the answer. VPC is a AWS service that provide that security. Okay, VPC is a service that basically make your public cloud into a private cloud for you. Okay, VPC is a AWS service that makes sure that even if you are working on public cloud, okay, let's say I create my account and Tarang also created his account, and both me and Tarang are working from, let's say, North Virginia region, and let's say coincidentally my server and Tarang server is created from the same hardware. Behind the scene, the hardware is same. Okay, now even though Tarang's server is coming from same hardware as my server, it doesn't mean that his server and my server will get mixed up. It doesn't mean that our server will get mixed up, right? It doesn't mean that our data will get exchanged. How we are getting those security? We are getting those security because of VPC. VPC is the service that basically give you the experience of private cloud, even though you are working on public cloud. Got the understanding? Okay. See, to understand VPC, we'll understand first the problem that all of us are working on AWS cloud. Okay, all of us created our AWS account, right? All of us are working in North Virginia region. There are thousands of people that are working in North Virginia region. Then isn't it making any issue? Isn't it causing any issue when all of us work on the same hardware from the same region? No. Why? See, the concept is simple. This is AWS cloud. Okay, let's say this is entire worldwide AWS cloud. This is my account. In my account, I create a database in North Virginia region. Okay. Similarly, this is somebody else account and they created EC2 in their account. Now, since their EC2 and my database are from the same region, isn't there any chance that they might access my database? The answer is no. This will never happen. Why this will never happen? Because when you work on AWS, when you create your AWS account, okay, you get your own dedicated VPC. Okay, you get a VPC in your account. Actually, this is inside account, but I'm keeping it outside as of now. Okay, every AWS account in AWS, every AWS account in AWS gets its own dedicated VPC. Okay, it gets its own dedicated VPC. Why? This is by default. And what is this VPC? This VPC is the private network boundary. This VPC is the private network boundary within which you operate. Okay, within which you operate. Now, when you so what happens? Even though you and your another AWS account are working from the same region, even though both of your, let's say, underlying hardware is exactly same, still they cannot access your account. Why? They cannot access your account because every account is protected by VPC. So no other and nothing from outside of your of that VPC can access your resource. No other AWS account can access your resource in your VPC. VPC provides you a private cloud. Okay, so you can understand in a way that when you work on AWS, which is a public cloud, in that public cloud you get your own, okay, your account, my account, all of our accounts are protected by VPC. That's why even though we are working on public cloud, nobody from outside can access our account. You got the answer for why public cloud is as secure or even more secure than private cloud. This is the answer. VPC is the answer. I will not compare it with social media account because it might confuse you in the technical part. That's a little different thing because the social media account comes at a software level. Here we are understanding things at the platform level. Okay, so we operate within VPC. Now, what happens if I go to my account? I will go to the VPC here. If we create our AWS account, we get a default VPC in every region. Okay, we get a default VPC in every region. Right? So you see in my North Virginia, there is one VPC. If I go to any random region, let's say I go to Tokyo, here also you will see a VPC. So this is called as default VPC that we get in every region by default. And this same VPC you have in your account. Okay. This same VPC is there in my account in every region, and the same VPC you got, I mean, same configuration VPC you got in your account. Okay, now please don't go and check it right now. You can trust me, it is there in your account as well in every region. Okay, but this default VPC we cannot use for our real world project because default VPC gives you a lot of things. That's a good point. Okay, default VPC gives you a lot of things by default, but it cannot be modified much. It cannot be used for our purpose. Okay, so if you are working on a new project, the better thing is to create a new VPC, custom VPC. VPC ID will be different. ID is a unique identifier, so it will always. Okay. Now see, I will come back here. So before I get into custom VPC and all, I will explain you few more things. So I'll first of all tell you why VPC. VPC is such a tough service because VPC includes so many things. On your screen, you can see a VPC architecture. And you can see VPC is not just one thing. It's a collection of so many things on that you see on your screen. That's why people find it very difficult. Okay, but do not worry. I will show you VPC from scratch. In fact, I will create one diagram right now, and we'll understand the entire introduction. I mean, we'll understand the entire overview. Okay, and after that overview, we will do a deep dive into each and every topic, and then we will do the practical as well. Okay, but first of all, I will give you a good overview. So let's say this is my VPC. Okay, this is my VPC, and my VPC is a regional service. Okay, this is my VPC. Okay, this is a VPC in any of the region. Let's say we are creating a VPC in a Ohio region. Okay, now VPC is made up of few things. VPC is at the region level. Okay, so if VPC is like a region, then what do we have inside? Within region we have AZ. Okay, so here I will write within region we have AZ, and within VPC we have something called as subnets. Okay, what is subnet? Region is a bigger area, AZ is a smaller area, VPC is a bigger network, subnet is a subnetwork or smaller network. Alright, VPC is a bigger network, subnet is right. So here you see in this VPC we have called as, yes, you can say logical subdivision at a network level, right? So here in VPC we have one subnet, or let's say two subnet. We can have sorry, we can have even more subnet, but I'll put right. So subnets are of two types. There's a public subnet, okay, and then there is a private subnet. Subnets are of two types. Right now, just understand. See, detail we will see later. Right now, just understand subnets are of two types. There's a public subnet, there's a private. Okay, public subnet, private subnet. Now, what is the meaning of public and private subnet? Or what is the use of it? See, the EC2 server we can create are of two. Okay, EC2 server we can create, they are of two types. We can create a public server and we can create a private server. The server you create in public subnet is called as, this is a EC2. The server you create in public subnet will be a public server. And the server that you create in private subnet will be a private server. Okay. Again, what is the technical difference between public server, private server? What is the technical difference? We'll see later. But right now, just understand, servers are according to subnet. If you create a server in public subnet, you'll get a public server. If you create a server in private subnet, okay, so this is public server, this is private server. Now, here I will ask you guys one question. Let's say in public subnet, we have two public server. Can I say these two server can easily talk to each other? Compared to public server, gateway is a different thing. But see, what I want you guys to think in a way is that if there are two server in public subnet, means both of them are public server. These two server can easily communicate with one another compared to public server in public subnet and private server in, right? Because see, the logic here, I mean, I will give you an analogy. If me and my colleague, both of us are working from office, do we need any tool like Microsoft Team or Zoom for? No. We are working from same office, we can directly talk to each other. But let's say me and my colleague both are working from home. Okay, my colleague is working from their home, I'm working from my home. Now can I say now that we need something extra for communication, like some on, now we good. Okay, so now we need something extra. So here you see, this two server can easily communicate because they are in same subnet. But when it comes to server in different subnet, there we need something called as implicit router. Here we need implicit router. What is implicit router? Implicit router is basically a tool, and we don't use this tool. This is used by AWS. It is created by AWS. It is used by AWS for its internal communication. Implicit router is a tool that provide communication between server from different subnet. Okay, it helps between communication. It helps for communication between server from different. Okay, we don't configure implicit router. That's why it is called as implicit. Implicit router will be created by default because we don't even use it. Okay, our the communication that we set up, they are done separately. This is for internal communication between server in different subnet, and this is created and used by AWS themselves. That's why it is called as implicit, so that we don't need to set router. Now here I will ask you one more question. Let's say in this public server, okay, we want to let's say we are creating a website, we are running a web application, and in this public public server, we have our web application running. Now we want to download something. Do you think we will have access to public? The answer is no. Guys, think about it. Here we are talking about private network. In private network, if you have public internet, don't you think that will? Do you agree with this? that if we are talking about a private network, virtual private cloud, then having public internet there defeat the entire purpose. If we have a default access to public internet, don't you think it will defeat? I'll come to that. So, but do you also agree that, okay, we require internet? There is nothing like private internet. We require internet. Otherwise, if we do not have internet, then how we will download any library for our development? If we do not have internet, then how we will update our database with the latest security patch? If we do not have internet, then how we will do any of our work? Without internet, we cannot do anything in server, right? So we don't, the fact is we don't have access to public internet. Okay, that's a fact. We don't have access to, on on top of it, we require internet. So how do we get it? So for that, we have something called as internet gateway. Earlier, some people were talking about this. For that, we have internet gateway. What is internet gateway? Internet gateway is a component that brings internet in your VPC. Okay, how do you get internet in your home? How does all the device in your home get internet? When you add a Wi-Fi router, then you get internet. Similarly, when we add a VPC router in, when we add internet gateway in this VPC, okay, when we add internet gateway in this VPC, then we get internet for our underlying server. Internet gateway is that component that will bring the internet for our server. By default, we don't have access to internet, but we need. How do the server of same subnet communicate with each other? We'll see. Right now, just focus on what I'm covering. As I said, right now I'm just giving you overview. One by one, we will see all of this thing in detail, and I will also show you practical. But right now, just focus on what I'm showing you. Just understand the introduction of all the components. Then we'll see each and every component in, right. So internet gateway, you can compare this with your Wi-Fi router. You apply Wi-Fi router at your home, and all of your devices get internet. You apply internet gateway to VPC, and all the component in VPC, right? But here comes, okay, how does my public server knows that there is something called as internet gateway that is giving? How does it knows about it? Because your server have no idea about internet gateway, no idea. It's just that's how it works. So how to make sure, how to already know? For this, we will use something called as root table. Okay, let me put a diagram here. For this, we will use something called as root table. In root table, we will have target and destination. Okay, and here we will add the root that if anybody wants internet, then go for internet gateway. If anybody wants internet, then go for internet gateway. Okay, this is the root we will add. Now, whenever EC2 server wants internet, it doesn't know about internet gateway. It have no idea about internet gateway. So what this EC2 will do? This EC2 will go to root table. Any component in VPC always go to root table first. And when it goes to root table, there it will see that if you want internet, then go for IGW. So that's how it reaches to internet gateway. And when it reaches to internet gateway, my EC2 will get internet. Okay. EC2 requires something through which it can get internet. It goes to root table. There it see if you want internet, go to IGW. Then it get the IGW. As simple. Younger folks, this is like a Google map. Let's say I'm moving to London for, let's say, for few months. Okay, and I want to drink coffee. I don't know any cafe in London. I don't know where I can get the coffee. So what I will do, in my Google map, I will just type coffee or cafe near me, and Google map will give me the list. So can I say Google map is like this route table where all the routes of all the places is there as a directory? Okay, so route table also we discuss. But did you notice I was talking only about, you can give route for anything. all the components in your VPC. We can give root for, right? Now in this VPC, did you notice I was talking only about public server? What about private server? In this private server, we might be hosting a database also. What if tomorrow a new version of our database? Okay, we need to update the data. Okay, now talking about private server. In private server also I need internet. So can private server use the same method? The answer is no. Okay, the answer is no. Okay, technical reason we will see later. Right now, just understand that if my private server needs internet, it cannot follow the same approach as public server because it's not a public server. Public server have different approach. Private server have, right? Now, how does private server get internet? Private server gets internet using something called as NAT gateway. Okay, and understanding NAT gateway concept is little difficult for most people. So I will give you a simple example. Okay, I will give you a real world example. Okay, up until now, I have given you real world example in many places. I've given you real world example for implicit router that me and my colleagues are working from our respective work from home. So we require something like Microsoft Team for communication. For internet gateway, I give you the example of Google Map. And now for, I will give you one more example. So let's say this is my home. Okay, this is a home. Now this home is divided into, let's say, two parts. Okay. Now, let's say I got infected by COVID. Okay, nowadays COVID cases are again rising. Okay, so let's say I get infected by COVID. Now, what I'll do in this home, this is my, let's say, bedroom. This is my private bedroom. Bedrooms are private, but yes, this is my private room. Okay, so I got infected by COVID. So can I say the very first thing I should do is to isolate myself here? Okay, I will isolate myself, and in other rooms, my other family member will be there. Okay, in other rooms, other family member will be there. Right? Now, let's say here is my brother. Okay, my brother is not infected by COVID, so he lives in different room. Now, near my home, I know this example sounds very silly, but trust me, you will understand everything. Near my home, there is a pizza shop. And the sole purpose of this pizza shop is to provide pizza, nothing else. Near my home, there is a pizza shop. And the sole purpose of this pizza shop is to provide, right? Now, can I say my brother who is not infected by COVID, he can easily go out and get the pizza from this shop? Yes. But can I go out? No. I'm infected. If give me the answer, how can I get the pizza? The person who is in. Can I say I can ask my brother, since he can go out, he will go out and bring the pizza for me? This is the right. Everyone pay attention. Can I say this home is like the VPC? And if this home is like VPC, can I say this private room is like a private? And if this private room is like private subnet, can I say the person isolated here is like a private sub? Can I say if this is a private subnet, other room we can consider them as public subnet? Can I say this pizza shop whose sole purpose is to provide pizza is like internet gateway whose sole purpose is to provide here? So what do we call this brother who is bringing that pizza for our private server? This brother is called as NAT gateway. NAT gateway is that brother who will live in public subnet. And since NAT gateway is in public subnet, it can go and get the internet like your public server, like this. But unlike public server, it will not use internet for, okay? It will not use internet for itself. Rather, what it will do? It will bring the internet for private server. Okay, so to answer the question, how does our private server gets internet in VPC? Our private server gets internet through. Now see, if I give you one example here, let's say 192.136.11.22/32. If I give you this example, this is an example of a IP address. Okay, but how many IP does it represent? It represents only one IP address. Okay, it represents only one IP address. See, this part is called as network. Okay, and this part is called as host ID. This 32 is called as host ID. Now, what is host ID? See, network ID, we know it's an IP address. It is made up of 4 blocks, and every block have a range 0 to good. Okay, you get a range from 0 to 255. Every block in this IP have a range from 0 to 2. Okay, but why this is one IP total? See, host ID represent the range of your IP addresses. How many IP you get? That is defined by how many IP you get is defined by, right? Now 32 does not represent any range. I know I just said that it represents range. I said host ID represent range, but 32 represent no range. Here we get only one IP. Okay. Now everyone pay attention and try to understand the pattern. Okay. 192.136 or 163 anything .11.22/24. Now 24 represent the change in last one block. 24 represent change in last one block. So you get a range from where to where? You get a range from 192.163 or 53 whatever .11.0 up to 192.163 or sorry 153.11.255. Okay, your last block will change, and of course if it change, it will change completely. So total how many IP we are getting? We are getting total 256 IP, correct? Didn't get it? No problem. I will give you more example. Okay, so 255 plus this 0, you get 256 IP. Okay, one more example. 192.163.11.22/16. Now 16 means what? Anybody would like to answer? 16 means last two block will. So if last two blocks are changing, then we will get from 192.163.0.0 192.163.255.255. Now all the permutation and combination of this, that many IP address you will get, or somewhere around 65,000 IP address you will get. 65,000. Here you got 256 IP, and here you will get around 65,000 IP. Yes, 65,536. Here, anyone? Do you see any mathematical? Yes, octet, right? One more example. 192.163.11.22/8. Now, what does 8 represent? 8 represent change in last 3 block. So you get a range from 192.0.0.0 up to 192.255.255.255, and whatever the permutation combination, that many IP, right? So this is called as CIDR, classless interdomain routing. See, CIDR is a very big networking concept. Okay, it includes a lot of things. It includes a lot of things, but we don't need to understand all of that. We will understand only this concept. What is the concept? The concept is if you change the host ID, your network ID, your range of IP address will, okay, your IP address, the range of IP address, how many IP address you will get, that will, this, if you want to see, I will share something with you. I will share a online tool where you can verify all of this. Okay, let me. Okay, look at this. Let's take 32. Okay, 10.0.0.0/32. If I calculate this cider, how many hosts we are getting? We are getting only one host. 10.0.0.0 is our starting address, and 10.0.0.0 is our last IP. Because we have only service, Ankit. Instead of 32, if I go with 24, what will happen? Can I say last block will change if I go with 24? Do you see last block is changing? So how many IP we got? We got 256 IP. If I go with 16, what will your last two block will change, guys? See, and we are getting 65,536 IP. Okay, here if I put 8, last 3 block will change, and this many IP. But does it mean only this number will work? 8, 16, 24, 32. Does it mean only this? No. Other number will also work. It's just that this number represent complete change. 24 represent complete change of last block. 16 represent complete change of last 2 block. But what if I when I provide 24, you see last block is changing. When I provide 23, you will see the second last block will begin to change. Look at this one. When I provide 23, the second last block begin to change. When I provide 22, you will see it will change even more. See, now it changed to 3. And you see our number of hosts are also increasing. If I provide 21, you will see it will change even more. It changed to 7. If I provide 20, it will change even more. There is no how here. That's how it works. That's how it works. This is the concept of cider. That when you manipulate, when you change the host ID, your network ID will change. Your number of IP address you are getting will change. How your number IP address changing? Because these blocks are changing. Okay, as you can see, as I'm lowering the number, the second block is changing more and more. Earlier, now it was 15. Now it is 31. If I make it, let's say 18, now it is from 31, it changed to 63. If I make it 17, it changes to 127. And when I make it 16, it will change completely to 250. All right. So today we will see all of this component in detail. Okay. We will see all of them one by one in detail. And we will also do their practice VPC. Okay. So what I will do, I will go to VPC. I think in last session, we created VPC demo, right? Demo VPC, we look at this. Here, what I will do now, you see, we have this default. In our last session, I showed you, and I hope you also verified it from your side. When you create a AWS account, you get this default VPC name. Tried this, right? And all this default VPC have the same CIDR range. Okay. In every region, you get a default VPC. Every region. Now, what I will do, I will create a new VPC. Okay. Here I will give a name demo VPC. Okay. Here I will select the CIDR. Now you know what is CIDR that. Why VPC is asking? CIDR is IP range. Okay. So if I'm creating a VPC, I need to assign a range of IP address to the VPC to create IP. Very good, Nafisa. Because in this VPC, when we create EC2, when we create database, from where do you think their IP address will come from? Okay, all the resources that we create inside this VPC, where do you think those resources are getting their IP address from? They will get their IP address from this CIDR that we provide. So here if I provide 10.0.0.0/16, then your servers, your resources will get their IP address. Okay, all the resources will get their CIDR. Sorry, all the resources will get their IP address from this CIDR. Right? Then here you can see we can provide CIDR for IPv6 as well, but we will not provide that. We'll keep it to IPv4. Okay. Then you see tenancy. Now, what is tenancy? In tenancy, you see there are two options. And by the way, in IPv6, we don't need to define anything. You can just simply select Amazon provided IPv6 CIDR block. So you will get IPv6 CIDR block from AWS side itself. Okay. But right now, we will not define it. Now, here you see what is tenancy. There are two options in tenancy. Okay. There is a default option and there is a dedicated option. What is the meaning of this? See, you guys remember the reason why cloud is cheaper than having our own local data center? What is the reason for that? Correct, very good. So what happens when multiple different people working in different accounts are using AWS cloud? What happens is, let's say all of them created the server in the same region, in the same AZ. There's a very high chance that all of their virtual server is created from the same, right? Why? Because cloud, you might get your own individual server. It might feel like you got a new server, which is not shared at all. But behind the scene, cloud, the hardware that it is using is being shared across multiple accounts. So when you go with default tenancy, you get that shared resource. You get that shared hardware. But if you go with dedicated tenancy, now you will get dedicated hardware. Okay, dedicated hardware means what? Whatever resource you create in this VPC, that will be created on a dedicated hardware. It means that underlying hardware will not be shared with any other people, any other person. Right? So when you go with tenancy, you get the option of shared hardware. And when you go with dedicated, your hardware, you will get a dedicated hardware. Obviously, if you go with dedicated hardware approach, you will have better security, you will have better performance, but also it will increase cost. Right? Having dedicated hardware is much more costlier than working on shared. Right? So this is how you create. Today we are able to create VPC in 5 minutes. Okay, provide the name, provide the CIDR. Mostly everyone go with default tenancy, and when you go with default tenancy, you also have an option of getting dedicated hardware. But if you go with dedicated tenancy, you have only dedicated hardware option. So mostly people go with default tenancy. Okay, no need to change here. Here just provide CIDR and provide name. Understand how simple it is to create a VPC. But you need to understand, pay attention. Here I'll click on create button and our VPC is created. As simple. Okay, our VPC is created. Now what? What is the next thing to do? After VPC, what is there? What after VPC comes subnet. Okay, so here if I go to your VPCs, here I have two VPC. First is default VPC of this region of this account, and second is my demo VPC. Okay, now in this VPC, I want to create subnet. Okay, how pay attention? Okay, I will give you. Okay, now see, before I create subnet, I will tell you a simple concept. Okay, subnet is a subset of VPC, correct? Subnet is a part of VPC. So let's say VPC CIDR, okay, is let's say 1 to 1000. Okay, I'm taking simple number. I'm not taking actual IP address. I'm taking simple number. Let's say VPC CIDR is 1 to 1000. Right? So can I say subnet CIDR will be between this range only? Let's say 1 to 200. Subnet 2 will be from 200 to let's say 400. Subnet 3 will be from sorry, this should be 201. 401 to let's say 600. Like this, right? Can I say subnet CIDR will never go beyond the CIDR of Okay, so always remember this is the rule. Okay, and here also some calculation will be done, some formula will be there that we don't need to know. Okay, I will show you online tool on of how to do it, right? But here understand one thing, that uh, if we are creating subnet, which is a subset of VPC, right? So naturally the cider of subnet will not go beyond cider of VPC. Okay, so let me show you guys. Here I'll come to VPC. Now here in VPC I will go to subnets. In subnet, now you see there are total, already there are 6 subnet. Why? Let me go to other region. Let me go to Ohio, North California and Oregon. If I go to Ohio region, here you will see, now here you see, here we have 3 subnet. Okay, in North Virginia we had 6 subnet, here we have 3 subnet. Here if I go to North California, here we have 2 subnet. Okay, and here we have 4 subnet. Okay, now these are the default subnet. Why this? Yeah, I will tell you. So default subnet depends on default number of availability zone. Okay, default subnets depends on default number of availability zone. Okay, in Oregon by default there are 4 AZ, so there are default 4 subnet. In North California there are 2 AZ, so there are default 2 subnet. In Ohio there are 3 AZ, so by default 3 subnet. And in North Virginia there are 6 AZ, so there are 6 subnet. Okay, so this depend on number of AZ. But are we restricted by this? Does it mean in my demo VPC I can create maximum 6 subnet? The answer is no. It's just that AWS follow this rule. I mean, they follow this as a kind of a way to create number of subnet. So AWS follows that. We don't need to follow it. Okay, you can create up to 200 subnet, or you can create only one subnet, your choice, based on your requirement. There is no rule that we have to follow this. If you delete default subnet, they will be deleted. But don't do it, okay? Because in our course, you will do most of your practice in default VPC. So if you make changes there, you will get error in your other demo. Right? So here you see there are 6 subnet because there are 6 AZ, but we don't need to follow this rule at all. Okay, we can create subnet according to our requirement. So here I'll click you guys some question. Okay, so you see while creating subnet, it is asking me to select VPC. Now, does it mean if I select default VPC, I can create more subnet? So see one thing, look at here. If I select default VPC, it is giving me option to add more subnet. Now you agree that we are not restricted by. It is just that AWS followed that number, but if we want, we can add more subnet. It is in front of you. Okay, but I will not add this in default. I will add it in. Okay, here I select my demo VPC. Now here in the subnet name, I will select, let's say, we will create first of all public subnet. Okay, we will create public subnet, and here we need to select AZ. Okay, so remember last time I told you, just like within region we have AZ, within VPC we have subnet. So subnet and AZ are at the same level. So when you create subnet, you need to define to which availability zone this subnet will be aligned to. So let's say I'm selecting AZ1A. See here I can see 6 AZ. Now in the name also I will add AZ1A. Okay, just for easy identification. So here I'm creating public subnet. Here I selected AZ1A. Okay, this is the cider of my VPC. Now I need to provide cider of my with answer. Now here what happens if, okay, now there are many tools like this. What you see on your screen is one of the tool. There are many calculator, many tool like this. Okay, now I will show you in this tool how to calculate the cider of your. Okay, now first of all what you have to do, here you see network address block. Here you need to provide your side. Okay, here you provide cider of your VPC, right here. Now what I'll do here, I'll provide 10.0.0.0 slash I will provide 16. This is the cider of my VPC. Okay, and here I will provide number of subnet. See here by default one is selected. So from this one cider I'm getting only one subnet. So can I say one subnet will have the same number of, that is 65,536 IP address? Anything divided by 1 will be the right. But what if I want 2 subnet? Can I say that number will be divided by 2? Now how many IP we are getting in each subnet? 32,000. If I divide that by 4, if I want 4 subnet, now you see in each subnet I'm getting 16,000. Okay, do you see? I just need to provide how many subnet I want, and I'm getting all of their IP address calculated. Do not worry about this. I will show you how to use this. But do you understand that here I provide cider of VPC and here I provide number of subnet? All the calculation will be done automatically. How to use this calculation till this point? And how many IP I'm getting in each subnet? 4096. Okay, so automatically everything is getting. Now here you see this subnets that you get. Why I'm telling you that we use this online tool and we should not do manual calculation here? Because here you will get perfect value. For example, this subnet is starting at 10.0.0.0 and it is finishing at 10.0.15.255. Now second subnet is starting at 10.0.16. Is there any overlapping? No. Now second subnet is finishing at 31.255. The third one is starting at 32. The third one is finishing at 47.255. The fourth one is starting at 48. Do you see any overlap here? No. Just like your VPC, your subnet also should not overlap. Okay, when you create subnet, your subnet should not overlap with each other. Their CIDR should not overlap with each other, not at all. Now, how to use this? So here when we create subnet, it is asking CIDR for subnet. So from where I will bring this which mistake gets to overlapping? Manual calculation. Nafisa. That's why I use this online tool. Okay, now here you see, we will take any of the subnet address. Okay, pay attention everyone. I'll show you multiple example. Everybody pay attention. I will copy this one. Okay, I'll copy this header. Okay, and I will paste. Now what is remaining? Host ID. Okay, how to provide host ID? Host ID we will provide from here. Look at this. As you change your number of subnet, your host ID will update. Look at this. Okay, so for 16, what is the host ID? 20/20. So I will provide here /20. Okay, so this is how you create subnet. Okay, and I will click on create subnet. Range. Okay, now see how to create subnet. Select the VPC for which you want to create subnet. Okay, now this time I will create private subnet, so I will provide the name private subnet. Again, I will create subnet in the same AZ. Now, if we have 6 AZ, I told you it doesn't mean that we need to create. Okay, doesn't mean we need to go with 6 AZ or 6 right? So what you need to understand here is it not necessary that you will go with only one subnet per AZ. If you want, you can go with multiple subnet. So again, I will select AZ1A here. So I already created public subnet. Now I will create private subnet in the same AZ. Now how to provide CIDR here? Very simple. Use online tool like this. Okay, what we do here? Here we provide the CIDR of our VPC. So my VPC CIDR is this. Then here I provide how many subnet I want. Okay, so we decided, let's say we want 16 subnet. Now I can take subnet a network ID from here. Okay, we can take network ID from here. Okay, so earlier I took this network ID. Now I will take this network ID. right? I provided network ID. Now host ID I need to provide. How we will provide host ID? We will provide host ID from here. Okay, here is the /20. Why I'm taking this one? Earlier I told you, because this is the CIDR of your subnet. This is the host ID of your subnet. Okay, as you change your number of subnet, this will also change. So that's why I selected this one, /20. Why I will take /16? Don't you think this belongs to my VPC? Will you provide VPC host ID in subnet? No, right? Your subnet host ID will be different. You take it from here. Example. Okay, so here you see, what does it represent? CIDR notation, here it represent basically your host ID. Which host ID will belong for this particular subnet? So for this subnet, I am selecting /20. That is fine. Are you understanding? Last time I will show you again. I will create how to create subnet. How to create subnet? Click on create subnet and here select your VPC for which you are creating subnet. Now here provide the name of your subnet. Let's say again this time I will create public subnet, but this time I will create subnet in another AZ1B. So here in the name also I will add 1B. Now how to provide CIDR for subnet? Use online tool like this. Okay, how to use such tool? Here provide CIDR of your VPC. My VPC CIDR is this. Then select how many submitting it every day. I hope it is clear for everyone. Now I selected how many subnet I want. Now I will take I will take network ID from here. Do I need to go sequentially? Is there any rule like that? No. I can randomly take any one of them. Just make sure you do not repeat the same, because CIDR should not repeat. So I will take this one. Now how to provide host ID? You tell me. How to provide host ID? Host ID you will provide from the CIDR notation here, because this host ID will change based on your number of subnet. Okay, so host ID I will provide from here. Okay, now in the same page I can add one more subnet. Okay, so this time private subnet. Private subnet. Now tell me, here I created public subnet in AZ1B. Is it mandatory that private subnet will also? Can I select some other AZ, let's say AZ1C? Yes, no such rule. Your choice. Okay, now here I'll provide CIDR network ID from here. Let me take this one. Okay, and host ID I will take here now. And by the way, here you see, here it is shown. You are getting 4096 IP. So this is how we. Very good. Now I will ask you guys. There is something wrong here in the CIDR Akpal. Guys, when I created this subnet, do you saw there was any option of selecting public or private, Ravi? Guys, was there any option of selecting public or private? Don't you think I just provided? Don't you think I just provided name public? If I just provide name public, will it make it public subnet? What if I provide semi-public? Now what is the meaning of that? Right? I just provided the name public or private. Just by providing name public or private, it doesn't make it public or private subnet. So what is this? What are the subnet? Are they public or private? All these 4 subnet that we created, all 4 of them are by default private subnet. Okay, it is our responsibility to convert them into a public subnet. When you create a subnet, see the subnet given by AWS will already convert it into public subnet. Okay, but the subnet that you create, they will be by default private. So it will be your job to convert them into a public. Okay, it will be your job to convert them into public subnet. So all 4 subnets are private subnet. Now how to convert them? Very simple. Okay, how to convert private subnet into public? Very simple. I will select the subnet. Okay, NAT gateway also know. NAT gateway is there to give internet for private server. NAT gateway is there to give internet for private server, not for converting public private subnet into public subnet. Okay, see, I'll show you. Select the subnet. Here I'll click on action. Here you see subnet setting. Now when you go to subnet setting, here there is an option called as auto assign IP setting. This one option we need to select. Okay, this one option we need to select. Okay, enable auto assign public IPv4 address. When we select this one option, our subnet will become a public subnet. Now, how to see that? I will give you proof. Okay, don't worry. I will give you technical proof for it. But by selecting this one option, our subnet will become a public subnet. How to convert? Here I'll select the public subnet, click on action. I will go to subnet setting, right? And here I will select enable auto assign public IPv4 address, right? And here will okay. But now how to see the how to verify this? How to verify this? Oh, I told you that we got public and private subnet, but what is the proof? Okay, I will show you. When we create subnet and when AWS creates subnet, we create subnet when we create VPC. Okay, I will give you proof. I will go to EC2. I will launch the EC2. First of all, I will launch a public server. And here I will go with default values. Proceed without key pair. Now, do you remember when I covered EC2, I skipped all of this, right? Now, what I'll do, I will edit this. Here I'll select demo VPC. Okay. Now, here I'll select public. Now, you see, this part is simple, right? Now, I am creating EC2. I just need to select in which VPC I want EC2, in which subnet I want EC2. If you remember, when I was covering EC2, I told you I'm this part today, and we will cover this after VPC. So I want to create public server, so I will select public subnet. As simple as that. Go with all the default value and click on create server launch instance. Okay. Now I will launch one more instance, and this will be private server. Okay, and here proceed without key pair, and we will edit this. Again, we will select demo VPC, and this time we will select private subnet. Okay, this one, and go with all the default value, and we will launch instance. Now here I will tell you a you get public subnet. Okay, if you create a server inside public subnet, you get public server. Okay, and same goes for if you create a server in private subnet, you get a private server. Right? Now, what is public server? Public server is the one that have both public and private IP address. Okay, and what is a private server? Private server is the one that have only private IP address. Okay, this is the difference. What is the difference between public server and private server? Public server have both public and private IP. Private server have only. Okay, see, I'll show you the proof now. Yeah, I'll show you the proof. So here I'll select public server, and do you see it have both public IP address as well as private IP address, right? This is the proof that this is a public server. And if it is a public server, it means we successfully converted private subnet into public. Okay. Now here you see private server. Do you see private server does not have public IP? It has only private one. This is the proof. This is the proof that our subnet got successfully converted. Now one more point I will tell you, and this is important from internet. For this, I will show you the official document. Now, we saw that when we created the subnet, how many IP we got in that subnet? 4009. We got 4096 IP. Do we get all of those IP? The answer is no. Okay, so whatever big or small subnet you create, you will always get 5 IP less, right? You will always get 5 IP less, right? So first IP will be and these are the 5 IP which are reserved for AWS. So you will get 4091 IP, not 96. Okay, so what happens? First IP, okay, one like let's say your CIDR is 10.0.0.0/24. Let's say this is the CIDR of your subnet. Now in this CIDR, the first IP 10.0.0.0 is reserved as a network address. Second IP 10.0.0.1 is reserved as a VPC router. Okay. Third IP 10.0.0.2 is reserved by VPC for DNS server. Fourth IP 10.0.0.3 is reserved for future use. And after that, directly the last IP 10.0.0.255. This is the broadcast address. So first 4 and last one. First 4 and last one. So total 5 IP address are reserved for AWS. Very good. Okay, so always remember, whenever you create subnet, you get 5 IP lists. First 4 and last one. And just understand, just memorize one word for them. Last one is broadcast address. First one is network address. Second one is for VPC router. Third is for DNS server. And the fourth one is for future use. Okay, in fact, let me just put it here in the notes. Okay, so let's say subnet CIDR of 10.0.0.0/24. Okay, if you go with this, yes, 5 address in every subnet. First one, first IP, right? That is the network address. Then second IP, then third IP, then fourth IP, and then last IP. First 4 and last one, right? First one is network address. Second one is reserved for VPC router. Third one is reserved for DNS server. Okay. Fourth one is reserved for future use. And the fifth one, last one, is the broadcast address. Okay, just remember this much. Okay, so let me come back here. Let me show you a few more things. So here is my server created. Okay, now Pay attention, okay? I will try to connect with private server, okay? And I will use EC2 instance connect method. So here I'll click on connect button. And here you see instance is not public subnet. So we can't connect. Yes, 5 IP for each resource. Rohit, within one subnet, you can have hundreds of resources, right? Then how you will create subnet for each and every resource? Remember the hierarchy. First we create VPC, then we create subnet, then inside subnet we create server. Then how you will create new subnet for each server, right? Remember the hierarchy. Okay, so you guys see here we are not able to connect with. Okay, I'll click on private subnet. I'll click on connect button, and here you see no public IPv4 assigned. Instance is not in public subnet. So we can't use EC2 instance connect method here. Okay, so first of all, your EC2 instance connect method does not support private server. Okay, this method does not support private server. It works only with public server. So if I go to instance here, I'll select public server. Okay, now I'll connect with public server. Here I'll click on connect button, and here we can connect with it. Oh wait, public server, click on connect button. Okay, here I'll click on connect button. So with public server we can connect. And there you go, we got it. And tell me, what do you think could be the guys? Tell me a simple first time. I told you what is this EC2 instance? This method open your EC2 right within your browser. Can I say if it is opening the EC2 right inside our browser, it require internet, and that is the issue. That is the real issue. Okay, SSH is already there, but internet is not there. Now you'll say, Pratik, then how did it work in our demo or when we created EC2? Yes, because we ran it in default VPC, and in default VPC, default internet gateway. All right. Now let me show you the how to solve this problem. Okay, so to solve this problem, what do we need? We need in. Okay, so what I'll do, I will go back to my VPC. Okay, I will go back to my VPC, and here I will go to internet gateway. Okay, I will go to internet gateway. We didn't create any public private VPC here because remember when I showed you that overview, did I say that there are public? Previously we had different. Okay, now we have our demo VPC. Public or private concept is there for subnet, not for VPC. Okay, now see, here you see by default internet gateway is there. This is that default internet gateway because of which we did not get error, right? This default internet gateway will take care of internet VPC. But when you create VPC, now you need to define your own internet gateway. Okay, so here I'll click on create internet gateway, and it's very simple. All you have to do is to provide the name. Let's say my IGW, and you can click on create internet gateway. That's how simple it is. Click on create internet gateway and we are done. Our internet gateway is created. But are we done with it? No. Okay. Once your internet gateway is created, that's the first step. Second step is to attach it to VPC. First step is to create internet gateway. Second step is to attach it to the VPC. So I will select this. I will click on action and I will click on attach to VPC. And here is the demo VPC. Now here I will point out one interesting thing. You remember when I was creating subnet, at that time there was it was showing me both the VPC, but while attaching internet gateway, it is showing me only demo VPC. Very good. Because your default VPC already have an internet gateway. Now I'll say, Pratik, default VPC also has one VPC can have multiple subnet. Okay, one VPC can have multiple subnet, but one VPC can have only one. Okay, one VPC can have only one internet gateway, or one internet gateway can be attached to only one VPC. Between internet gateway and VPC, there is only one. Between VPC and internet gateway, there can be only one to one. Clear. So here I'll select my VPC, and now now that we attach internet gateway to our VPC, will we get access? Refresh. No. Why no? What is remaining? Table. Root table is remaining. Gateway. Okay, so we did those two things. Now one more thing is remaining, that is to add a root in root table. Okay, in our root table we need to add a root. Okay, how to do that? Very simple. Go to root table. Okay, now when I go to root table, here you see I can see two root table already. Okay, I can see two root table. One root table, as you can see, is for our default demo C, the first one. But you see, for demo VPC also there is a root table. This is something new, right? Up until now, what we have seen? Up until now, we have seen that when we create VPC, we need to create subnet, we need to create internet gateway. But you see, for the very first time, we got something on its own. Okay, we got root. Okay, very good. Now, why we got this separately? We also need to understand the reason why we got it. Because here you see, I will go to root tab, and here you see there is a root. Okay, by default there, yeah, we'll do that. But here you see a default root is already there, and this is the reason why we got root table. Now continuing, here I will add a root. Okay, now we need to add our own root. What root we will add? We will add the root that if you want internet, and internet is represented by 0.0.0.0/0. This represent internet. Okay, if you want internet, then go for internet gateway. Right? If you want internet, then go for internet gateway. Don't you think this is exactly target destination? I messed up. Destination here, target here. But don't you think this is exactly what I mentioned here? If you want internet, go for internet gateway. Obviously, here we can't type internet. So here internet is represented by this 0.0.0.0/0. And here we select internet gateway. Okay, so click on save changes. Do you think answer? I will click on save changes. Now if I go to that EC2 again, let me try to connect with this again. Click on connect button. Okay, so I'm connecting with public server using EC2 instance connect. And pay attention now. This time it will work. Why? Because we fixed the problem of internet gateway. Okay, as you can see, it is working. We fixed the problem of internet gateway. How we fixed it? Very simple. 3 steps. Create internet gateway. And internet gateway, you guys saw, we just provided the name and we got it. Okay, we provided the name and we got our internet gateway. We didn't have to do much. Why? Because you can imagine internet gateway is a ready-made software made by AWS. all you have to do is to just create it. That's it. Okay, so we created internet gateway, then we attached it to our demo VPC. Okay, and here we learned one thing, that one VPC, between VPC and internet gateway, there is one-to-one mapping. Okay, and the third point, that was the second point. The third, we added route in route table. What route we added? If you want internet, go for internet gateway. Moving on. Now we got internet access here. Okay, so we are able to access this server. Okay, here we will understand one more concept now. Okay, so everyone please understand this, very important. Here I will give you a real world example. Take an example of a let's say bank. Yeah, all of this is available in free tier. Take an example of a bank. Okay, let's say you are working on a banking application like, let's say, HDFC. Okay, now you have a website. Okay, everyone at your website have a front end where people log in. Okay, they will access the website. Now, whenever, so everybody can view the website. Okay, any person in the world can view the website, but only a valid user can log in. Right? Now, when a valid user log in, okay, when that valid user log in, that user want to check, right? So where that balance will come from, where that information will come from, DB. So do you think your web app server or your database, both of them you can host on same server, or both of them you can host? Can I say the web app server, okay, which is used by public internet, will be hosted on public internet, and the database which is private should be hosted in. Okay, see, I'll draw that. So this is my database server. And here is my web app server. Okay, this is my database server, this is my web app server. Web app server will host the front end of my website, so you guys agree that this should be publicly accessible. Database, no matter what, it should not be publicly, right? So database server will be hosted in private subnet. Database server will be hosted in private subnet. Okay, similarly, web app server will be hosted in public subnet. Web app server will be hosted in public subnet. Okay, and this itself will make sure here this is a private server and this is a public. Just saw that, can we access private server publicly? The answer is no. Why? Because it doesn't have public IP address. So can I say in that way our database will be more secure? Do you agree? Now here a person will, my next point. Now when a user request comes for your web app server, okay, any person can view your website, or let's view your website, okay, and that person will then log in. Okay, now when that person log into your website, and let's say on the website that person see a button called as check my balance. When that person click on that button, check my balance, what happens? A request from web app server goes to, a request from web app server goes, right, and database server will reply balance of that customer, right? But how to allow this? how to make sure that anyone can access our web app server, and requests from web app server will be accepted in database server. How do you database server should get requests only from web app server? See, I'll remember, when you create server, every server has security group is what? Okay, so there will be a security group here at the server level. Okay, this is the security group, right? And we know in security group by default it blocks. So what I'm telling you, I will show you how to do this practically. But the theory approach that I'm trying to tell you is that this security group of web app server, it will allow SSH request from anywhere. Okay, let's take an example of SSH request. This security group server will allow this security group will allow traffic. Okay, we will keep it open. But this security group will allow traffic only from web. This is the theoric solution. Do you think this will achieve our right? Very good. This will achieve our target. Now, before I show you the practical, we need to discuss a little bit more about this concept. Okay, this is the concept of security group and NACL. Okay, now what is this? See, this is a subnet. Okay, in this subnet we get a server. Okay, in this subnet we get our EC2. Okay, that is server. Right, now we know around EC2 there is a firewall. Okay, around our server there is a firewall, and at the subnet level there is also a firewall. Okay, understand this. Up until now what we saw, that there is a firewall around EC2 and that firewall is security group. Today I am telling you something new. Today I am telling you that there is a firewall at the subnet level as well. Okay, so this firewall, okay, this firewall at the EC2 level or server level is called as security group, and this firewall at the subnet level, this is called as NACL. What is NACL? NACL means not salt. NACL means network access control list. NACL means network access, right? Now, when a request comes for your EC2, whenever a new request is coming for your EC2, okay, the request always comes to your NACL first. It goes through NACL, right? From NACL, the request goes to your security group. Okay, obviously, evaluation happens here. If your request pass this evaluation, then only it is moved forward and it will go to security group, right? And obviously security group is also firewall. It will also do the evaluation here. Okay, if it pass the evaluation, then only your request will go to the actual EC2. then only the request will go to actual. Is this flow clear? This is called as inbound request, incoming request. I hope it's not very complex. It's simple enough. Right? Now, similarly, just like there is a request coming to our EC2, there can be a request that is going from EC2, right? There can be a request that is going from EC2. Now, here there is no evaluation that will happen. And I will give you a reason for it later. Okay, but this request goes to NACL. And here a evaluation will happen. Okay, here a evaluation will happen. And then only request will go out. Right? And this is called as your outbound request. Simple enough. So here now you need to understand few things. In security group, okay, in security group, we can only allow rules. Outbound request. Because EC2 is requesting outside scenario. Okay, so in security group, we saw that whatever rule we add, that rule is allowed. Okay, and whatever that is not added in security group is by okay, whatever rule we add, that is allowed, and whatever we do not add, that is not allowed. That is by default. Okay, in NACL, there is much more flexibility. Here we can explicitly allow as well as deny the rule. Okay, for example, if I show you practically, if I go to security group, here edit inbound rule, here you see SSH is there. It means only SSH is allowed. All the other rules are denied. Okay, there is no explicit deny here. But if I show you NACL, network access control list, in NACL you will see here we can add a rule. Let's say I can add a rule SSH. I can allow this rule, and I can again add SSH, and I can deny this rule. So here you see you can explicitly allow as well as. Okay. Now here comes a question. See, if my security group is the inner firewall, okay, and my request will anyway get rejected. Okay, if my request will anyway get rejected here, then why there is a need of explicit deny? See, my question is, you guys saw in NACL there is a explicit deny. We can deny deny some rule, right? Now, if security group by default blocks whatever that is not allowed, then why there is an explicit need of deny? Do you think this is a valid? Okay, see, let's say here I select all TCP deny, right? Now here I selected all TCP deny. But in my security group, you remember I did not define all TCP. And if I did not define all TCP in security group, can I say it is just by not adding this in security group? Can I say it is by default? Yes. Then what is the use of explicit deny here? Okay, see, I'll give you the answer. See, now I will give you the answer, and this can be asked in interview. Okay, why there is a need of explicit deny? To understand its need, we will assume explicit deny does not exist. Okay, yes, we will assume why it does not. We will assume it does not. Okay, so to understand its need, we will assume that NaCl does not exist. We will assume we have only security group. Now let's say in our security group we created a web app, and in that security group we allowed requests from 1 to 1000. Okay, we allowed all the requests 1 to 1000, right? But later on we found out that there is a IP address 111 that is trying to launch attack on our web app. Now how we will block this? How we will pull thing here? What I told you, whatever we allowed in security group, that is allowed. Whatever we don't allow, that is by default deny. So can I say in security group I will allow 1 to 110, then I will allow from 112 to 1000. Can I say in this process triple one will automatically get denied such answer? Okay, now tomorrow I found out that there is one more IP that is trying to launch attack. Now what we will do? We will again update the security group. We will allow from 1 to 110, then we will allow from 112 to 221, then we will allow from 223 to 1000. This is what we will do. Can I say in this way triple one and triple two will be blocked? Whatever that you do not allow, that is blocked by default. Now, don't you think this is a very hectic process? Every time you'll have to update your security group. It's very complicated. Now you understand why there is a need of explicit deny. Because when we have NaCl and explicit deny, in security group, we will allow everything. We will allow from 1 to 1000. And in NaCl, I will deny my IP. Okay, and if I deny them at NaCl, they will never reach at security group. Okay, this is what I meant here. That security group can only allow the rule, but NaCl can allow as well as deny the rule. Point. Now you remember this I told you, for outbound request, security group will not do any evaluation, but NaCl will do the evaluation. Okay, so here also I will give you simple example. First of all, one simple example I will give you for NaCl and security group. All of you guys, some of you people might be living in a society. Some of you people might be living at your own home. Okay, let's take a society example. Okay, I live in a society. So this EC2 is my flat. Now tell me, if anybody wants to enter inside my flat, can I say they have to pass through two gates? Can I say this subnet is my society and there is a society gate? Somebody first have to enter inside society. Once they enter inside society, then they have to enter through my front tarang. Okay, so this subnet is like your society. NaCl, which is a subnet firewall, is like a society gate. Okay, when anybody enters here, they have to pass through another gate, that is EC2 security group or my flat front door, and then they can enter inside. Right? So here, why there is no evaluation during the exit? Why there was no evaluation here? See. Now let's say there is a premise. Okay, there is a premise, and in this premise there is a security guard. Okay, in this premise there is a security guard. Now what happens? Whenever anyone is trying to enter in this premise, this security guard will ask for your ID. Okay, basically he will do your evaluation. Okay, he will do your evaluation. He will ask for your ID, and once your ID is validated, you have a valid ID, you will be allowed to enter. Okay, you will be allowed to enter. But when you exit, okay, when you exit, at that time also, will it ask for evaluation? Do you think it should ask for your ID again when you exit? It already checked you when you enter. It should not check you again, right? Why? Because this security guard, let's say, remembers you. He remembers that I already scanned this person. Okay, so I don't need to scan him again and again. Can I say this security guard is like security group that is checking only when the person enters, but when person exits, it is. Do you think it is like that? Yes, it is like that. Okay, here the reason is this security guard remembers you that already scanned this person. What is the reason here? Here the reason is security group is a stateful firewall. It maintains the state. That's why it doesn't need to scan again and again and again. But let's say there is another security guard who checks when you enter, but he again evaluates you when you exit. Okay, this another security guard will check you when you exit as well. Can I say NACL is like that security guard? It checks you when you enter, it checks you when you to check again. Because security group maintain the state. That's why it is called as stateful firewall. Okay. NACL does not maintain any state. Why? Because it is stateless firewall. Got it, guys? This is stateful firewall, this is stateless firewall. Stateless firewall doesn't maintain the state, that's why it needs to scan again and again. Stateful firewall maintain the state, that's why it needs to scan answer today. So understand the agenda first. What is our today? Our today's agenda is to first of all create a web app server and create a data. Right? We are assuming we are creating it for a web app. Now, what is web app server? Web app server is something where anyone from outside, I mean anyone on public internet can, okay, anyone on public internet can look at that web page. But obviously the person who have their account only, they can access it, they can log in. All right. Now when this person log in, okay, and he want to check the balance, his balance, okay, where that balance will come from, okay, the balance will come from, right? But of course we don't want to give it to anybody, right? Database should allow access only from web app server. Database should not allow access from anywhere else. Remember this part. Database is the most critical as well as the most uh, confidential component in any web app. Okay, we should not allow access to database from anywhere else. So database should allow access only from web app server. Now, okay, so we are going to set up two security group. We are going to create two security group. One security group for public server, one security group for data. Okay, one. So let's first of all do this. I will go. Let me go back here. Okay, now here I will go to VPC. Okay, here I will go to security group. Okay, and here we are going to create a security group. Okay, so the very first security group we are going to create web app security group. Okay, and what this security group will do? This will allow, and since we don't have a real world web app, obviously, we are going to use SSH. Okay, we are going to use SSH. Okay, of course, we don't have web app. So otherwise, if we had web app, we would have used HTTP. But right now, we will use SSH because that will not affect the concept that we want. Right? So here I will allow this. This will allow SSH. Yes. Okay, so we will allow SSH traffic from anywhere. That is internet on public. Right? Now what? What is next? Here we will add inbound rule. Here I will, oh, 1 minute, let me select demo VPC. Okay, so when we create security group, we need to select the appropriate VPC. Okay, we need to select the correct VPC. So here I will select SSH from anywhere, right? So this will immediately in chat. Okay, here I will add the name, and in the name here I will add web app security group. What we done here? Everybody clear with web app security group? Very good. So here I'll create this security group. Okay, similarly, we will create one more security group. Okay, this time it will be a DB security group, database security group. So DB-SG, right? This will do what? This will allow SSH only from where? SSH only from web app server. Web app server. Okay, here I will select demo VPC. Here I will add rule for you guys. Okay, we can also allow security group. So if I select web app server security group, then requests will be allowed only from web app server security group. Basically, the server inside this security group. Security group. Okay, so here we are done with both of our security group. Our web app server security group is ready. Our database security group is ready. Now the next thing is, we need to create the actual server. Okay, so for that we will go to EC2. Obviously, we will go to EC2. Delete this yesterday's 2 server. We don't need them. I will launch new servers. Okay, here I will launch, provide the name. Let's say, first of all, we will create web app server. Okay, and here we will select proceed without key, or let's create key pair today. Okay, let's do one thing. Today I will show you something little bit complex stuff. Okay, something new. So we'll create a new key pair. Here I will give a name EC2 KP 22 June. Okay, we'll create this key pair. Okay, so here I selected key pair. Key pair is downloaded in my laptop, and I will edit this setting. What I'll do here, this you guys know already. We covered this yesterday. Here I'll select my demo VPC, and here I'm creating web app server, so I'll go with public server. Okay, I will go with public subnet. Okay, and here I will select my security group. Which one? I will select web app security group. Okay, this will allow SSH from anywhere, and we will launch our server. Okay, our web app server is launching. Now we will create one more server that will be for our database server. So here I will give a name db-server. Okay, and here I will give a name proceed. We'll select our today's key pair. Okay, look at this. I'm selecting the same key pair. I can select different key pair also, but I'm selecting the same one. Okay, here I'll edit this. Again, I'll select demo VPC. This time we are creating a database server, which should be a private server. So I will select here private subnet. Okay, and in the security group, I will select DB security group. As simple as that. Okay, so we selected our security group and we will launch this server now. Okay, so here you see, here you will see our servers. Instance state is equal to running. So here you see both of our servers are ready. Now how to access them? How can I access my database server, the private server? Okay, since we are allowing request only from public server, so for that we first need to log inside our public server. Okay, and what I'll do now, I will not use EC2 instance connect method that we have already seen yesterday. I wanted to show you that error. So we got that error. We use internet gateway and we solve that problem. Right now, how to now I will show you some different way. Okay, I will show you the SSH command, right? That you also already know, but still. So let me go to my command prompt. Okay, so command prompt, right? I will go inside download folder. Okay, now here what I will do, here I will run okay, but what we need to do before running SSH command, we need to give permission to our file. So sudo chmod 400 ec2 kp 22 June. Okay, it will ask me my laptop password. Okay, now I will run my SSH command. Okay, how to run SSH command? Very simple. SSH -I, then provide your EC2 key pair. Okay, then provide your username. What is our username? Our username is ec2-user, then @ and then provide IP address of your server. So I want to log into public server, so I will provide its public IP. Okay, and if everything is set up correctly, it should work. Okay, let's see. Enter. Yes, I want to continue. And there you go. We logged inside our system. Okay, so here you see I'm in log inside my public server. Now, if everything is set up correctly, then from this public server, I should be able to log into. See what I'm trying to tell you. Here I'm inside public server. So from public server, I want to log into my private server. Okay, so here also I will run SSH command. But when I provide key pair here, do I have key pair? Guys, in this EC2, the answer is no. See, what I'm trying to tell you is, if in case if anybody did not understood, let me show you. I'll show you what key. Yes, key pair is. Look at this, everyone. This is my laptop. Okay, from my laptop, I'm trying to access the web app server. From my laptop, I'm trying to access web app server, and from web app server, I'm trying to access DB server. Okay, so for me to access web app server, key pair is there in my laptop, right? If key pair is there in my laptop, then only I can access web app server. But from web app server, if I'm trying to access database server, don't you think I need to have the same key pair? Everybody understood? So what we need to do, we need to simply upload the key pair from laptop to here. Okay, and how do we do that? Very simple. For that, we are going to use scp command. If you don't create key pair, then there is no issue. You can directly access the server. Right, so here what I will do, here I will use scp command. Now what is scp command? Scp command is very similar to your ssh command. What was the template of ssh command? It was this: ssh -I, then we provide what? We provide key pair, then we provide username, and then @ symbol, then IP address of the server that we are trying to access. Okay, this was SSH command. Now SCP command is almost similar. Okay, instead of SSH you will provide SCP. Okay, and what is SCP stand for? SCP is secure copy. Okay, SCP secure copy. What we are trying to copy here, Kumar, very good. We are trying to copy key pair, correct? Okay, so we need to provide key pair also. So here I will provide, sorry, in our case we are uploading a key pair. Basically we are uploading a file, so here we provide the file that we are uploading. Okay, obviously you need to provide what you're uploading. And second thing is where we want to upload this. There has to be some address. Okay, so here we will provide that location. Okay, here we will provide that location where we will upload the file. So you see, SSH command and SCP command are almost similar. In SSH, we have two extra things. First is the file that we want to upload. In our case, it is key pair. And then the location where we want to upload it. And instead of SSH, SCP. Okay, just like in SSH, we provide the IP of the server that we want to access. In SCP, we will provide the IP of the server where we database server. From my laptop, I want to upload file in web app server. So I will provide web app server IP. And what is the location I will provide? Look at this. Sorry. Here if I type pwd. So this is the home location /home/ec2 user. So here I will upload my file. So I will exit from my public server. Okay. I will exit from my public server. Just a second. Okay. Now here what I will do? Here I will run scp command. Scp means secure copy. So scp, then -i. Then what is the next thing we need to provide? We need to provide the file that we want to upload. EC2 KP 22 June. Okay. After this, what I need to provide? I need to provide. Why this is repeating here? Basically, this is the file that I want to upload. First time I'm providing the file that I want to upload. Second time I'm providing the key pair. Okay, I intentionally use the same name just to confuse you guys a little bit. The file that I want to upload is nothing but my key pair. That's why it is repeating. First time I'm providing the name of the file that I want to upload, which is my key pair. Second time I'm actually providing the key pair. Yes. Now, after this, what we need to provide? We need to provide EC2 username. Then we provide @. Then we provide the IP address. Let me copy the IP of web app server. And then we need to provide the location. What is the location? Location, I will provide this one. home/ec2 user. home/ec2 user. Okay, so here I want to upload the file. Right? So let's enter. As you can see, our file is 100% uploaded. Okay. So here you see it is 100% uploaded. Okay, let's verify. Let me SSH into that server again. And if I type ls here, I should see the file name. And there you go. Right, now we are done with all of our requirement. Now the only thing that is remaining, here I will run ssh command, ssh-i. Here I will run ssh command. Okay, I will provide the key pair, ec2 key pair. Then we'll provide the username, ec2-user @. And now we'll go to a private server. So private server does not have public IP. No problem. We'll provide. But how can key pair name and file name be? I will copy this private IP here. I will paste it here. Okay. Now everyone pay attention. If my security group is set up correctly, this should work. Okay, you guys know database server, we cannot connect with our database server. Look at this. Because anyway, it's a private server. Okay, but database server, we define in security group that it should allow access only from web app server. So if I enter this, it should work. And if it works, it means we done everything correctly. And there you go, we are inside database server. Okay, now moving on, here you will see if I ping google.com here. Okay, and yeah, before that, let me go to my EC2. Let me connect with my public server. Okay, I will connect with my public server. Okay, so here if I ping google.com, do you think it will work? Will it work here? Here it will not work. Why? Because internet is there for public server, not for. Okay, now pay attention. I will come back here. How to solve this problem? To solve this problem, now we require NAT gateway. Okay, now we need NAT gateway. What is NAT gateway? NAT gateway, remember that COVID brother example? NAT gateway is that brother that will bring pizza for you. Okay, so NAT gateway is that component in VPC that brings internet for private server. Okay, so here I will go to NAT gateway, right? And you see NAT gateway is not there. Not even a single NAT gateway is there. So here we can understand that NAT gateway is not there for our default VPC. The main reason is in the default VPC, all the subnet that we get are public subnet. So whatever server you create in default VPC is a public server, so no need of NAT gateway. But since we are creating our own VPC, our own subnet, our own server, we need to provide NAT gateway because we'll be creating private server. Right? So here I'll click on create NAT gateway. Now pay attention, the method is very simple. Okay, creating NAT gateway is also very simple, like internet gateway. Here I will provide the name my NAT gateway. Okay, this is the name I'm providing. In the subnet, I will select, let's say, public subnet. Okay, you can select other subnet also, but public subnet is recommended. Okay, here connectivity type, you can select any one of them, doesn't matter, but I'll go with public. Okay, the only extra thing that NAT gateway require, and this is very important, most important thing in NAT gateway, the only extra thing NAT gateway require is elastic IP. See, I'll show you a little demo. I will create a new server. Okay, here I'll provide name elastic IP demo, and we will create this server. Okay, I'll keep everything else to default and we'll create this server. Proceed without key pair, launch instance. Okay, now our server is created. Now, how many of you guys notice this? That every time you stop server, anybody notice any change that happen whenever you our public? Okay, and whenever we start our, okay, we will get our IP address, but not the same one. We'll get a, right, and now you see IP address is different. Earlier the IP address was different. Now it is different. Okay, this is what happens when you work with different. But do you think this is a bad thing? Do you think this is problematic? See, when we are working in real world scenario where we have auto scaling group and everything and load balancer, it doesn't matter. Okay, because we never really need to know the IP address of the. Okay, we don't need to know the IP address of, because load balancer is there. All the request goes to load balancer DNS. It doesn't need to go to the actual IP, right? So it doesn't matter if it is IP is changing. It's okay. Correct. But what if we are referring to this one server at a time only? In that case, what we will do is we will use elastic IP, because at that case we don't want it to change. If we are referring one server only, then we don't want it to change. So what is elastic IP address? Elastic IP address is basically the public IP address given by AWS. So here we can click on allocate elastic IP, and that's it. Here you can add a tag name elastic IP demo. Okay, that's it. You don't need to do anything. Just click on just click on allocate, and this you will get this elastic IP address from AWS. Okay, AWS will provide you this elastic. Okay, and once you get it, and remember this is a paid thing. Elastic IP is not free. This is okay. Once you get this elastic IP, okay, we will click on associate. Okay, we are going to associate it. We are going to use it. So I'll click on associate, and here I will select my server. I will select my EC. Okay, that's it. I'll click on associate, and we got this IP for our server. So if I go to my EC2, here you see earlier this IP was there. But if I refresh now, you can associate it with any EC2. I'm associating it with my demo EC2 just to show you. Now you see we got elastic IP. Okay. Now if I stop it, what will happen? Pay attention. We can create or not if it is paid. Your choice. If you want to create it, create it. If you don't want to create it, don't create it. Okay. Now you see when I stop the server, you see. Okay. Let it get about that. Now you see. Now that my EC2 is stopped, even then this IP address is there. This is elastic IP. Okay, this is elastic IP. What is elastic IP? Elastic IP basically means here you see our IP address is still there even after our server is stopped. Now if I try to start the server again, just pay attention. And there you go, it is EC2 is running. And you see our IP address is still there. So what is happening? Why IP address is not changing? Because when you stop the EC2, you never lose the IP address. And since that you are never losing the IP address, it is never since you are not losing the okay, you are not losing the IP address. It is also not, you can say, it is also not getting removed. It is okay. So here you see, this is okay. So what I will do now, I will delete this server because my elastic IP is attached to my EC2. Okay, and as long as your elastic IP is attached to one resource, it cannot be attached. It cannot be used by other resource. So before my NAT gateway use this elastic IP, I need to remove it from the. Okay, so you see our EC2 is terminated. Now it can be attached to our NAT gateway. So again, I will go to my NAT gateway. Here I will give a name my NAT gateway, and it's very simple here. There's nothing here. Select the public subnet. Okay, I'll select public subnet 1A, and here just select elastic IP. And you see our elastic IP is there. Okay, our elastic IP is there. That's it. Add a tag my NAT gateway, create NAT gateway. Our NAT gateway is created. That's how simple it is. But before that, you need to understand some concept. It's easy to create, but before that, you need to understand those other concept. Okay, but does it mean we are getting an internet now? NAT gateway is created, and unlike internet gateway, we don't need to attach it to our VPC. Does it mean we got internet? The answer is no. See, still no response. Okay, and here you see these are the root tables. So yesterday I told you that in root tables we get a default root table. Okay, we get a default root table with default VPC, but for our custom custom VPC also we got a table. Yesterday, if you remember, here we added the root for our internet gateway. But today I will show you something different. Today we will create a new root table because that is something that we haven't done now. Okay, today we will create one more root table for our demo VPC, but this root table will be only for private subnet. Okay, it will be only for our NAT gateway or private server. what we are going to do, we are going to create one more root table dedicated for private subnet, private server. Okay, so let me, and there I will add the root for private server, that is NAT gateway. Here I will create a root table. This will be a private root table. I will select demo VPC and that's it. Just provide the name and select the VPC and create root table. And in this root table, I will add my root. Okay, what when we are adding root for NAT gateway, what should we add? If you want internet IGW, guys, NAT gateway, internet gateway we already added. We are adding root for NAT gateway. If you are adding root for NAT gateway, and here if I said select internet gateway, how it can be a root for NAT? Remember for which server we are adding? We are adding it for private server. When private server wants internet, what brings internet for private server? NAT gateway brings internet for private. Okay, so I will save this rule. Now the moment I save this, will my internet works in private? And as internet, do you think we come on? Just because I give the name private, does it make it private? Don't you think this is, guys, understand this is now how to make sure that this root table works with private subnet? Now how to actually do it? Do you see here subnet association? If I go here, there is no subnet associated with this. What I will do, I will simply edit this. I want this root table to work with which subnet? Private subnet. So I will select both the private subnet and I will associate. I will select both the private subnet and I will associate them here. Save association. Now the moment I do this, do you see internet is flowing in our account? Do you see internet is flowing in our account now? The moment I do the subnet association. Let's move on. Now I will cover the last topic of VPC, that is, let me go to VPC here. That is peering connection. What is peering connection? Peering connection simply means up until now whatever we discussed was related to uh, whatever we discussed was related to one VPC. What if I want to connect multiple VPC? Good question. Why you need to connect two different VPC? Because let's say sometimes your EC2 is in one VPC, your database is in another VPC, and you want to, from EC2, you want to access that database. So obviously you will have, okay. Now what I'll do here, I will click on create peering. Okay, here I will give a name. Let's say my VPC peer. Okay. Now here in the requester, I will select my requester VPC. Let's say demo VPC is my requester VPC. So VPC peering is basically sending the request. Okay. In VPC peering, basically one VPC send request to another VPC. Okay. And another VPC, the account owner, need to accept the request. Right. So here is my demo VPC, which is the requester VPC. And here in my account, in the same region, I can select my demo I can select my default VPC. Now my demo VPC will send request. Alright, so here you see demo VPC will send request to default VPC. But what if I select another region? Now here I can select another region and I can provide VPC ID of another region. So see, basically VPCs are there. There are two VPC that you need to connect. They can be from same region. Okay, or two VPC that you need to connect. They can be from different region. Okay, or two VPC that you want to connect, they can be from different account altogether. Okay, so whether your two VPC are in the same region, same account, or in the same account, different region, select that. Okay, provide the ID accordingly. If you want to connect your VPC in your account with somebody else VPC in their account, you need to provide their account ID here. Okay, you need to provide their account ID. right? Now where to get account ID? Account ID we get from here. Okay, what is account ID? Account ID is the unique ID of your different department. So let's say here I provide some fake account, right? So this is how it will work. Obviously, the another account owner should accept your request, then only it will connect. You can't randomly send it to anyone. Right now, I will select my account. I will select the same region, and here I will select my demo default VPC. So my demo VPC will send request to default VPC, create peering connection. Obviously, it is my account, so here itself I will see the request and everything. Okay, so here you see I have an option. I can accept the request or I can reject the request. So VPC pairing is a very concept. Is this clear? There is nothing. Okay, now everyone look. Please note down how to delete all of this. We created many things. Okay, so there is a way to delete all of this. The very first thing we will do is we will delete the peering connection. Okay, delete this. Second thing that we will delete is our servers. Whatever servers we created in that VPC, we will delete all the server. Okay, I'm not deleting root table directly. I'm deleting EC2 server first. Okay, now pay attention. Let's wait for them to shut down, terminate it. It automatically. Wait a minute, why this server not deleted? 1 second, let me terminate again. Okay, now it is shutting down. Let's wait. Let's just wait for it. Let's wait for it to get terminated. Okay, as you can see, our servers are terminated. Now I will go back to VPC. Now I will go to NAT gateway. Okay, I will delete the NAT gateway first. Okay, first of all, delete the NAT gateway. Now we'll have to wait for it. Let's just wait for it. Because if you do not delete in this sequence, then it will not work. Okay, so deleting in that sequence is important. 2 years. Okay, so here you can see NAT gateway is deleted, and there is one more proof of it. I will go to root table. I will go to this private root table. Here you will see. Do you see here? Okay, 1 minute. Not reflecting right now. Refresh. Select root table. Do you see black hole is written here? Why black hole is written here? Because the route where it was pointing, that route is deleted now. Okay, the route where it was pointing, that route is deleted now. Okay, so come back to, okay, now let's go back, check NAT gateway once. It's deleted, right? Okay, sometime it takes some time. Now we will go to elastic IP. If NAT gateway is deleted, we should be able to release elastic IP. Okay, so here you see release option is there. Okay, here you can see release option. So we need to release this elastic IP address. Okay, because we no longer need it. The moment we release it, it will go back to AWS and we will no longer be. Okay, so here you see I release the elastic IP. Now you can go to your VPC and now you can delete your VPC. Okay, now you don't need to delete anything else. No need to delete your root table, no need to delete subnet. Now if you delete the VPC, here you will see it will show you all the resources it will delete. Okay, now it will delete each and everything. Saying IP address. Now you see here when I delete the VPC, everything else will be deleted. Configuration protocol. Okay, look at this. I deleted that VPC and everything else inside it is deleted. Okay, so how to delete everything? First of all, delete NAT gateway. Sorry. First of all, delete peering connection if you created, then delete NAT gateway, then delete servers, delete all of your EC2 server, then delete NAT gateway, then release elastic IP, then delete VPC. Okay, now the next service we are going to cover is S3. Okay, and here I will give you a good news now. Okay, two good news. First good news is S3 that we are going to cover is very easy service. Okay, S3 that we covered is a very easy service. Lengthy, correct. Unlike VPC was a very tough service. S3 is a very easy service. But the best news is, one more good news is, in real world, most of you people might never going to get work in VPC. Most of you people may never work with VPC. Why? VPC is an important service, but most of you people will never get work on VPC. Why? Because VPC is the most critical service in any AWS project. Because it is on the basis of VPC where everything else is created. So if something goes wrong in VPC, everything goes down. And it is very, very, very difficult to fix that. Yes, that's why it's generally the responsibility of cloud architect or senior network engineer. Only those people get work on it. Most of you people will never get work on it. Okay, but still it is important from certification point of view. In certification, you will get a lot of questions on it. Right? And the S3 service that we are going to cover now. S3 is a very easy service, but S3 is the service on which most of you people will be working with. Most of you guys will be working with S3. Okay, S3 is a fundamental service. Right? So no matter what is your profile, whether you are a DevOps engineer, whether you are a data engineer, whether you are a tester, whether you are a web developer, no matter what is your profile, everyone works with S3. It is that important and it is that fun. Okay, just a second. Okay, let's go to S3. S3 is regional or zonal. S3 is global service. Yes. Okay, now before we start with S3, let's first understand what is S3 theoretically. S3 is the storage service. And it is such a popular and such a commonly used service when it comes to storage that you can think S3 is kind of a default storage service of AWS. Okay, S3 is kind of a default AWS service for storage. Okay, S3 is a default storage service. Now, the thing that makes S3 unique is, first of all, S3 is a global service. Okay, S3 is a global service. Up until now, whatever services we covered, whether we covered EC2, EFS, or VPC, all the services were, whatever service we covered till now, all of them were regional service. But S3 is the global service. Okay, what is the meaning of global? Global means it is not attached or it is not defined to any particular region. For example, when we created EC2, okay, the server that we created was created in that region, whatever region we selected. That's not the case with S3. Okay, so first of all, S3 is a global service. Second, S3 is a public service. This also makes S3 very unique. S3 is a public service. What is the meaning of public service? Or what is public service? What is private service? See, EC2, EFS, both of them are private service. But what is the meaning of private service? Private service is that service which is created within VPC. Okay? And S3 is a public service. Means what? S3 is not created inside VPC. S3 is created outside of. S3 is a public service means it is not created inside VPC. Now you'll say, then is it secure? The answer is yes. S3 have its own security mechanism. Okay, S3 have its own security mechanism. Even though it is not inside VPC, it is still secure. Alright. So these two things make S3 unique. Now, S3 is made up of buckets. Okay. And here you see in my account, there are 32 buckets. You can see in my account, there are 32 buckets. What is bucket? Bucket is basically the container inside which you upload the file. Okay, bucket is the container inside which you upload the file. Okay, so here you see list of all the buckets. Okay, now let me write few things here. Okay, let me just tell you directly, we don't have much time. One more thing. You remember how much storage we define in while creating EBS? Or do you remember what was the maximum storage that was there in EBS? 16 terabyte. Now, is there any maximum storage for our S3? The answer is no. S3 provides you infinite storage. Yes, S3 comes with virtually infinite storage. You can store as much data as you want, no problem at all, no limitation. Yes, single file you can upload up to maximum 5 terabyte. Okay, a single file can be there for maximum 5 terabyte, not beyond that. And think about it, guys. Did you ever have you ever seen a file more than 5 terabytes? No, 5 terabyte is a very big size. Okay, so S3 literally allow you to upload unlimited amount of data, and that too any kind of data. You can literally upload any kind of data. You can upload audio file, you can upload video file, images, PDF, any kind of file you can upload. No limitation. Okay, you can upload any amount of data, you can upload any kind of file. Okay, but S3 is not a database. S3 is a pure storage.
Just a quick info, guys. Intellipaat brings you executive postgraduate certification in cloud computing and DevOps in collaboration with I have Divya Sampar, IIT Roorkee. Through this program, you will gain in-demand skills like AWS, DevOps, Kubernetes, Terraform, Azure, and even cutting-edge topics like generative AI for cloud computing. This 9-month online bootcamp features 100 plus live sessions from IIT faculty and top industry mentors, 50 plus real-world projects, and a 2-day campus immersion at IIT Roorkee. You also get guaranteed placement assistance with 3 Azure job interviews after entering the placement pool. And that's not all. This program offers Microsoft certification, a free exam voucher, and even a chance to pitch your startup idea for incubation support, up to rupees 50 lakhs from IAP Divya Sampark. If you are serious about building a future in cloud and DevOps, visit the course page linked in the description and take your first step toward an exciting career in cloud technology.
So S3, few things I told you, if you remember, there are two unique things about S3. First is S3 is a global service. Okay, S3 is a global service. Means what? It is not bounded to any region. Okay, unlike your EC2, unlike your VPC, S3 is not bounded to any specific region. It is global in nature, right? So that's a unique thing about S3. One more unique thing is S3 is a public service. What is the meaning of big public service? Public service means S3, unlike EC2 and VPC, S3 resources or S3 buckets are not created inside VPC, unlike EC2 or EFS. Okay, so S3 is a public service because it is not created within VPC. But do not assume that just because S3 is not created within VPC, it means S3 is not secure. No, not at all. S3 is a very secure service. Okay, S3 is a very secure service. It's just that it have its own parameter of security. It have its own way of security. Okay, so I'll show you S3 here. Yeah, we can connect with S3 from VPC also. Okay, so here you see in S3, see in EC2 what we created, In EC2, we created server. Okay, in EC2, we created server, we created instance. In S3, what do we create? In S3, we create buckets. Okay, so on your screen, you can see these are the buckets in my account. Okay, what are buckets? Buckets are nothing but container. Okay, buckets are container. And what is container? Container is something inside which you upload your object. Basically, you upload file. And in S3, those files are called as object. Okay, and the good thing about S3 is that if you remember when we covered elastic block storage, EBS, at that time we saw that mostly in EBS the maximum capacity is up to 16 terabyte. That is the maximum storage. But in S3, that's not the case. Okay, I'll tell you. I work in big data. My previous client was one of the biggest bank in the world. Okay, all of you guys know its name. It was one of the biggest. It's actually one of the top three banks in the world. Okay, at that time we were dealing with their data, so we were getting their batch data, we had their historical data, we have their data from their there were some their internal servers were also there, from there also we had data, and we had streaming data also. Okay, so our team created a data pipeline that was not daily, but it was in total it was working with more than 50 terabytes of data, 50 terabytes of historical data. Okay, the data pipeline that we have created, 50 terabytes of data. That was their last, I think 10 or 12 years of data, something like that was there. Okay, and that was also not their complete data, right? So where that data was stored, that data was stored in S3. The data was coming from multiple sources, but it was stored in its raw format in S3. Okay, so S3 provides you that virtually infinite storage. Okay, S3 allows you to store as much data as you want. Okay, you can store as much data as you want. Especially in my domain, data engineering or big data, we use S3 all the time. There is no project of big data that can be done without S3, because S3 is our default space. Actually, see, there are many storage, there are many database, and I'm not saying at all that we do not use other storage or other database. We use all of them according to their specific situation. For example, if we want to do analytics, we don't store data in S3. If we want some analytics, we store data in data warehouse. Okay, our transactional data we store in database. But S3 is that common place where you can bring data from everywhere, and then you can begin your process. Okay, so the good thing, last time I told you, most of you people might never get to work with VPC in a real world product or project. Okay, you will never get to work on VPC because it's a very core service for networking people, and it is handled by them only. It's a very critical service. But S3 is such a common service that all of you will work with S3. Okay, I know people who don't know about AWS, but they have also worked with S3 because in their project S3 was there. Okay, so S3 is such a common service, it is used by everyone, right? So that was little bit introduction. Now let's get started. So what I will do now, we will directly see the practical. There is nothing much theory in S3. We will directly see the practical. I will create a bucket here. Okay, I will create a bucket here. I'll click on create bucket. Again, do not worry, Pratik, how many bucket we can create. Always ignore such question. How many things we can create? These things I forget all the time, and you should also never try to memorize it. Okay, maximum soft limit is 100 bucket, hard limit is 1000 bucket. But this knowledge will not give you any job. This knowledge will not crack any interview. So never worry about, Pratik, how many bucket we can create. It's useless. Okay, numbers, always remember, in cloud, never try to memorize the number. Number will always improve, number will always change. Okay, understand the core concept. So here you see I'm creating a S3 bucket. Now while creating the bucket, here you see the very first thing is AWS region. Okay, now you'll say, Pratik, you said earlier that S3 is a global service, but now why this is region here? Okay, why region is written here? See, S3 is a global service, that is 100% true. But tell me one thing, when I upload my data to S3, okay, S3 is a virtual storage. I'm uploading data to S3. This data has to go somewhere in some physical storage. Where do you think that will go? Tell me. It has to go in some region, right? In some region, in some AZ, there will be a data center, there will be a storage drive. It has to go in some region, right? So S3 as a service is a global thing. S3 as a service is a global service. But data will be stored in some location. Data will be stored in some AZ, in some region. Do you agree with that? So are you ready to understand the fact that S3 is a global service, but data is stored in some region? That's why when we create bucket, we need to define the region where my data will be stored physically. Is that concept clear with you? Just because my bucket is regional, it doesn't mean S3 is not global. S3 is global, but your bucket is regional. Your data has to be stored somewhere. People at an intermediate level of experience, your interviewer, if S3 comes, and if you, especially if you're applying for cloud engineer, if S3 comes in interview, they might try to ask you or confuse you in such topic. Okay, so S3 is a global service, but bucket is regional. Okay, now you see here I will provide the bucket name. Okay, so I will provide, let's say, test bucket. Okay, now I will keep everything else to default. Okay, keep everything else to default, right? So here you see I'm creating a bucket with the name test bucket. Okay, I will try, ignore everything. Okay, all of this thing I'll show you one by one. Okay, now when I try to create a bucket here, you see I get error. What is the error? It is saying bucket with the same name already exists. All right, but if I show you my account, if I show you my account, in my account you will not find a single bucket with the name test bucket. Okay, so you see in my account, you see there is no bucket with the name test bucket. Then why I'm getting error? Because this name has to be globally unique. Look at this. This bucket is not there in my account, but I told you S3 is a global service. So here we can't provide this name because somebody else in the world have already created a bucket with this name. And what is it? See, right now just understand this as a rule that you can't create a bucket. You have to create a bucket with a globally unique name. Later I will tell you the technical reason for it. There is a proper technical reason for this. Okay, so here I will create a bucket with the name, let's say, what is today's date? 28th June. So here I'm creating a bucket with this name, test bucket 28th June. If nobody else in the world have created bucket with the same name, then we should get this bucket. Okay, I will create this bucket. Yeah, here it is. Look at the time. Your bucket name has to be globally unique. That test bucket name was not there in my account, but somebody else in the world have created that bucket. I told you S3 is a global service. So bucket name has to be globally unique. Okay. So you might, and I will give you technical reason for it also. So basically you guys know this, right? Domain name cannot be duplicated. Domain name has to be globally unique. You cannot have two websites with google.com as a domain name, right? Similarly, S3 bucket name cannot be duplicated globally. It has to be unique globally. Right, so here you see I created my bucket. Now here I got my bucket. Now if you look at the bucket, if you look at this UI, without, even if you might be coming from, let's say, you might be into working into management, but still you can understand by looking at it, looking at the UI, that it's very user intuitive. There is a upload option, there is a create folder option, there is a delete, open, download option. So very user friendly UI. Okay, now what I'll do here is my bucket. The bucket got created. Now I'm going to simply upload a file. Okay, let me upload a file. Let me drag and drop a file. Okay. All right. So here you see I uploaded a image file. I will upload this file now. Okay, so you see my file is uploaded, and here you see I got one object in my bucket. So this is my bucket, and in this bucket I got one object. Right? Now look at this. Okay. So I select this object, I can download it, I can open it, I can delete it. Now here you see this open button. Okay, before I show you that, let me click on this object. And now here you see all the details of my object. And you see there is an object URL as well. Now, do you remember where else you have seen URL for the file that you uploaded? Where do we get the URLs for the file we uploaded? Google Drive, OneDrive. Okay, so if we upload any file in Google Drive and we want to share that file with somebody else, what we do? We use that object URL. So here you see this is my object URL. Instead of it, I'll click on this open button. I'll click on this, and here you see. Here you can see I got my image. So this is the file that we uploaded. Okay, here is my image. So here you see I got my file. Okay, here is my file I opened. Now what I will do, here I will go to this object URL. I will open this also. And there you go, we got error. Why I got this error? I already told you, just because VPC is not there, it doesn't mean it is not secure. S3 have its own security features or parameter. Okay, so you see, with whoever you share this URL, they will get access denied. But what was the difference? When I go to object URL, and generally that's what we do. From my OneDrive, if I want to share a file with my team member, I copy the link of the file, correct? But whenever you work on such storage like Google Drive, OneDrive, or S3, by the way, do you guys, have you guys, all of you guys use this Dropbox? Maybe not today, not a lot of people use it, but back then it used to, we used to use it a lot. Okay, so Dropbox was one of the earliest cloud storage provider for normal consumers. Okay, so in the initial years of Dropbox, do you guys know that Dropbox was using S3 behind the scene? All the data was getting stored in S3. Dropbox was just providing the interface. Of course, they had a lot of things, but the whole thing was like this, that they were providing the service, but behind the scene, they were storing data in S3. Now they moved to their own data center. But earlier, Dropbox was providing, whenever you uploaded your data, it was going to S3. So here you see security is there. We understood one thing, even though VPS is not there, but security is there. Okay. But then why my file was opening here and why it did not open here? Why there is no security here? Okay. Why? I'll tell you the reason. Let me copy this URL. So in S3, here we have object URL. And object URL look like this. Okay, this is how object URL looks like. Right? Now, after object URL, there is something called as pre-signed URL. And pre-signed URL looks something like this. Okay. Now, I don't know whether you can see it or not, but if you look closely, you will say that both of them are different. There is a difference, right? Here you see serverless plus data lake architecture. Okay, plus is not there, but still, till here the URL is exactly same. Okay. Now I'll tell you what is happening here. Okay, we will not get into its cryptography logic. There's a lot of security behind the scene. Okay, the good thing about cloud is you don't need to know those unnecessary detail. Okay, abstraction is there. You need to know what, on the basis of which you can do the development. You don't need to know how S3 is providing service. But there's a cryptographical algorithm is there. So what is happening here is your default URL is by default lock. Okay, this URL is by default lock, it is by default secure. But when you use pre-signed URL, you get a key with that. So if this is your locked URL, then this is the key of that URL, key of that lock. This is basically, technically, it is called as ANZ security token. Okay, this is called as ANZ security token. Okay, basically this is a temporary, I mean, this token is a temporary credentials for you to unlock the object. Okay, remember, security tokens, whenever you hear about security tokens, always, most of the time, it is nothing but temporary storage. Okay, so what is happening? Pre-signed URL comes with ANZ security token. Okay, what this token will do? This token will unlock your object. Okay, but what I told you, it's a temporary storage. Now you see the request has expired. Here you see 300. What is this 300? This 300 is 300 second. Okay, so this pre-signed URL was active only for 5 minutes. You got access only for 5 minutes, and after 5 minutes, that access is gone. Temporary access. What if I again select my object and again I click on open button? Again, you will get a new pre-signed URL. Again, this object will be available for 5 minutes. So what is pre-signed URL? Pre-signed URL is that, see, I'll give you directly use case. Let's say you have data in your S3 and you don't want to make this data publicly available. Okay, you don't want to share this data with anybody else. You don't want to make it publicly available. But you want to share this data with few people. Okay, for a let's say for a temporary period of time, you want to share this data with few people. How you will do it? Without opening your object, without making your object publicly available, how you will make this object available for your few people? By using pre-signed URL. So let's say I have some objects in my S3 bucket that is not publicly available. Okay, but I want to share those objects with your batch. Let's say I have some PDF. I want you guys to access those PDF. I want you guys to download those PDF. What I will do? I will share the pre-signed URL with you. If you get the pre-signed URL, you will obviously get the access to the data. I will share the pre-signed URL with you. Will I share the will I share this object URL? Will I share this? No, because it is not publicly accessible. Okay, I will share this pre-signed URL. Okay, I hope everybody is clear. So this 5 minute is the default period. This 5 minute is a default timer. Can we change it? The answer is yes. How to do it? We'll have to create our own pre-signed URL. How to create our own pre-signed URL? Simply here, click on object action and here you see share with a pre-signed URL. Okay, here we can provide the time. Okay, minimum 1 minute up to maximum 12 hour or 720 hour. Okay, your present URL can be valid for minimum 1 minute. Here you can provide the time or maximum 12 hours. Okay, after even if you provide 12 hours, after 12 hours, your URL will definitely get expired. And the concept here is nothing but the concept. It's basically the security concept here. It's a security, you can say mechanism. Like for example, when you log into your AWS account, after 12 hours, your account get, automatically get logged out, right? This mechanism you will see everywhere. Okay, the same mechanism is here. I have a object that I don't want to make publicly available, but I want to share that object with few people. Let's say with your batch. What I will use? I will use present URL. So basically, present URL you will use when you want to give access to your data to few people for a temporary period of time. That is the purpose of present URL. If I want to make the object publicly available, then I will obviously share the object URL. But understand this, that if I don't want to make my object publicly available, I just want to share the data with, and see, there's a problem there. There is a security fault here. Let's say I share the present URL with you. Okay, I share the URL with you. What if you share that URL with other people? Do you think it will work for them or not? Publicly available means anyone can access. But my question was, let's say my object is not publicly available, so I share the present URL with you. And what if you share it with other people? See, that URL will work for other people as well. That is the problem. Understand, URL is URL. If I share a present URL with you and you share it with other people, it will work. That is the fault. That is a one problem with present URL. The fault with present URL that in the end it's a URL. URL is URL. Okay, until unless you actually developing a backend that will block that URL with some authentication. Until unless you don't do that, URL is URL. If present URL it works for you, it will work for some other person as well. Understood? That's one problem, but preset URL which generally is a good option when you want to share it, when you want to give someone temporary access to, let's say, some individuals. You don't need to make your entire object public. Is the concept of preset URL clear? Here, if I give, let's say, um, here if I give, let's say, minimum, let's just say 1 minute. I'll give 1 minute. We'll create this preset URL. Okay, here I'll copy this URL. I will simply paste the URL here and you will see this URL will be valid only for 1 minute. After 1 minute, this URL will be gone. Okay. But now here comes another question. Okay. Let's say we don't want to use pre-sign URL. Then how do we actually unlock the URL? But let me tell you few other point also. Okay. So here you see, I will go to my bucket. So you see okay, we covered pre-sign URL. Let's move forward from there. Now you see the object URL was not working. What if I don't want to use pre-signed URL? Now I want to completely open up my object. What if I don't want to use pre-signed URL? I want to actually make my object publicly available. Now what? How do I make my object publicly available? Okay, so let me show you. So here you see, when we click on create bucket, you remember there was something called as here, look at this, block public access setting. Okay, so what happens is, this is my bucket. In this bucket, this is my object. Okay, now when my request is trying to reach to this object through object URL, my request is getting blocked at this bucket level itself. At the bucket level itself, my request is getting blocked. Why? Okay, because of this security. Block public access setting for this bucket. This is a bucket level setting that will block any kind of request coming from public internet. Okay, so we need to uncheck this, right? So I will go to my existing bucket. I will go to permission. Here in the permission tab, you see block public access setting. So what I will do, I will edit this. I will uncheck this. That's it. We are done. Okay, click on save changes. Since you are removing security, it will ask you to type confirm. We will type confirm here and we are done. Okay, we type confirm here and we are done. Okay, now can we access object URL? Let's see. Okay, we are still not able to access it. Why? Because now what is happening is the request is able to bypass the bucket. But when it is reaching to the object, request is able to bypass the bucket. But when it is reaching to the object, there it is failing. There, once the request reaches to the object, there the request is failing. Why? Why request is failing? Because at the object level also there is a security. Okay, so there was a security at the bucket level. Now there is a security at the object level. And there are two approaches here. I'll show you. There's an older approach and there is a new approach. I'll show you from the older approach. Okay. So when we created the bucket, at that time, you see here we had one more option, object ownership. Okay. So basically what happens is you can make any object publicly available. How? Simply select your object. Here click on action and here you will see make public using ACL. Okay. You click on this object, your object will be public, then you will be able to access your object. But the problem is, you see, this option is not available for us. Okay, this option is not available for us. Why? Because when we create bucket, by default, object ownership ACL is disabled. Okay, which is recommended. I'll tell you the reason why also, why it is recommended. ACL is disabled. So we need to enable the ACL, then this option will be enabled. Okay. So again, we'll go to permission tab. Okay. Again, here we will go to object ownership and ACL was disabled. Now we will enable the ACL. The moment we enable the ACL, okay, just go with acknowledge, save changes. The moment you enable the ACL, you can again select the object. And now you see this option is available now. Yes, the option is enabled. Okay, so you need to enable the ACL because this option is, this option makes your object public by ACL using ACL. ACL is access control list. Okay, now when I make the object public, now if I go to the same URL and if I refresh here, you will see now this URL will work. Okay, now this object is publicly accessible. Right? So what we understood two things, that there are two levels of security. One is at the bucket level security, one is at the object level security. Bucket level security is something which is mandatory. You have to uncheck that block public access. Okay, as long as that those checks are there, request will never be able to reach to your object. Then we saw at the object level, object is by default private, but we can make it public. Okay. Now here, do you see any problem? Do you see any problem with this ACL approach? Guys, you understand the problem here, that S3 is an infinite storage. You can upload billions of object. Are you going to make each and every object public? No, right? That will take a lot of time, that lot of efforts. If you want to make an object publicly available, are you going to literally going to make each and every object public? No, that's the problem. Think like this. Whenever you see any concept, try to understand the problem in that concept. So what is the solution? This is the reason why ACL is not recommended anymore. Okay. So there is something called as policy, something called as IAM policy. Okay. We set up IAM policy that gives better security. Okay. Now what is this IAM policy? IAM we will cover. Okay, so we don't need to know about it right now. I will show you a policy demo also later on. Right now, just understand this one thing. In your account, let's say in your project, there are, you know, hundreds of people, hundreds of developers working from different teams, from different regions. Multiple developers are there. Okay. Now, who to whom you want to give access to the bucket? Do you want to give access of the bucket to your developer? Do you want to give the access of the bucket to your tester? Do you want to give access of the bucket to your business people? To whom you want to give access? Okay, you want to give access of the bucket to the developer. Do you want to give access to all the object, or you want to give access to few object? Right? Okay, you want to give access of the 100 object. Do you want to give upload object access? Do you want to give them download access? Do you want to give them delete access? Okay, let's say you want to give them access, open access, you want to give them download access, but you don't want to give them delete access. You understand the complexity we are getting into? So many permutation and combination that can be done using policy. With ACL, you cannot go in such depth. That's why ACL is a very limited option. That's why ACL is outdated and nobody uses ACL approach. Okay, what we use is something called as policy approach. Okay, in policy, here we write JSON code. Okay, here we write JSON code, and that JSON code is nothing but your IAM policy. And using IAM policy, you can define any complex requirement very, very easily. Okay, you can define any complex requirement, security requirement very easily. And we will study that. Today also I will show you a policy demo. But when we get into IAM, I will show you how you can create your own policy. Okay, especially if you guys are getting into DevOps. For you people, it's very important to understand all of this policy and all. Okay, because you as a DevOps engineer, you'll be working on IAM a lot. So right now, understand this one thing: ACL is a outdated approach. Even AWS also do not recommend using that. Okay, so we go with bucket policy approach we go with. How does policy approach look like? Do not worry, I will show you a demo for it. So that was the security part of S3. Now there are few more things and we'll see that also. Okay, now a very important concept, that 100% guarantee you will get that in certification. You might not get question on this interview because this topic is important, but it is very simple as well. All of you people who have worked, who know even the basics of GitHub or Git, you will you understand this concept easily, but everybody else will also understand. Right now, let's say I select this option. Okay, let's say, for example, somebody selected this object. Okay, let's say this is your work, this is your data. But one of your colleague, and by the way, this example is inspired from a real world incident. One of your colleague accidentally selected this object. Then they accidentally clicked on delete button. Then they accidentally type permanently delete. Then they accidentally clicked on delete object. Now what? Now your company will accidentally fire you. Okay? And trust me, this has happened in my team, not with me, but it is. I mean, not the firing stuff, but this has happened. It was very shameful. This has happened in one of my previous company. Okay, so that's why you need to have technical knowledge. So even when you lie, you need to know what to lie. They say that you need to have knowledge for even for cheating. Okay, so even if you are trying to lie, you need to know some technical knowledge. So you lie better. Okay, so what you do in such case? Now the data is deleted. There is nothing we can do. Okay. Yeah, validation was there. It asked us to type permanently delete. Validation was there. Still, we accidentally type permanently delete. So obviously it got deleted. Okay, so there is nothing we can do. Now, I'll show you one more thing. One second. Okay, so I'm going to simply upload this simple text file. Okay, I will upload this simple text file and look at the content of the file. This is a text file version 1. That is the content. That is the content of the file. Okay, I will upload this file in my S3 bucket. Okay, so here you see I'm uploading this file. Upload. Okay. Now again I will go back to that file. I will update this file. Okay, I will re-upload the file. Look at this. I'm not changing the file name. I'm not updating the file name. Okay, what I'm doing? I'm not uploading the file name. I simply updated the content inside the file name. Okay, I simply updated the content inside the file name. Now what do you see? We have only one file. Okay, so if I open this file and you see it's our latest file. So can we say our older file got overwritten? And this is what generally happen in any storage. Okay, if you upload file with the same name again, most likely it will overwrite the file in most of the system. Okay, it will overwrite the file, right? My older object got replaced by my new object. So that is a loss of data. Now imagine there is a server in your product, there is a server, okay, and on, let's say there was another team that is taking care, that is, okay, let's say there's a server, okay, here, okay, there is a server. Now there is a team that is working on this server, okay, they, let's say, upload some data here, upload some CSV file. For example, let's say every day a new employee.csv file comes, right? Now ideally, let's say this team that is working here, okay, their backend application is writing a file with the date. Okay, so let's say employee dash today's date dot csv. Okay, so every day when a new file comes, there is no overwrite, and here we are consuming that data, right? But suddenly, let's say something went wrong in their application, and the file they are loading as employee.csv. Okay, now you can understand, every day when this new a new file comes, employee.csv, older file will get overwritten. Basically, you're losing your data. You're having data loss. Your yesterday's data is getting overwritten. So how to deal with this? So to deal with this, we have something called as versioning. Okay, there is a concept of versioning in S3, bucket versioning. Here, if I go to property, you will see there is something called as bucket versioning. Here, if I edit this, now you see bucket versioning. Here I'll click on enable. That's it. Enable this versioning and you're done. Click on save changes. But whatever data that is lost, that is lost. You can't get that data again. If your file one version one was one got overwritten, now that you lost. There's nothing you can do about it. Okay, but now when you upload a new file, let me again update the content of this file. Okay, when I upload this file with the updated content, I'll click on upload. Now again I can see only one file. Does it mean this time also it got overwritten? The answer is no. Okay, the answer is no. What happened here is, see, now there is a new option called as show version. Okay, you see there is a new option called as show versions. What is the meaning of this? Show version. Now you see when I click on it, I can see two versions and look at their time. This is my latest version, this is my older version. Okay, so by default, if I go here and if I click on open, you will see the latest version. See, version 3. But if I go back here and I click on show versions, now you see my older version is also there. Okay, if I open this, here you see version 2. Okay, so basically what we understand from this, when you enable versioning, after that, if you upload file with the same name 100 times, okay, it will store all the 100 version, right? Versioning store all the version of your file. Okay, see, versioning is what? Versioning will allow you to upload file with the same name again and again, and it will store all the version. You see, again I uploaded file .txt. Did I change the name? No. If I had changed the name, then there would have been two files, because those two will be the different file. But now you see, even though I uploaded file with the same name, I see both of their version. It's not getting overwritten. Okay, so versioning prevents overwriting of data by creating multiple version, right? Now versioning is a very simple concept. Okay, there is nothing much brainer here. It's a very simple concept. So nobody in interview, actually people do ask, to be honest. I'm surprised why people such ask such simple concept. But to be honest, in any company, if any good person who is, let's say, maybe, I don't know, I should say this or not. Let's say someone who is technically sound. They might not ask you what is versioning. Okay, because it's very simple. There is nothing much here. Okay, but one thing that can be asked to you is, how does versioning works? The answer is on your screen. Okay, the clue is on your screen. Okay, see, I'll tell you. Version ID is the answer. But what exactly is happening here? See, when versioning was not enabled, at that time, the file was getting overwritten. Why? Because at that time, the name of the file was the primary key. Okay, so there is a concept of primary key in database. Okay, what it simply means is, for example, all of you guys have, let's say, student ID. Okay, do you think student ID can repeat? There can be two Praveen in the class. There can be two Vivek in the class. But do you think there can be two same student ID? Student ID cannot repeat, right? That is called as primary key. It cannot be duplicated. So when versioning is not enabled, okay, at that time file name is primary key. That's why if you upload file with the same name again, it will not tolerate it. It will not tolerate duplicate name. So it will overwrite previous file with the new file, right? Understood why it was overwriting? This is the internals. Okay. But when you enable the versioning, after enabling versioning, what is happening? Every file get something called as version ID. Now, what is version ID? Version ID is the unique ID that every object will get. The object that were uploaded previously before enabling the versioning, obviously they will be null because they were uploaded before enabling the versioning. But here onwards, no matter how, okay, let me do one more time. No matter how many times you upload it, every new upload will have a new version ID and that will always be unique. Okay, look at this. Okay, because what is happening when you enable versioning, the file name is no longer the primary key. What is the primary key? Version ID. That's why now it can allow you to upload file with the same name again and again. And if you notice one thing, this time I did not even change the content of the file. Okay, I did not even change the content of the file. The content of the file is still the same because content never mattered. The content of the file never mattered. That I just updated just to show you the difference, just to show you the practical. The problem was the file name was same, and if you upload file with the same name, it will get overwritten because file name was the primary key. And now when we enable versioning, version ID is the primary key. That's why you can upload file with the same name unlimited time, and it will allow all the unlimited version, because all of those unlimited versions will have, each and every one of them will have unique version ID. That's how it works. Now, if I click on this, if I check this show version, by default it will always show you the latest version. Okay, look at this. By default you will always have the latest version. And if you go to this file, look at the object URL. In object URL, by default, the default object URL is normal, right? But what if you want access according to version? If I click on show version, now you see there are three versions. If I go to the oldest version, now you see version ID is there in the object URL. Version ID null. What I will get here? I will get the oldest version. If I go to second version, now you see when you click on version, you see the actual version ID in the URL also, because that's how it is identified. Your object is identified by its name. Your version is identified by version ID. Uploading by file name. File name matters, Rohit. Content not. Okay, so one more thing I'll show you here. I will select this file. Okay, I will click on delete button. Okay, here it is asking me to type delete. Okay, I will type delete. I'll click on delete object. Okay, and you see our object is deleted. So before break, we saw one advantage of versioning, and that is that we can upload different version of the files. Okay, we can upload different versions of the file, right? And it will preserve all the version even if the file name is same. Okay, it will preserve all the versions. Now the second advantage is that it also prevent accidental deletes. Look at this. Okay, so I deleted the file, but here you see all of my previous versions are there. All of my previous versions are there to open, to download, to delete. Okay, all of my previous version is there. So versioning help you with accidental deletes as well. Okay, it helps you with accidental delete also, right? So you can still access your older version of the file. Look at this. Okay, now how it is happening. The concept is very important to understand here. How versioning is preventing you delete, because versioning can help you preserve different version that is given. That's very simple to understand. But how it is preventing accidental delete, that's very important. How it is preventing accidental delete is by creating another version. Okay. See, here you might not, many of you people might not like this, or you might, find this very silly. But I will show you one example. Many years ago, I was watching this movie with kids, and when I was watching this scene, I do not remember the name of the movie. When I was watching this movie, okay, and this scene came up, it immediately reminded me of delete marker. Okay, S3 feature. This one. Okay. Now here what happens? This person, when he wear this whatever it is cloak, okay, he becomes invisible. Right? Understand? When this person wears cloak, he becomes invisible. Right? Does it mean the person is not there anymore? No. Person is there, but he is hidden. He is invisible. Exactly same thing is happening. Is your data deleted? No. Your data is just hidden. Is this person not there? No. The person is there. He's just hidden. Who is hiding that person? Can I say this cloak is hiding that person? Who is hiding this object? Something called as delete marker. So when you delete files, when versioning is enabled, when you delete files, a delete marker is created. Okay, a delete marker is created. And what delete marker will do? Delete marker will hide your original files. Okay, what delete marker will do? Delete marker will hide your original files, like recycle bin. Okay, so because of delete marker is a 0 byte file. The purpose of delete marker is what? The purpose of delete marker is to hide your original file. So to you, it might look like that file got deleted, but no, the file is not deleted. The file is still there, but it is hidden. Okay. Now tell me logically what will happen if I delete the delete marker. What do you think will happen? The original file will be reflected. Guys, if delete marker is hiding the file, if I delete the delete marker, don't you think my file will be visible again? If I delete the delete marker, what will happen? Your original file will be visible again. Delete marker was hiding your file. If the thing that was hiding your file, if I delete that file, then don't you think the hidden file will be visible again? See, all of my files are visible again. Okay. Now everyone see, this cloak was hiding that person. Okay, everyone pay attention. This cloak was hiding that person. How do you make the person visible again? The person will be visible again if we remove the cloak. So if I remove the delete marker that was hiding the file, then why don't you think the file will be visible again? See, again I'll show you. This is my file. If I try to delete this file accidentally, what will happen? Delete marker will be created. Will my file will be deleted? No. My files are not deleted, they are hidden. Who is hiding the file? Delete marker. So if I delete the file that is hiding my original file, don't you think my file will be visible again? Such simple logic, guys. See, my files are visible again. Okay. What I'm trying to tell you right here is that versioning prevent accidental delete. Do you remember before I enable the versioning, I deleted the file, and at that time when I deleted, it was asking me to type permanent delete. Do you see it is asking you to type permanent delete? No, it is asking you to type delete because this is not a delete. It will hide the file. That's why it is not permanent delete. Okay. Now you will say, Pratik, then does it mean we can never delete the file permanently? No, we can delete the file. How to delete the file permanently? For that, if you want to delete any file permanently, you'll have to delete them by their version. You cannot delete like this when your single version is shown. You'll have to click on show version and you'll have to individually delete all the versions. Okay, we have to individually select all the versions, then only the file will be deleted. Okay, look at this. Now if I select this file, now if I click on delete button, you see it is asking me to type permanently delete, because now it will be actually deleted. Okay, and when it is permanently deleted, obviously it is permanently deleted, you can never see it again. Okay, but when show version is not selected, then if you try to delete it, will create delete marker, and delete marker prevents any kind of accidental delete. Okay, now see. Now I'll click on show versions. Let's say, let's say I select all the version. Now when I click on delete button, now it will be permanent delete. Okay, now obviously if it is permanent delete, it means there is no way you can ever recover this object. It's a permanent delete. Okay, so that's how versioning helps you. Versioning helps you with two things. It helps you to prevent overwritten of the data by creating multiple version of the file. And second thing, it helps you prevent accidental delete. Okay, now I'll tell you one more concept. Okay, so our next concept is storage classes. Okay, and this concept, if you remember, we already covered in another AWS service. We covered this in EFS, Elastic File System. Okay, if you remember in EFS, we saw this option of IA and also one zone. This option we saw in EFS, not EBS. Okay, so we covered this in EFS. Now, what exactly it is, I'll tell you. Because in S3, it is even in more detail. Okay, so what is this concept? See, and this is asked in interview a lot. Okay, so pay attention. Now, what is this concept? Storage classes. See, I'll give you a scenario. I think I have also given this example previously. Every month, let's say you get some new data. Okay, every month in your product, you get 100 GBs of data. And for that entire month, you will be using that data. Let's say on 1st of June, we got 100 GB of data. And for rest of the June, we are using this 100 GB of data, right? Now, in the month of July, we will get another new 100 GB of data. Okay, in the month of July, we will get another 100 GB of data. Now what? Okay, will we use last month of data? Will we use last month of data? No, we will be using July month data. Okay, we will be using July month's data, right? Why? Because last month data does not matter. Okay, we will not be using last month data, right? Now, if I'm not using last month data, don't you think we should get discount on it? I have two data sets. Both the data sets are of 100 GB. But I use one data set every day and I don't use another data set at all. So don't you think in second data set I should get the data set that I use every day or frequently, I should get discount on it? Okay. So here comes the concept of storage classes. So for example, there is a storage class called as standard. What is standard? Standard storage class is the default storage class, by the way. Okay, when you upload your data in S3, and if your data doesn't go into any if your data doesn't go into any of the you don't specify any storage classes, it will go by default in standard. And in standard, your frequently accessed data goes. Okay, your frequently accessed data goes to standard, right? So next month in July, on 1st of July, if I get new data, I obviously want that data in standard storage class because I know I am going to access that data every day. So standard is for frequently accessed data. And this is there you will get nominal charges. Whatever data charges you have. Data charges means whatever normal charges of S3 that are there, you will get that here. But last month data, let's say in June month's data, we don't need that data anymore. So where we will put that data? That data we will put in standard IA. Okay, that data we will put in standard IA. In standard IA, we will put infrequently accessed data. S3 is available in free tier. Okay, in standard IA, we will put infrequently accessed data. Okay, the data that we know we don't use every day. Now understand the concept here. If both the data set, one that you use frequently and another that you don't use, if both the data set are in S3 in standard, you will not get discount. You get discount when you move the data infrequently access when you move your infrequently accessed data into standard IA. Because then only AWS will categorize that data as infrequently accessed and give you the discount. Okay, if you do not move your data into appropriate storage class, then it will charge you according to standard nominal charges. Doesn't matter whether you are accessing it frequently or not. Understanding the point, guys? Understand this simple fact. Okay, I want to save money in my project. And in my project, I know every month I get new data and we process only current month data. So how to save money here? By moving previous month data into standard IA, storage class is there to save the money. Okay, so infrequently accessed data we will move to standard IA. And the good thing is that whether you go with standard or whether you go with standard IA, both the data you will get in millisecond access. Okay, basically both the data is always available immediately. Okay, both the data is always available immediately. Yes, obviously here you will get discount, right? So in both the cases we get access to data in millisecond, and in both the cases data is replicated in more than 3 AZ. Okay, now what is this? See, why you never lose your data when you work on cloud? What is the reason? For example, in case of S3, you never lose the data because your data is replicated across multiple AZ. Okay, so in both the cases, data is replicated in more than 3 AZ, right? So this provide you the security. So in a region, if I know my data is there in at least 4 5 AZ, so if 2 3 AZ also goes down, still I have my data, right? Okay, so this feature is there. The unique thing is here it is infrequent and it is frequent. What is the minimum storage duration? Okay, I'll come to that also. What is this minimum storage duration? See, you know this basic business tactic that we get more discount if we add more more product in our cart while doing online shopping for groceries or anything, right? So similarly, will you get discount just because you uploaded, you put your data for 1 day in standard I? Will you get discount? No. You have to keep there for minimum 30 days, then you get the discount. That is the meaning of minimum storage duration. For example, shop for minimum, let's say 10,000 to get this discount. Shop for minimum 5,000 to get this discount. In case if we start accessing data from standard IA, then we'll, yes. See, uh, if you access the standard I frequently multiple time, okay, then you will not get discount. It will charge you according to standard if you break that policy. Okay, so if you want even more discount, then we have one zone, and one zone was there in EFS also. Remember what was it? What is the meaning of one zone? Let's say I have some data that I know I don't need it anymore. I have some data that, let's say, for example, let's say I have some data that is recreatable. Okay, that even if I lose this data, no problem, I can always get it again. So, do you think we need to replicate that data in more than 3 AZ? No, we don't need to replicate that data in more than 3 AZ. So, one zone will give you even more discount. Okay, one zone IA will give you even more discount. Okay, why? Because here data is not replicated. Okay, forget about more than 3 AZ. Data is not replicated. Only in one data is there only in one AC. Because obviously, if you do not have replication of data, it can be issue, right? If my data is not replicated, okay, then it's a issue. What if tomorrow some disaster happened and this particular, let's say, AZ is not available? Then I will not have that access to that data. So in such situation, okay, it's risky, okay, and you will get discounts for it. If you are ready to take that risk, then you will get discount on it. That's why one zone gives you even more discount. In one zone also, it is infrequently access data. You cannot access it frequently. One zone also, whenever you access data, you will get it immediately. But here the point is data is not replicated. Okay, here data is not replicated, right? I hope you remember this three storage class exactly we saw in EFS. But the thing with S3 is that S3 provides you even more option. Basically, this replication option was not there. I mean, explicitly was not there. Okay, now look at this. Here we have archival option as well. Okay, Glacier instant retrieval, flexible retrieval, deep archive. What is this? See, let's say like I'll tell you, there was a product on I was working in my previous company. We created our own product, and in that product, it was again related to finance. In that product, we the product cycle was according to financial year, right? So obviously, last financial year data we are not using until unless it is specifically required, right? Sometimes what happens in finance or such project, let's say there was from your client side, there was some legal issue. Let's say some allegation happened, some legal issue happened. At that time, they ask us, guys, please retrieve data from that financial year. from that particular day because they have to show it to, legal teams and all. Until or unless such situation does not happen, we don't use last financial year data. They charge you on the basis of that as well. Okay, but leave it. That's not our concern. Why don't they charge like this? We need to understand this concept. So here, what happens? Last financial year data that I know I'm not going to need. I'm done with that data. We are done with that year financial. All the management and everything. So we don't need that data. We will archive that data. Okay, see, we don't delete the data. We never delete the data. Who knows when you might need any of those data. So we archive the data. And in archiving, S3 provide multiple options. So here we have Glacier instant retrieval. Okay, Glacier flexible retrieval. Okay, and Glacier deep archive. Okay, all three of them are used to archive data for data archival. Okay, all three of them are used for data archival. Okay, so now what is the difference between them? See, Glacier Instant Retrieval give you more discount than all of them, but comparatively less discount than Flexible Retrieval, and Flexible Retrieval give you comparatively less discount than Deep Archive. Deep Archive give you the highest discount, right? Deep Archive give you highest discount. Why? Okay, but before let's understand Instant Retrieval. Instant retrieval archives your data. But always remember, whenever you archive data, you don't get access to the data immediately. Okay? Because when you archive your data, you first need to unarchive your data, right? But Glacier Instant Retrieval is that feature of AWS that allows you to access your data immediately. Even though your data is archived, you still get access to the data immediately. Okay? So here also you get millisecond access. See. Okay, here you see millisecond access, right? And now you see, for example, here flexible retrieval. Flexible retrieval means what? Okay, here it takes minutes to hours. Okay, here you don't get access to the data immediately. Here it takes minutes to hours. Obviously, it depends on amount of your data, how much data you want to access, but it's minutes to hours. And finally, deep archive. Now, deep archive give you highest amount of discount, but look at the condition here. Long-lived archive data, and here also you see once a year, but here you see less than once a year with retrieval of hour. So it will not only take multiple hours, even for small data, it will take multiple hours to retrieve data, but it will also take, you also need to access the data less than once a year. Means maybe in 2 years you can access the data once. Okay, so here you see less than once a year with retrieval of R, right? So it takes multiple R even if you have, let's say, MBs of data, right? And finally, here you see reduced redundancy. Ignore this. This is outdated storage class. Nobody uses this. But here you see something new called a standard IA. Standard IA was also not there in EFS. What is standard IA? Standard IA means here, let's say, if you do not know, let's say right now, the example I give you, in that example, we know the pattern of data. We know when we get data, when we not get data, which data is frequently accessible, which is not frequently accessible. We know those things. But what if I don't know the pattern of data? Then what? What if I don't know the pattern of data? Intelligent Turing, just select intelligent Turing, and intelligent Turing will take the decision for you. Okay, what it will do? It will analyze your data access pattern. Okay, and it will move the data accordingly in standard or standard I. If you access the data frequently, it will move it to standard. If you do not access data frequently, it will move it to standard I. But use this when we do not know whether we are going to access data frequently or infrequently. It will analyze your pattern, accordingly it will move. So these are the storage classes. Now, why storage classes is important? Very simple, because it will define cost saving of your account. Okay, so in your project, if you want to save the money, save the cost, this is one of those little approach that you can do that can make a lot of changes, especially in data heavy projects. For example, you are working on big data projects, data engineering. There, this matters a lot. And throughout our course, in almost all the service, you will see there are some opportunity to save the money. That's why it is also asked in interview. Okay, now how to automatically move it? Okay, because we don't want to do this manually. How to do this movement automatically? So for that, you see here we have management, and here we have something called as life cycle rule. What is life cycle rule? I'll show you. Create life cycle rule. Here, just give a name. Let's say demo LCR. Apply to all the object. Now look at this. Transition current version of object between storage class. If I select this option, here you see we can define number of days. Okay, so it starts from standard. Standard is your default storage class. So let's say here I define that after 31 days. Okay, days after object created. So if I upload a file today, so 31 days from today, the file moved to standard IA. Okay, 31 days from today, the file moved to standard IA. Then one more transition. Let's say after 6 months, let's say even if data get deleted, we are okay with it. So let's say after 180 days, here I will select one zone. So after 180 days, what happens? Data will move to one zone automatically. 6 months from today, data will move to one zone. And one more, let's say after a year, we are 100% sure that we don't need this data anymore. So let's say I will move it to directly Dep archive. So 1 year from today, the data will move to Dep archive. Because based on our example also, if there is a data that I use in the given month only, so if I'm accessing that file till the last date of the month on let's say 31st, I'm accessing it. Still from the next month, from the next day, first of next month, I don't want that data anymore. So it is based on object creation. Here we can apply the limits also. Like for example, there is a data, okay, that you know you are going to need beyond the month. So let's say here we can do one thing. Let's say every object will have a tag. Okay, let's say here I have a tag LCR enabled. Okay, so this any object that have this tag that will be considered in the movement of the life cycle. So if there is a data that you think, okay, I don't want to move this data because for some reason we need it, remove this tag. So that object will move from that filter. I mean, you need to remove the tag from the object. Okay, see, here we can limit the scope of the rule using filter. So what it is saying, here I will add a filter, any object that have this tag. Okay, let's say I have 100 object. Out of 100 objects, 50 object have this tag, LCR enabled. So only those 50 objects will move. Rest of the 50 objects that do not have this tag, they will not be considered. Because here I'm defining a filter that whenever any object have this tag, then only move it. Otherwise, if I select apply to all object, in that case, this rule will apply to all the object will be moved. But if I apply this rule that only the object that have this tag, only move those object, then whatever object that is not there with this tag, they will not move. So if there is an object that you want to use beyond this month, then you can remove this tag from that particular object. Okay, right? So yeah, when you work at a at a lead level, when you work at a architect level, not at architect but at a lead level, you are expected to give such solution. You are expected to come up with strategies that will either will improve performance, or they might also save the money, save the cost. Continuing with S3, I told you that in S3 there is a life cycle rule. Okay, what is this life cycle rule? Because see, uh there can be millions of object. Okay, are you really going to move each and every object to different storage class? Are you really going to edit each and every option? Obviously not. Okay, we will not do that. So we want a automated approach. Okay, we want a automated approach where data will be moved from one storage class to another storage class automatically when certain condition is satisfied. For example, if we upload data today, so let's say here I will provide 45 days from today, the data will go to standard IA. Okay, if data is uploaded today, then 45 days from today, data will move to standard IE. Okay, automatically. Okay, it will track the date of object creation or object when the date when the object is uploaded. 45 days from there, it will move the data to standard IA. As simple as that. Then one more transition we can add, or let's say instead of going through all of this one by one, we can directly move to Glacier also, no problem. Okay, you can see you have to go in this sequence, okay, from top to bottom, right? But you can directly jump to some other one. As long as you're following top to bottom, you can jump to directly to last one as well, not a issue. So let's say after 1 year, after 365 days, the data will move to Glacier Deep Archive. Glacier Deep Archive is the archival of data, okay, and it retrieves your data very slowly, and that is the reason why it is giving you that discount. Okay, it archives your data. Even for very small data, it can take multiple hours to retrieve your data. Okay, it can take multiple hours to retrieve that data. Okay, so that's the reason why it also gives you the highest amount of discount. Okay, now so this is about moving current version. Here you see current version is written, and same transition cycle we can apply for non-current version. Now I haven't told you about current or non-current. What do you think is the meaning of current and non-current version? Current version is the, like yesterday we covered versioning, right? Current version is the latest version that we upload. Okay, if you are uploading a file 100 times, okay, if you upload a file 100 times, then 99 versions are non-current version, and the latest 100th version, okay, latest 100th version is your current version, right? So can I say current version will always be only one file? Current version will always be one file, and non-current will always be multiple file. Multiple versions will be there. Very good. So here you see, this is for your current version and this is for non-current version. So here also you can define the same life cycle for non-current version. But here you see, there is one additional parameter you can provide. How many version you want to move? So let's say I upload a file 10 times. So I can say 9 versions, 9 uploads are non-current and one version is the current version. Correct? So here I can define only move 5 non-current version. Okay. So let's say here I define after, let's say 60 days. After 60 days, move 5 non-current version to standard IE. Okay. If you don't define this, all the version will move. Right, but additional parameter we can provide. That's why I told you, when we talk about current version, there will always be one file, and when we talk about non-current version, there can be multiple files. Okay, so now one more thing. Life cycle rule is not about life cycle rule is not only about moving data across storage classes. Okay, it's not only about moving across storage classes, it's about automatic deletion as well. Okay, so for example, here you see, if I let me show you this one. Here is the expire current version of the object. Now here I will define, let's say 100 days. Now what will happen? After 100 day, my current version will expire. Okay, my current version will delete. What will happen when our current version is deleted? Delete marker will be created. Delete marker will be created. Remember when we deleted the version, when we deleted the file, what happened? Delete marker is created. That is the reason why here you see there's a option for permanent delete non-current version as well. Okay, here if you provide, let's say 200 days, after 200 days your data will permanently delete. In 100 days your data will not be deleted, a delete marker will be created and your data will be hidden, but after 200 days your data will be actually deleted. All right, so this is what happens. Okay, so these two things allows you to move data across storage class, and it allows you to delete data automatically. And the last option is for deleting the delete marker and incomplete multi-part upload. Basically, if any upload that failed in between. So this is for that. Okay, not so important because there are very rare chances that you will face any issue where your data failed while uploading. Until it's the issue at your side, but there also AWS handles such exception quite well. Okay, now, is this clear, everyone? Life cycle rule, I'm again telling you, everyone pay attention. Life cycle rule allows you to automatically move the data. Okay, it allows you to do two things. automatically move data across storage class and automatically delete the data. Okay, that's what this lifecycle rule does. Okay, so coming back from here, one more thing I'll tell you in the management section itself. So in management section, we saw lifecycle rule, and one more very important thing, that is replication rule. On this also you can get interview question. Now replication rule is simple. It's all about replicating your data. Okay, replication rule is all about replicating the data. Now understand here, there are basically three categories. Actually there are two categories, but one more I myself added for you guys to understand concept. So in replication there are three categories. First is cross region replication. Okay, or we can say this is a second. First is same region replication, or you can also say cross AZ replication, whatever name you want to give. And the last one is cross account replication. Okay, these are the three kind of replication we have. Okay, so here what happens? First of all, cross AZ replication is free. Okay, this one, first one is free, and not just free, it is default. Okay, it happens by default, and it is all automatic. You don't have to do anything, right? So basically what happens, whenever you upload any data in your bucket, okay, whenever you upload any data in your bucket, that data is I told you yesterday, bucket is at the region level. Okay, so whenever you upload any file in any bucket, that data will be replicated in multiple AZ in that region. So let's say you have a bucket in North Virginia region, and in North Virginia there are 6 AZ, 6 availability zone. So when you upload a file in this bucket, okay, when you upload a file in this bucket, your data will be replicated in all the different AZ of that region. Okay, automatically. And why? Because this gives you high availability. Okay, this gives you high availability, right? So let's say some disruption happen, something goes wrong. So even if let's say few AZs are not available, okay, let's say few AZs are not available, your data will be there in other AC, and you don't have to pay any additional money for this. Okay, you don't have to pay any additional money for this, regardless of number of AZ. Okay, but do you remember we have one zone where we do not get replication? You remember in standard and standard I, your data is replicated in more than 3 AZ. Basically, at that time, this cross AZ replication is what what is happening. Got the point? And when we go with one zone, what is happening? Okay, when we go with one zone, what is happening? It is giving us discount by not replicating the data. Now you'll say, Pratik, just now you said that we don't have to pay any additional money. Then why we are getting discount? See, you don't need to pay any additional money. Your data will be automatically replicated across multiple AZ without any additional money. But when you go with one zone, you will actually get additional discount, because you are opting out from that feature of replication. Okay, you are opting out from that feature of replication, right? For that's why you will get that discount, right? So, but again, to be honest, from practical point of view, I personally, in none of my projects were my domain in which I have mostly worked is finance and banking domain. Okay, all of my projects were in that domain. Uh, at least in my domain, I have never seen not even in single project, I have never seen one zone storage class being used, because nobody want to save so much data, save so much money that they will compromise on data security, right? And I'm telling you from a background where I have worked on many freelance project also, right? Then we have cross region replication. Now this is not free, this is expensive. Obviously this is expensive because you're literally moving data from one part of the world to another part. For example, your bucket is in North Virginia. Okay, your data is there in North Virginia. Okay, now what you will do, let's say you want the same data in India also. Okay, you want the same data in India also. So then you can use cross region replication. So whenever any data comes to your North Virginia bucket, that data will be automatically replicated to your Mumbai region bucket. Okay, so here I'll show you. Okay, so we can set up a rule. Let's say demo rule, replication rule. Okay, so here you see, apply to all objects, same filter that we have seen. Okay, so here I need to select the bucket. Okay, so this 28th June, which is my North Virginia bucket. So this is my North Virginia bucket. Okay, source bucket. So from this bucket here I can choose in which bucket my data will go. Let's say here I will select this bucket from Ohio. Okay, I will select this bucket, or I can select some other bucket. Let's say this one, right? So data from my North Virginia bucket will go to Ohio bucket. Or if I select some other bucket, let me see. If I select this Mumbai bucket. Okay, so as you see, you can select any bucket. Okay, any region. Even you can select another bucket in the same region, right? But now you see we are getting an error. Here you can see we are getting an error. The error is replication requires versioning. Why do you think replication require versioning? Okay, see guys, why it is asking for versioning? Because let's say in your source bucket there is a, let's say, employee.csv file, and in your target bucket there is already a employee.csv file. Now when this replication happens, don't you think in your target bucket that file will get overwritten and you will lose that file that was there in target bucket? Correct? You will lose that file, right? That's why it is asking you to enable versioning in your target bucket. Okay, because in target bucket, if versioning is not there, then if a file with the same name comes from source bucket, then it will overwrite your file in target bucket and you will lose the data. Okay, you will lose the data. That's why it is asking you to enable versioning in your target bucket. Okay, so this is very important. Okay, it's very important to prevent any kind of data loss. Okay, so and here not just that, as I told you, there is one more kind of replication, that is cross account replication. Okay, so these are nothing, these are expensive, they are not automatic. You have to define, I mean they can be made automatic, but you have to create them first. You have to create the rule first, and they are not at all default. Okay, AWS will never give you cross region replication by default. Okay, you have to set it up. All right, and similarly cross account replication. So cross account replication is used to replicate data from one account to another account. Okay, so simply select here, you can see specify a bucket in another account. Now you have here, you have to give account ID. Do you remember where we have came across account ID? Very recently we have seen this. Okay, there we have came across this account ID. Okay, so you can provide the account ID and then your data will be replicated to that particular account ID. For example, in my current project, the product on which we are working, it is spreaded across 3 account. Okay, we are working on 3 AWS account. One account we call it as producer, second account we call it as consumer, and third account is we call it as the central account. Okay, so all 3 of them have their individual work. My team is majorly working on producer account. Okay, but little bit we have to work with sometimes with second consumer account, sometimes we have to work with central account, all of that. Okay, so what I'm trying to say is, in my current project we exchange a lot of data from producer account to consumer account, and sometimes that data exchange happens from bucket to bucket also. Okay, although in my project both the accounts are working from North Virginia, but still. Okay, so in my project, there is a replication rule that transfer data from my producer account bucket to consumer account bucket. Okay, now here there is a very simple logic that if you are replicating data from one account to another account, or you're simply replicating data in your account itself, in your own account, if you're replicating the data from one bucket to another bucket, so naturally you require permissions for it. You cannot do that without any permission. Okay, so for that, here you see we have IAM role. Now what is IAM role? IAM role, right now, just understand, we will have a dedicated session on IAM role, and IAM is one of those very, very important service for you guys, people who are trying to get into DevOps. Okay, so IAM role, right now, just understand, IAM role is all about giving the permission. Okay, so IAM role gives you required permission for you to move your data and transform your data from one place to another. For all of that, you get permission from IAM role. Okay, so here IAM role, here encryption, and here you can also select this destination. By the way, in your source bucket, data is by default encrypted. Okay, previously, few years ago, encryption was not mandatory, but now encryption is there by default. Okay, so here also, while replicating the data, you can choose to enforce additional replication. That when data moves to target bucket, that data will be encrypted automatically. All you have to do is to select this option. That's it. Similarly, here you see destination storage class. Okay, so let's say my bucket is in North Virginia, and just in case I face any data loss. Okay, just in case I face any data loss, to prevent that. Okay, so to prevent any data loss, let's say we are replicating our data in Mumbai bucket also. Now tell me, in North Virginia bucket, I will have my data in standard storage class. Do you think in Mumbai also I need to have it in standard storage class? Yeah, it's a backup, so we don't need to store that in standard. We can keep that in Glacier or any other storage classes, which are cheaper, or maybe let's say one zone, or simply Glacier, right? Why we will keep that again in standard storage class? Okay, data moves across storage class for free. And then you see here there are few options. Okay, these are the additional option. You guys can ignore them, but I'll just tell you quickly. For example, this RTC. This is the only thing that is important. You can say what this RTC will do. Here you see 99.99% of new object within 50 minutes they will be copied. They will be replicated. Okay, so see, when you do the replication, okay, your replication load happens in two ways. Okay, first is there is a historical load. Okay, so let's say you have a bucket in which you have data from, let's say, last 2 years. Okay, you have a bucket in which you have data from last 2 years. Now when you create a replication, when you do the replication, the first replication will take a lot of time, because first replication will replicate last 2 years of data. Okay, but let's say this data is replicated and from tomorrow you are getting new data. So whatever new data that you get, obviously that will not be as big as last 2 years of data. That will be very small data. Okay, so this RTC gives you the guarantee that whatever new data that you get, whatever new data that comes to your source bucket, that new data will be replicated quickly. 99.99% of the new data will be replicated quickly. All right. So rest of the thing you can ignore, not so important. Okay, let me tell you few more things. Now here I'll go to properties. Here I'll go to the last option, static website hosting. Okay, so have you guys ever used the GitHub feature for hosting the website? Basically static website. Then this is similar to that. Okay, and for rest of the people who are new to this, here you see S3 allows you to host static website. What is static website? Static website is basically, you can say, these are the website that where there is no backend, there is no database. Okay, there is no backend, there is no database. Okay, pages does not refresh. Yes, they remain constant. Okay, they do not change on the basis of user input. That is called a static website. So here you see, we just need to click on this and we need to enable this. Okay, host a static website, go with this option. Here in the index document, simply provide index.html. Index.html, for those people who do not know, this is a default, this is basically a nomenclature. This is default name of the home page. Okay, this is the default name of the home page, index.html. And okay, we'll just provide this name and we will click on save changes. Okay, now once you do this, now all you have to do is to upload your website file. Okay, so upload here your static website file. Okay, so I do have some static website file. Let me upload them, just a second. So here you see I am uploading all of this file. Okay, you can see multiple files I'm uploading. Total 44 files across different folders. Okay, so all of these files I'm uploading. Right here, I'll click on upload button. Okay, now let's wait for it. Okay, so here you see files are uploaded. Now if I go back to this bucket, here you see my website files are uploaded. Now what happens is when you enable static website hosting, these are the website file. They contain website code, HTML, CSS, basic JavaScript, all that. Okay, so here you see, I uploaded all this file. Now if I go to the properties here, now you see, when you enable static website hosting, okay, when you enable static website hosting, what happens is here you get this URL. Okay, you get this URL. If you go to this URL, you will see your website hosted. But we are getting access denied error. How to solve this? Remember, I made all those, I made that file public by enabling the ACL. Okay, now understand the problem here. Now we have 44 files. Can we really make all the 44 file publicly available? Can I really do that for each and every file? Obviously not. I will not do that. Right? So here we go with something called as IAM, which is a modern approach to make your data publicly available to manage the security of your account. Okay, we go with IAM, and for that we need a policy. So pay attention here. I'll go to permissions. Here I will go to bucket policy, and here I will edit this policy. Okay, now look at this. So what I'll do here, you see, here bucket policy we need to provide. Now here is the policy generator. Okay, so you don't need to write JSON code. By the way, I'm giving you guys, all of you guys, a assignment, homework, basic homework. Those people who do not know IAM, and surprisingly many people don't know. Not IAM, sorry, JSON. Those people who do not know JSON, please understand JSON. Okay, use any resource, use blog or use website, or any, watch a YouTube video, but understand JSON. Okay, and it takes hardly 15 minutes to understand JSON. JSON is such a easy thing, it can be understood in 15 minutes. Okay, so what I'll do now, here I'm creating a policy for my S3. So here I'll select S3 bucket policy. So here you see, I'll go with effect allow because we want to give allow policy. Okay, here in principle I will give my bucket name. Here I will give my bucket name. Okay, and here in the action I will give permission for upload, or I can give all the options, or simply get object. Okay, because we want to view the object, right? And here, okay, let me give this in resource. All right, and we will generate this policy. Again, as I said, don't worry about this. Add one or more statement. In principle also, let me give asterisk, so it will allow everyone. Generate policy. Okay, now look at this. I will copy paste this policy. Okay, see, this is what I want to show you. Here I will provide this policy. Okay, now when I provide this one policy, I don't need to worry about making each and every object publicly available. Okay, okay, why ACL is an outdated approach? I told you that if we go with ACL approach, then we'll have to make each and every object public. We uploaded 44 objects. Can we really make all of them public? No. But when I provide a simple policy like this, just wait and watch. I'll save this. Now if I go to this URL and if I refresh, this should work now. And now you see all of it is working. Now you can go to any page, it will work. Okay, we uploaded 44 files. Did I make any of them public? No. But a single policy like this did all the job. That's why this is so important. Okay, that's why ACL is outdated approach. You don't need to remember this code. We will see how to create such code. Don't we need to assign? Yeah, we assign the policy. Here you see, we just simply created, okay, I get it. So this is called as resource policy, right? Resource policy is that policy that can be attached at the resource level. Okay, so if I just provide the policy here, that is more than enough. That is done. Okay, so everyone look at this. Right now I just showed you two things. First of all, your website is hosted here on S3. Okay, you don't require any server, you don't require anything. Okay, so here you see our website is hosted. Now if you look at this clearly, you will understand we don't require server for this. But why? Because it's a static website. For static website you don't require server. Okay, static website does not require any CPU, RAM, memory and all. For that S3 is enough. Okay, and then you see here we also studied that instead of going with longer approach or limited approach like ACL, if we provide policy like this, it can do the entire job. And we will cover this in depth. Okay, when we get into IAM, there we will see what else we can do using this bucket policy and all. It's a very big concept, we'll understand there. And there are many complex stuff you can do with it. So when we get into IM, there we will cover this in depth. I just wanted to guys see some demo. I wanted you guys to understand why ACL is an outdated approach. Okay. Now we will move to another module, that is database module. And here we will cover RDS service. If I show you in database module, you will see there are many database services. Do we need to know all of them? No. Okay, there are only few database services that are extremely important and we need to know them. Okay, but the one that we are going to start with is this RDS, the one of important course. Because always remember, in any application, database is the most critical component of any application. According to you, what is the difference between? Okay, good. See, storage is only storage. Okay, database is a storage plus process. Right? Storage is only storage. Database is a storage plus processing, or you can say storage plus. Okay. So when you add data, like for example, your business data, like for example, let's say, let's take the example of Intellipaat. Okay, e-commerce brand. Sorry, not e-commerce. EdTech brand. Okay, for a EdTech brand, where do you think all the all the information of student, all the information of trainers, all the information of trainer, student, and courses will it be stored in your storage? No, that will be stored in database, because from there we can extract the information whenever. Okay, everyone. So storage only store the data, but database store the data in a way that can be extracted later on. Okay, you can retrieve the data. All right. So here you see, now RDS is a AWS service that can be used to create relational database. What is relation? Come back to the point. Now, if you guys have heard about Oracle database, MySQL database, MySQL server, Microsoft SQL Server database, PostgreSQL database, these are the database. Uh, they are the relational database. Okay, relational database means what? Okay, you have, let's say you are working for an e-commerce brand. Okay, so let's say there's a products table that contains all the list of products and their detail. There is a customers table. There's a orders table. Now orders table is connected with orders table. Let's say is connected with customer table, and it is connected with product table. Okay, which customer ordered which thing at what time. That is the order table. So order table directly have a relation with customer as well as product table. So this is called as relational, right? Now, whenever you want any relational database on AWS Cloud, your answer is RDS. Okay, so here we are going to create a database just like while creating EC2. We went through a form where we provided all of our value. Okay, then we got the database. Same thing we will do. Okay, so here you see, we are going to create a database. And while creating database, here you see the very first thing you see, here all the different options are there. So these are all the only databases that are supported. Right now, ignore. Okay, this Aurora that you see here, we will cover later. What is Aurora? Aurora is a part of RDS, but it is very different, so we'll have to cover it separately. But you see, rest of the databases are the one that we get. Now tell me, don't you think it reminds you of EC2? You remember the very first thing in EC2 that we did was to select the AMI, select the software. Coming back, now here you see the exactly same thing we saw in EC2 also. The very first thing we selected in EC2 was AMI, the software part. Whether we want Linux server, whether we want Windows server, and exactly same thing we are doing here as well. Here we are selecting the database engine type. Whether we want MySQL database, whether we want Oracle, whether we want PostgreSQL, MariaDB, IBM DB2, all of them are popular. These are the most popular databases in the world. Okay, so which database you want? That is basically the database engine, DBMS. Okay, for example, we will go with the most popular one, and that in my preference is MySQL. Okay, MS SQL belongs to Microsoft, Oracle belongs to Oracle. Okay, the rest of them are different. Some of them, they are publicly available. Okay, so we will go with MySQL, one of the most commonly used database, right? So MySQL will select this. So here we selected our database engine. Now, before I move forward, I will ask you guys one question. Tell me one thing. So I told you, whenever you want any of this database, okay, EC2. As I told you, EC2 is nothing but a computer in which you can do whatever you want. So here, what is happening in RDS? Okay, what is RDS? In RDS, you are getting the server in which database is already in. Okay, in RDS, you are getting a server in which database, right? So in EC2, we will get the same thing if you do it automatically. Sorry, if you do it manually. In EC2, everything, whatever you see here, whatever we are going to see here, everything you have to do manually, and many of these things cannot be done, to be honest. Okay, so like for example, here I select MySQL. That's it. I just select this, we will get it. While in EC2, you'll have to download the MySQL, you'll have to install it, you'll have to configure it. Everything is your responsibility, right? So EC2 is the answer. Now, which one to go with? Obviously, we go with RDS. Why you will go with EC2? If you go with EC2, everything is your responsibility. You have to do the entire management, and you cannot do that much, to be honest. Okay, you cannot manually take regular backup. You cannot take care of encryption and security and all. You cannot do all, right? Rather, what should we do? We can go with RDS, where we will get everything by default. So before break, we saw that while creating RDS, the very first thing we have to do is to select the database engine. Okay, why we need to select database engine? This is basically what will define which database do we get. Okay, do we get MariaDB, do we get Microsoft SQL Server, or whatever? Okay, once we select our database engine, the software part, here we can select its version as well. And you will see most of the latest version will always be available, right? So you don't have to go with any previous or older version. Then you see here, okay, I'll show you. This part also I'll show you. So here you see there is a template. There is something called as template. Now, what is this template? Template here simply means, you see there is a free tier template. Okay, so if you are just practicing with RDS, okay, if you're just learning, you can go with that free tier template, right? But in real world, obviously we go for production or we go for dev and test. Okay, obviously while deploying in production, we go with production template. Now, what is the difference? In production template, you will get all the features. In dev and test also, you get all the features. But in free tier, since it is free tier, you don't get all the features. Okay, you don't get all the features in free tier. Most of the features are not available, right? So don't worry, you don't need to create production database. We will create free tier database, but we will see all the feature of production, because that is what the real learning contains. Okay, so we will go with production template. Now in production template, you see, the very first thing is, if I go with this, here you see availability and durability. And in your entire RDS, this is the most important. Okay, availability and durability. This is the most important topic in your entire RDS that we are going. Okay, now what exactly is this? Availability or high availability simply means, if your database or your resource, anything, server, storage, anything, if something goes down, okay, if some issue happen, if something goes down, then is it still available for your customer to use, or it is completely gone? Okay, so for example, if I store only one copy of data, and if something goes wrong with that one copy, then then obviously I will. Okay, but if I have multiple copies of that same data, then even if one copy goes down, I can still get my data from. All right, so what is happening here? You see, see, SSD is solid state drive. We already covered that. If you remember, we SSD we saw in EBS, elastic block storage. Okay, so you see the very first, deployment option. Deployment option is the most important concept. Okay, you will definitely get, if RDS comes in your interview, you will definitely get question. Okay, you will definitely get question on this. So what is this deployment option? The very first option you see here we have is single AZDB instance deployment. This one. Now what this option will do? See, I'll tell. We have a region. Okay, this is our region. Now in this region, here we will have, let's say, one AZ. There are no interview question. There are topics. I said you will get question on this interview or on this topic. Okay, so understand the topic. Question can be, anything. Any person can ask question in any different way. Okay, so what we have is, here we have a region, and in that region we have, let's say, 2 AZ. Now if you go with this option, this single AZDB instance option, if you go with this option, what do we get? We get one database. Okay, this will be our only database, primary database. We will have only one database along with its storage in this one AZ. Do you think this is highly? No, it is not highly available. Because if something goes wrong with this database, your entire database, if something goes wrong with this primary database, your entire database is gone. It is down. And if something goes wrong with this AZ, then also, okay, so there's a problem here. Right? So what we do now? Here you see, it's a problem here. Now we can go with this second deployment option. Okay, what do we have here is, this is called as multi-AZ DB instance deployment. Okay, multi-AZ DB instance deployment. If you go with this option, what will happen? If you go with this option, you get one more database, that is one more standby database in another AZ. Okay, this is called a standby database. It's not a primary database. It's a standby database. Okay, you get one more standby data. You get one more database in another AZ, and that is your standby database. Now, is this highly available? Obviously, it is highly available. 100% highly available. Because if something goes wrong with this database, primary database, you can rely on standby database. Okay, you can use your standby database. And this is what happens when the request, let's say you have a website hosted behind the scene, this database is there. So when a request from your users, okay, when the requests from your users are coming to this primary database, okay, and if something goes wrong with this primary database, or if something goes wrong with the AZ, okay, what will happen? AWS will redirect all the requests from primary database to, right? Your AWS will automatically redirect from primary database to standby database in 1 or 2 minutes. Okay, so we can say this is highly available because we not only we have two database, but we have this two database in different, right guys? Said Ravi. So guys, here, if you want your users to be redirected to standby database, don't you think your standby database need to have the same data as primary database for it to replace the primary database? Yes, obviously. So there is a constant replication happening from primary database to standby database. So whenever any request or any data comes to primary database, there is a synchronous replication happening from primary database to standby. Okay, a continuous replication. Okay, a continuous replication is happening from primary database to standby. So as soon as primary database gets any data, standby database will also get the. Okay, it's a sync. Okay, so but understand, standby database is a read only. Okay, so for example, when your primary database goes down and your standby database takes over, Okay, standby database cannot accept new data. Okay, see, you can read data from primary database, you can write data into primary database. But when it comes to standby, there you cannot write data. You can only. Okay, so my question is, do you think by the additional of the standby database, it will? Yes, correct. It will improve the high availability. Next question. Do you think by the addition of standby database, will it improve performance of our database? Okay. See, the reason why it will not give performance improvement because at a time there is only one database is active. When do you get performance improvement? When at a time multiple databases are there and your data, your incoming queries or load is getting shared among those two databases. But here what we saw, when primary is active, standby database is in standby. It's not running. It's just getting the new data. And when primary goes down, then standby database take over. So at a time, only one database is active. And if at a time only one database is active, obviously you will not get any performance improvement. You get performance improvement when both the databases you here. Do you think this is fault? Okay. Now here I'll tell you something. Here many people who have good years of experience, even they make this mistake. This is not fault tolerant. Why? You remember earlier I told you after 1 or 2 minute request will be redirected to standby database. When primary database goes down, after 1 or 2 minute request will be redirected to standby database. Okay. When we talk about fault tolerant, this is handling failure. This is handling fault. But generally, when we talk about fault tolerant, what do we expect is we expect that when primary database goes down, immediately requests are redirected to standby database. Or maybe not immediately, but in at least in few seconds. But if it is taking 1 to 2 minutes, then that's a very long period of time. Okay, then you cannot say it is fault tolerant. Okay, if it is taking so much time, then it is only managing the fault. It is managing the failure. Okay, fault tolerant involves you take the you deal with it immediately. That is the meaning of fault tolerant. So this is not fault tolerant. But yes, it depends. This definition is also a little bit, it's contextual. For example, let's say in your product, for your product, let's say 1 to 2 minutes is totally fine. It is totally okay for you. Then you can say for your particular use case, see, standby, when your request redirected to standby, it takes somewhere around 100 seconds, you can say. Between, okay, anywhere between 60 to 120 seconds. On an average, you can say 90 to 100 seconds it takes for your request to be redirected to standby. Fault tolerance means handling the failure, handling the fault immediately without any disruption. But here we have a disruption of 1 to 2 minutes. Okay, so it is handling the failure, it is handling the fault, but not without disruption. Disruption is there in, right? Okay, so now I will tell you one more thing, one more deployment option, and that next deployment option is this multi-AZ DB cluster deployment. Okay, in this option, what happens? In this option, you have one more AZ, you have one more standby database. Okay, so can I say here we get even more high availability? Yes, very good. But look at this. Here you see, here you get non-readable standby instance. Here you see, you get two readable standby instance. You were talking about that we can redirect request here. This is possible in this scenario. In this multi-AZ DB cluster, in this cluster option, it is possible. Because in cluster option, while your primary database is running, your standby database are also running. They still support read request. They do not support write request. Okay, these are readable standby instance. They support only read request. But they will support it at the same time while primary is running. Okay, so when your primary is running, both the standby database are running at the same time and they will accept read request. What is the benefit here? Can I say now here we get performance improvement? Now here there's a chance of getting. Yes. So here you will get performance improvement, because always remember, in any database, in any real world database, always remember, read requests, see, write requests are always more heavy. Okay, write requests are always more heavy than read request, but read requests are always more. There is no right option, as I said. So if your primary goes down, then there will be a downtime for write request, as simple as that. You can't always have all the best thing. You can't always have all the read requests and write requests. Then what is the purpose of, right? So if primary database goes down, there will be a downtime, no doubt about it. Okay, what is the use? Don't you think when primary database is down, your customer are able to read their existing data? Don't you think? When my primary database is down, okay, we are not able to write the new data, but I'm able to, my customers are able to read their existing data. Their existing data they are still able to read. That's a huge benefit. That is the entire. Okay, so obviously this deployment option is the most expensive one. Okay, here you get a guarantee of 99.995% uptime. Okay, increase read capacity, reduce write latency. Okay, so these benefits you get. Okay, so overall this will not only give you even more high availability, but it will also give you a lot of performance. Okay, then you see here cluster identifier. Here we can just provide name for our database. So let's say I'll provide RDS database. Okay, identifier is nothing but a name of your database. After this, here you see, if I go down, here we need to provide the credentials. Credential, here you see username, we can provide admin. Admin will be our username. Then we can provide our password here. So here if I select self-manage, here we can provide our password. Obviously, we need to provide password because credentials are required here, because database, as I said, is the most critical component in any application, in any pipeline. So obviously it is protected through credential. What is the difference between cluster deployment 3 AZ and instance 2 AZ? You are asking between them. Basic difference is there. Here you have 2 standby, here you have 1 standby. Another difference is in the cluster option. See, it is called as cluster because it's a collection of multiple nodes. It's a collection of two, but here you have only one instance, primary instance, and you have here only one standby instance. That's why it is called as instance. But here, since multiple instances are involved there, more than 2 standby, so whenever you have collection of server, it is called. Okay, so here you see, here we provided credentials. So this will be our username and password that will be required for us to connect with our database. Okay, that will be required for us to connect with our data. All right. So this is what we need to provide when we are trying to access our database. Okay, now moving on. So you remember when we covered EC2, there we selected first AMI, which were part. Then we selected the hardware. Do you see? Yes. You see here we have all this instance type, right? And you see all this instance type, they start with DB dot. What is the meaning of it? Why do they start with DB dot? Here simply means one thing, that they are specialized for database. Okay, all this instance type, they are specially made for instance type. But here, when you go to RDS, here you will see only those instance type that are optimized for databases. Okay, so you can select the one according to your requirement. Then you see in EC2, after we selected instance type, then we had storage option also. Okay, we had storage option also where we selected our storage. Okay, so here you see, we can go with general purpose, we can go with provision IOPS SSD, we can go with any one of them. Okay, obviously here we have not, we don't have that throughput option and all, but here we have general purpose and provision, right? So here you see allocated storage 400 GB. You can go with whatever value. Let's say I will go with 4 GB. Here you see provision IOPS. Okay, so the same option that we had in EBS. Right now, here understand this one thing. When we covered EC, at that time, if you remember, in EC2, we had auto scaling group to scale our, right? We had auto scaling group. Now, do we have any way to scale our, can we auto scale our, okay, we have nothing like auto scaling group to scale. Okay, here you can scale only, okay. So somewhere here, yeah, there is option here. Okay, so you see enable storage auto scaling. Now, even though my allocated storage is 200 GB, still my storage can increase up to 1000 GB because that's what I have defined here. Okay, so when 200 GB is not enough, the storage will automatically increase. I hope you got the point. When 200 GB is not enough, it will automatically scale to 100,000. Okay, if I don't select this, then it will not increase. It will stuck at 200 GB and you won't be able to add more data. But yes, you don't get auto scaling for the entire RDS, but you get auto scaling for the storage part. Storage part can auto scale. Right? So this was about hardware part. After that, here is the connectivity. Then you see here, we have an option to connect to an EC2. Okay, now this option was not there I think till last year, this option was not there. So basically what happens when we have our database, we connect with our EC2 with from our EC2 with that database by using some tools or library. We connect with the database. But now AWS provide that option directly. Here you just need to select your EC2. Whatever EC2 you select, AWS will form a connection between this EC2 and that database. But my recommendation is don't use this feature. First, do this on your own manually from, okay, then try to go with this feature. Okay, if you want, you can use ChatGPT, but try to. Okay, then here we can select our VPC. If you remember, when we covered VPC, I told you that database is a kind of thing that we keep in. Okay, so here is our VPC. Here is our subnet. Public access I will keep yes, because I want to show you how to connect with database. Then you see here firewall. So obviously security group is a server level. Okay, security group is a server level. And what this security group firewall is a firewall around your server, and it blocks any kind of unwanted, right? So obviously here also we are having a server, we have a database server, so there will be a firewall is here. Then here RDS proxy, it is allow you to connect with your database securely from your your password can be stored somewhere else, and from there you can connect with your database. So these are the certificate of authority. It's your security certificate. Then here you see, if you want, you can provide tags. Here we can provide authentication. Now look at this. This password authentication is nothing but the password we provided earlier. If you remember, earlier we provided user, right? So if you go with this, we just need to provide, whenever we access our EC2, we need to provide our username and password. But then here we have this password and IAM database authentication. If you go with this feature, you need to provide the password, but you also need to be a valid AWS user. You also need to be a valid. Why? Because both the things are required. If you know only password, but if you are not a valid IAM user, you are not a valid AWS user of this account. But if you are a valid user and if you don't know password, then also you don't get access, because you need both the things. Okay, and finally here Kerberos authentication is nothing but here you can connect Active Directory of.
Just a quick info, guys. Intellipaat brings you executive postgraduate certification in cloud computing and DevOps in collaboration with I have Divya Sampar, IIT Roorkee. Through this program, you will gain in-demand skills like AWS, DevOps, Kubernetes, Terraform, Azure, and even cutting-edge topics like generative AI for cloud computing. This 9-month online bootcamp features 100 plus live sessions from IIT faculty and top industry mentors, 50 plus real-world projects, and a 2-day campus immersion at IIT Roorkee. You also get guaranteed placement assistance with 3 Azure job interviews after entering the placement pool. And that's not all. This program offers Microsoft certification, a free exam voucher, and even a chance to pitch your startup idea for incubation support up to rupees 50 lakhs from IAP Divya Sampark. If you are serious about building a future in cloud and DevOps, visit the course page linked in the description and take your first step toward an exciting career in cloud technology.